Hello my friends, my name is James and welcome to this second edition React.JS full course where we go from being absolute noobs at React to super wizards in the React.JS framework. Now I'm super excited to have this course live on the internet because ever since I personally struggled to teach myself React.JS, I have wanted to create a course that not only teaches you everything you need to know, all the foundational knowledge and concepts that are required to become a React.JS pro, but it also teaches it in a manner that is super digestible. The progression is very gentle, and that means that anyone with any experience level in React can comfortably follow along with this course. And if that weren't already good enough, should you get to the end, not only will you be left with a portfolio of amazing projects that are of the caliber needed to get you hired as a React.JS developer, but you'll also have all the resources, all the knowledge you would need to go and build your own absolutely amazing software for the internet. Literally, the stuff we learn in this video takes you 90% of the way to developing software like this one that I personally own and operate. All of the authentication, the databases, the user interfaces, it is all covered in this course. Now this course is obviously second edition. There's already a popular React.JS course available on my channel, but I got some constructive feedback on that and I decided I could do one better. So the core differences between this course and the previous one, first up is the projects. The projects in this course are specifically designed so that each one, once again, is a very gentle progression from the last. That means that anyone can get through the whole course, build all the projects, and every project is a slight progression from the previous one until we get to the last project, which is relatively advanced, super comprehensive, and it's really amazing for consolidating everything we've learned across the first two projects, plus it introduces some new concepts. Furthermore, the other massive change in the last course, we spent some time styling everything. And for someone who's trying to learn React, maybe that's not the best use of time. So all the projects that we will be building in this course are pre-styled. There's going to be no styling in this course. Everything is complete. So at the end, not only will your projects look absolutely phenomenal, but we can spend so much more time focusing on all of the React.JS concepts and coding best practices that you need to know to become a React.JS pro. So it should be absolutely wicked, loads of fun. It's a weapon of a course. And if that sounds good to you, let's take a look at exactly what we'll be building in this React full course. So here's a quick demo of the three projects we're going to be building in this course. First up on the list is the humble to-do application. Now this is a brilliant application because as much as it's super simple, it has a lot of utility in day-to-day life. It's super fun, and most importantly, it demonstrates many of the foundational concepts that we'll need to advance to some of the more complicated projects later in this course. Now the way that this to-do list works, obviously we track the number of open tasks. In here we've got three different tabs that let the users show all their tasks and organize them. And here's an example of what a task looks like. These two are complete and they have two options where we can either delete them or tell them that they're complete. So I could have one here that says finish this React.JS course. Now I can go ahead and click this add button that is added to our list, and that is now within the open tab. Now obviously this project is super mobile responsive, it looks absolutely great, and it also is styled for light theme as well. It looks good in both themes. And in this particular case, once we've finished this React course, we can select done, and now that has been added to our all list, and we could go ahead and delete it. Now the other cool thing about the to-do list is that all the data is locally persisted, which means that when I refresh the page, everything is still there, it's not refreshed, and it is persisted or cached across page reloads. So that looks absolutely brilliant, and that is project number one, styled using FantaCSS and deployed live to the internet. For project number two, we're boosting up the complexity and we're learning about how we can integrate APIs to our React.JS projects. And in this project, we are building out a Pokedex. So just here on the left-hand side, we have a nav that allows us to select from all of the 151 Pokemon in the original Fire Red and Leaf Green Pokemon series. The search bar works really well, where we can either search by the Pokedex number or we can search by the name of the Pokemon. And obviously, if we wanted to swap Pokemon, we can click on a different Pokemon, we get a new selection state in the side, and we load in all the information about that Pokemon. Now for this project, we use the Pokedex API, and we also learn how we can cache information in our project using local storage so that we don't overwhelm the API with network requests and constantly refetch the same information. Obviously, we have 4 nice images just here, and if we scroll down, we get some stats about the Pokemon, and we can also see the different moves that they are capable of learning. And if we go ahead and click on one of these moves, it loads a description that opens up in a modal overlay for this project. Here we can see that this move is called Sunny Day, which boosts fire type moves for 5 turns. I could look up Defense Curl, that heightens the user's defense. Leech Seed, that steals the HP from the foe on every turn. Now the other cool thing about this project is that the mobile responsivity works slightly different. So obviously when we drop it down to a mobile device size, everything looks super clean. Obviously it works well in light mode and dark mode as well. But furthermore, we also have a side nav that pops up and goes away. So just here, if I click on the little menu icon, it pulls up the side nav. We can scroll through all the Pokemon. I can then click on Bulbasaur and we swap back to Bulbasaur. Or I could come down to Articuno, which was my favorite Pokemon, and we can load in the information about Articuno. We can see that it's ice and flying type, get some moves, see that it can learn Bubble Beam, look at that move. And the other cool thing is that when we click the modal underlay, which is this blurred out screen behind the actual content in the modal, that exits out of the modal. So that is project number 2. It should be loads of fun live on the internet. And project number 3, saving the best for last, is Caffeine, which is a coffee tracker. Now these first 2 projects only save data locally, whereas in this third project we learn how we can add authentication and database functionalities to our React.JS applications using Firebase, which is Google's backend service. And the way that this project works, Caffeine is for coffee insatiates, is we start off building out a bit of a hero section that tells people why they might want to use the application. And then we let them fill out a form that lets them track all of their coffee entries, how much they cost, when they consumed the caffeine. And what we do is we then give them a whole lot of statistics about their coffee consumption history. So the first thing we tell them is we use the half-life of caffeine, which determines how quickly caffeine is metabolized in your bloodstream. We calculate the current amount of coffee in their bloodstream based on their coffee history. We give them some other cool statistics. We tell them how they might be feeling, what their caffeine warning level is. We keep a record of their favorite coffees, the cost per day, the average number of coffees. And then at the very bottom, we keep track of a history, which they can kind of tally up over time. And if we hover over an entry, we can see that this was a double espresso. It was taken 8 minutes and 41 seconds ago. It cost $21 because of the crazy inflation. And our current caffeine decay in our bloodstream is 123.5 milligrams out of the original 126. So it's a super cool application. We've also got some conditional rendering. So if we want a different type of coffee, we then get this huge drop down with loads of different options that the user can select from. Obviously, once again, the application is super responsive. It looks great in dark mode and light mode. And we've got the super cool authentication handling system. So essentially how that works, I just logged out. Now all of the history is gone because obviously if we don't have a user logged in, we don't have any information to display. And if we get a new user coming to our page who isn't already authenticated, if they try to add an entry, we tell them to sign up, or they can sign up using this call to action button right here. We can handle their user registration or user logging in. And if they log in, let's just use the test information that we did in the project. testemail@gmail.com was the username. We have some password handling systems. We can then authenticate them. And now they are a logged in user. We fetch all of their information and that is available to them. Furthermore, the authentication is super smart so that if I refresh the page, that's obviously saved. I don't then have to re-authenticate. And this would be the same if I logged on a new device. All of that information is persisted forever. So they're absolutely brilliant applications. As I said earlier, when we've built all 3, you can have the code live on your GitHub. You can show prospective employers And once again, these projects are so clean that they will comfortably land you a job as React or full stack or front-end developers. Now, as for the prerequisites for the course, what you need to know to be able to breeze across the finish line, it's pretty simple. First up, it's some HTML and CSS. That's just essential for any good developer to know. And secondary is JavaScript. React.JS is a JavaScript development framework, so at its core is a lot of JavaScript. And if you need some material to brush up on any of those topics, I have courses for each linked in the description down below. Now, what do you do if you get stuck while you're progressing throughout the course? Well, I've got you covered there too. First up, all the code is available on GitHub. It will be linked in the description down below. So at any point, you can always compare your code to mine, see what might be wrong, resolve any bugs, issues, or errors. Furthermore, if you have any questions, qualms, or queries, you can leave them as an issue on the GitHub repo, and either I myself or someone will come and respond to you and help you understand whatever it is that you may be struggling with. Furthermore, there are also some cheat sheet notes available for HTML, CSS, and JavaScript linked in the description down below. So if you want to have some handy guides there for you, they are available too. And finally, for members of the YouTube channel, there's also a Discord available where I'm super active. You can ask any questions there, and I will get back to you as soon as possible. And with that all said, it is finally time for us to embark upon our mighty adventure to becoming React.JS wizards. It should be a super exciting journey. I cannot wait to share it with you. And as always, if you enjoy the course, don't forget to smash the like and subscribe button so that I can continue to feed Doug a healthy diet. All right, it is now time to dive into project number 1, which is the humble To-Do app. This project teaches us all of the foundational, fundamental concepts we need to know in React to progress onto the latter 2 projects in this course. So, to get started in React, you're going to need 2 things available on your computer. Number 1 is VS Code, or our code editor. In this case, if you don't have it installed, you can find a link to install it in the description down below. And likewise, you will need Node.js, which you will be familiar with if you have been introduced to JavaScript, which is one of the prerequisites for learning React.js. The link to install Node.js is also available in the description down below. Now here I have a blank window of VS Code open, and what I'm going to do from this window is hit the open key right here, navigate to the directory where I keep all of my coding projects, and create a new folder called React.JS Full Course. Now if I go ahead and click create, that's going to create the folder for us, and within here we can hit the open key, which is just behind my head right here. And that will go ahead and open up the project directory inside of VS Code. So here on the side, we can see we have our Explorer window. This is where we're going to have all our folders for our 3 different projects in here. And the reason we're opening up VS Code is so that we can get access to the terminal, which is available by hitting the control backtick key. If I go control backtick, that opens up a terminal for us. Equally, you can access the terminal by toggling it using the VS Code options, or you can open it up via the folder file options available inside of VS Code. Lots of ways you can open up a terminal. Now, the reason we're getting a terminal up and running is because we're going to need some node commands to initialize our React.js project. Namely, the one right here that is available within this Vite.js guide. Now, if you're not familiar, Vite is just a really fast build tool that we can use to configure and initialize our React.js projects. Now, this is linked in the description down below. And within our React.js full course terminal folder, what we're going to do is type out that command, npm init Vite at latest, just like that. And then after that command, we're going to have a space separation, and then we're going to name our first app, which is the To-Do app. If I hit enter, that's going to give us some options to configure our Vite or React project. We're going to select the React.js framework, and we're going to select JavaScript. Now all we have to do from here is follow these instructions right here, and we will have our project up and running. So I'm going to go ahead and do that. We're going to cd into our To-Do application. we're going to run npm install, hit enter there. That's going to install our application. Note the effect the change directory command had. It changed the directory where we're installing our project. So here over in our folder explorer, we now have a folder called the Todo App, and within it we have our entire React.JS boilerplate for our new project. Now the last thing we need to do inside of the terminal is run this final command. We're not going to do that just yet. We're going to start off learning a little bit about React, look at some of the folders and files that we have available here, understand what they do, and then also configure some things before we dive into our project. So first things first, what on earth are we actually looking at? Well, let's start off at the bottom. First up, we have this vite config file. We don't need to touch that. That's just part of the vite configuration for React. Above that, we have the readme.md, which will be available in the GitHub repo. This will be updated by the time the course is released. And it's just some information that we can provide people who look at the GitHub repo, which if you haven't yet, you should be sure to start the project. Super appreciated. And it will just have some information about the course. If I was in your shoes, I would get into the practice of writing up a neat little README for your own projects where basically you detail the problem you're trying to solve, you explain how you are trying to solve it, and, demonstrate the final solution. And that can be a good thing to do if an employer is looking at your repos. Above that, we have the package.json. Now, if you're familiar working in Node.js with JavaScript, you'll know that the package.json essentially just specifies some configuration information about our project. So here we can see we have the name, we've got the version, the type, we've got some scripts. These are going to be important to us later. Scripts are scripts that we can run from the terminal, and the name of the script, when we call this script, it executes this command. We'll see how that works shortly. Underneath that, we have some dependencies. Dependencies are the packages or npm packages that our React.js project relies upon. In this case, we have React and React DOM. In this very first project, we actually won't need any additional packages, so that's not something we need to worry about right now. And then we have a whole lot of developer dependencies, which are specifically things that our project is dependent on in the development phases. So that's a pretty cool file. We're once again not going to be touching it very much. After that, we have the package-lock.json. Now, if it wasn't explicit enough, the -lock means that it's locked from our dirty little fingers. We're not allowed to touch it, and you risk breaking stuff. So best if you leave this file alone. Now I'm going to skip over the index.html because I'll come back to that in a second. After that, we have the ESLint. Don't need to touch that. A whole lot of random information. We have the .gitignore. This is important if you want to prevent any of the folders, files, or information in your project being pushed to a potentially public GitHub repo so that maybe you don't expose any API keys. Not going to be an issue for us in this project, but we'll learn more about it in the last project specifically. And at the top here, we have the node modules file. That's just all of our npm packages where they get installed. We don't need to go digging around in there. Then we have the public directory. The public directory is used for serving up any assets associated with our project. That could be images, fonts, videos, audio files, all that kind of stuff. A super useful folder, one that we will definitely be using throughout this course. And then we have the source directory. This is where all the magic happens in our project. Now inside of the source directory, which I've opened up, we can see it comes with a whole lot of files. And when you use the vite installation of React, they actually give you a functioning React.js project. So if we come into the app.jsx, where .jsx is the extension for a React.js file, we'll learn all about that shortly, we can see there's a whole lot of code in here. And this is code for the boilerplate project that comes when we install React. We're going to gut these files clean very shortly, but it's just something interesting to be aware of. Now, if you're completely new to React, let's just take a second to understand exactly how everything works. React is a JavaScript framework, where what that means is we use JavaScript predominantly to develop web applications. If you use vanilla web development with HTML, CSS, and JavaScript, you code in HTML and CSS and then you add the JavaScript last. That's great for a lot of projects, but when you have an application that's extremely dynamic, it's often much easier to code everything primarily in JavaScript and then throw in the HTML and CSS at the end, which we'll see how that works shortly. Now, the most important files in our entire React.js application are this app.jsx, which is a React.js file. We can see the little icon there, the main.jsx, and this index.html. Now, if we start off with the index.html, it's actually a relatively simple file. It's literally 13 lines of code. And if you've developed in HTML before, this should all look pretty familiar to you. Basically, we have an HTML document. We've got the head of our document, which has some meta information about our page. And then we have the body of the document right here. The body obviously contains all the visible information on the page. Yet if we look inside, we note that it only has a singular div with an ID of root, and it has a script. If we look at where that script is coming from, it's actually this main.jsx. So this React file right here is the script being run inside of the body. So if we jump across to that file, let's take a look at what we're looking at. So up the top right here, we have this first line of code. It's not really relevant to us too much. The second line of code is quite interesting though. Essentially, what it's doing is it's saying document, access the document, which is this index.html here, this HTML document, get the element by the ID. So that's the ID of root, if you remember, that's the div right here. And then what it's doing is it's saying inject our app, inject our React application into this HTML. So our entire React application via this script right here gets thrown into this div. Now this is all very high level. It's not really critical that you understand this, but it's just good to be aware of. Now we see right here that we have the entire React app being injected into that div. The app comes from the .app.jsx file, and it's referred to as what is known as a component. This is an app component. Now, a component is a body of compartmentalized code, and React is absolutely brilliant because what you do is you take a complex project, you compartmentalize it into a whole lot of little itty-bitty bits of code where each one is a component that has its own body of logic. So if we think about a standard HTML document, it might have a header, a main section, a footer, the body of the document, might have a nav bar, some drop downs. All of these are their own components. And components can be any size. I can have a header component that has a title component within it. It might have some navigation options components, so we can have components within components. And it's kind of like boxes. You can have a big box that has a whole lot of little boxes that have little boxes within them. And that's how you get a very organized packing structure. And that's what we're going to be doing inside of our React.js project very shortly. But the app is basically our top level component. So it contains all of our React code, and via this main.jsx, it gets injected into our HTML document and rendered onto the screen. Now, a component in JavaScript language is just a function. It's very simply a function. So just in here, what I'm going to do is get rid of all of these extra lines of code, break it down to what it is at its very core. And this right here is everything we need to create a component inside of React. As I said before, a component in React is just a function. And so here we have a function called app. It's our whole application. And the shorthand term for a file like this is a React functional component. And all a React functional component does is it returns what's known as JSX, which just happens to be that file extension. Now, I know there's a whole lot of terms going on at the moment, but don't worry, they're all relatively simple. A component is just a function that returns JSX, and JSX is just HTML that can have JavaScript written directly inside it, which is super convenient. So just here, I could define a variable, let x equal to 3, and now what I can do is inside of the JSX, remember you couldn't do this in vanilla HTML, if I use the curly parentheses, wherever I come across curly parentheses inside of the JSX, which is what gets returned out from the function, I can now write the JavaScript directly into the HTML, and that will then get shown onto the screen. So it's so easy to basically have JavaScript riddled all throughout your HTML code, which is what gets returned from your React functional components. So as I said earlier, a React project is broken down into all sorts of React functional components, which are just bodies of compartmentalized code. And so what we're going to do is right-click on the source directory and create a new folder called components. And you guessed it, it's going to contain all of the components for our project, where each component is its own file that exports its own function. Now for this project, we're going to have a few components. We're going to create them now. If we right-click and go new file, we can start making them. The first one is going to be called the header. Now, React functional components are always capitalized, so don't forget to use a capital letter. And the file extension is .jsx. So just like that, I have created a header component. We'll come back to the code in just a second. Then what we're going to do is create another new file. There's about 5 or 6 that we're going to create just now. This one is called tabs.jsx because we're going to have a component that contains some tabs. After that, we're going to have another one. It's going to be called the to-do list.jsx. And you guessed it, this is going to contain the code related to displaying the to-do list section of our project. After that, we're going to have another one called the to-do input.jsx. This is going to be specifically where we input the information. If you can imagine a to-do list, there's a bar where you write a to-do and then have a button at the end that clicks add. So this file is going to have all the logic related to that component. After that, we're going to have one called the to-do card.jsx. Now notice that when I have 2 words in a file name, each word is capitalized, and the to-do card is actually going to be the card that displays all of our to-dos in our list. Now at this point, you might think, but James, what if we have loads of to-dos? This is where the components are super helpful, because we can write the template essentially for a to-do card and reuse that same component multiple times. In HTML, you might have to write out a card 6 or 7 times. In React, you write it once, you use it lots of times. And just like that, we have created all of the components we need for this project. Now, as for the function part of the component, we've obviously created the files. All we have to do is export. We have to export our functional components so that we can access them from within other files. And we export a function called whatever the file is called. So in this case, it's a header. Now a function receives some arguments inside of the circular parentheses, and then it has the curly parentheses from within which we can return some stuff from our function. And in this case, we could just return some HTML. It's essentially known as JSX because we could write JavaScript directly inside it. But in this case, we're just going to return some HTML. And since this is a header component, I'm actually going to return the header HTML tags. And just like that, we have a React functional component, which is going to have all of the JSX or HTML code that is related to our header component and all of the JavaScript logic for any interactive sections. So that is super cool. Now what we're going to do is come to the tabs, and you guessed it, we're going to do the exact same thing. We're going to export a function called tabs, and return a nav, because it's kind of like a nav section of our project. One thing to mention as we're doing this is that you want to ensure that you're saving all of your files. After that, we have a to-do card. In here, all we have to do is export a function called to-do card and return a div, because this is just going to have a div with a whole lot of code that we can come back and add later. Now we'll save that. After that, we'll have the to-do input. This one, we're going to export a functional, just function called to-do input. And then we're going to return another div. This one's just going to have a div, pretty straightforward. Later, we'll add the input and the button. And then last, we're going to have the to-do list. And in here, what we're going to do is once again, export a function called to-do list, ensuring that you match the capitalization of the function name with the file name. And in here, we're just going to return a div. Very straightforward. Now that's all of our functional components, our React functional components created. Now the way that we go about using them inside of our project is very simple. So React is like the box analogy I gave earlier, where we have a big box that has some little boxes and then some further nested boxes within those. And so if the app.js is our biggest level box, in here we're going to have all of these sub boxes. For example, one is going to be the header component. So what we need to do in here is find a way to render out the header component within the JSX of this app, this top level app component. And the way that we do that is just by referring to it as if it were a legitimate HTML tag. So we use the tag, and here I'm going to call the header. Now, if you're coding inside of VS Code, your IntelliSense will come up suggesting that you add the import. Now that's really important. So what we're going to do is click on it, and it's going to add this import line where we import the component. If you recall, we exported it from the file. So we import it into our top level app, and then it's a self-closing tag. They're not exclusively self-closing tags, but we'll touch on that shortly. And then we're going to save the file, and just like that, we have added our header component to our project. Now we're going to do the same for all of them. Underneath the header, if you recall, we have the tabs. So we're almost designing our project as we create this componentry. Underneath the tabs is going to be the to-do list. So we have to click enter and make sure that we're importing all of these from the appropriate files. Underneath that, we're not going to have the to-do card because that's going to be within the to-do list, but we are going to have the to-do input. So I'm just going to accept those auto imports up the top. And now we have imported 4 components and we have rendered them all out within our app that via this main.jsx gets injected into our HTML and rendered on the screen. Now, one of the reasons I love React.js componentry is because of how clean it is. I have my whole application across, 11 lines of code. It's very easy for me to see that I have a header component, I have a tabs component, and when I want to meddle with the logic present in each, all I have to do is go to the appropriate component, so I know that all the tabs logic is just going to be in here, and it means that I have these small little files, and that's a good way you should know when you need a new component. Either, the way I like to think about it is that each component serves one purpose. The to-do list has the list, the header has the header, and the second thing that suggests you need a component is when you're going to have a repeated body of logic. For example, the to-do card in HTML, I would have to write out a to-do card 6 or 7 times, depending on how many to-dos I have. So in this case, I know it's going to need to be a functional component so that I can write the template for the card once and reuse it multiple times. For example, the to-do card gets rendered within the to-do list. So here, I go to the JSX returned from this functional component, and then all I do is I render out a to-do card, just like that. And we have to make sure that we import that from the appropriate file. And then what I can do is I can copy that, and I could have, 10, 20, as many to-do cards as I like. And then if I wanted to modify the to-do card, I modify it once. I don't have to modify all of them independently, and the changes are cascaded across all of them. So it's super easy to have these massive projects with really tidy folder and file structures. Now, obviously, none of this is visual on a screen, and that's absolutely fine. That's what we're going to dive into now. But first, just to quickly summarize what we've briefly talked about React functional components. The first thing is that a functional component is just a compartmentalized body of logic. As you can see here, we create them for all the different little parts of our project. We can have components within components, and all they are at their very core is a function that we export from a file that returns some JSX, which is just HTML that we can write JavaScript inside of. As for how we get them to show up, we render them within a parent component. In this case, we have 4 components just here. We import all of them as they're exported from their files, and we render them within the JSX of the parent component as if they were just plain old HTML tags, where the name of the tag matches the name of the function that we export from the file. We can obviously have components within components. For example, just here we have the to-do list component. If I wanted to modify the code for the to-do list, I can easily access the to-do list.jsx file. And here we can see that within the JSX return from the to-do list, we render out a whole lot of to-do cards, which themselves are also React functional components. So it's super easy to build these absolutely massive projects, and we've just about developed the entire structure we need for this tutorial. Now we have to do is add the content, make it look pretty, and make it interactive, which is pretty easy to do in React. So with that all done, it's time to boot up our project. And the way that we do that is from within our terminal, make sure that we are inside the Todo App directory. And we're going to run the command right here that was inside of our package.json, this development command. Now it's pretty straightforward. All we do is we type npm run dev. If we hit enter, that's going to boot up our application on a local host. You'll want to copy this local host, where yours will probably be localhost 5173, mine's 5175, because I'm working on the other projects in this course to make sure they look absolutely on fleek. So if we go ahead and paste that into our browser, that's going to open up our project, which is currently completely blank, but we didn't get any errors. It's just blank because, if you recall, we gutted this project and all of these components are currently empty. They are rendered, however, and we can confirm that they're rendering correctly. For example, if we take the header, we can come inside the header, and I'm just going to write James inside of the JSX returned from the header functional component. And if I save that file, my changes are propagated into the web application, and they display up on the screen. So that's absolutely wicked, and everything is working. Now, so far we have some default styling applied. We have this app.css, which we're just going to delete. We also have an index.css. We're going to come in here and delete everything from that file as well. And now we have a completely blank template application that we can absolutely beautify. Now, because this is a React tutorial, there's not going to be any CSS done in this video. If you want to practice your CSS, I have an HTML and CSS full course linked in the description down below. But the applications we're going to build are pre-styled. So they look super pretty, and we can just focus on doing all the React. And so what we're going to do to get these styles available inside of our course is come over to the GitHub repos for each of them. In the description down below, you'll find the link to the GitHub repo. If you could star the repo while you're there, it's super appreciated. It helps to support the channel. And you'll want to look for this index.css sheet. I'm just going to go ahead and copy all of the code from that index.css. Equally, you could just download the file and replace this one. And I'm going to paste it in. It's 153 lines of code, and it has most of the styles we need for our application. I can now go ahead and save that, and that is all done. Our application doesn't look much different, but as we start adding in the content, it will be pre-styled. Now that's about 60% of the styles. There's one more style sheet we need to import, and that comes from FantaCSS, which if you like fantasy and CSS, it's combined. This is my new little project that I've released. It's a pre-styled set of HTML elements where essentially if you just want to have an application look pretty, you just install it into your project, which is exactly what we're going to do. This is just a second CSS sheet, and this is going to style all the elements in the application. So the index.css is going to be for the layout styles, and the fanta.css is going to be for the element styles. This is linked in the description down below. We're just going to go across to the GitHub code. Likewise, if you could start the repo, just absolutely love their support. And we're going to look for the fanta.css file. This will actually be available inside of the React full course repo as well. And what we're going to do is just download this file, come across to our project React full course and the Todo App, and in here we're just going to save it within the source directory right there. We can see the index.css, and now I'm just going to click save, which is behind my head. And now if we come back over to our code, we'll have this fanta.css file. It's got all of the styles to make our application beautiful. You could fiddle with it if you want to. And now the last thing we have to do is both of these CSS files, all the styles for our entire React.js application are imported into the main and automatically applied to our React project. So right here, I'm just going to add an import line, and it's just going to be fanta.css, just like that. And now we can see that some styling has been applied to our document. So that is super easy. So since we've just officially had the world's fastest styling of a to-do application, it's time to actually start adding some content to our project. Now the way that this works, and this is how I build all of my projects, is I start off by adding the content first, and then I make it interactive secondarily. And I typically like to start from the top and work my way down, where the top in this case starts from within the app component. Now this is good so far. The only change we're going to make right here to this JSX is change these divs to what are known as React fragments. And the reason I'm going to do that, if we come into our application and inspect it, that's just right-clicking on the web page and inspecting, that's going to bring up our developer tools. From here, what I can do is I can inspect the HTML that's being rendered on the page, and if I open up the body, we find that div with the ID root, from within which our entire application is rendered. If I come within that, we can see we have a secondary div that then has all of our React functional components. And this div right here is completely unnecessary. It's just, it's currently not doing anything important. And so what I want to do is remove it. Now this div right here in our code is this div right here. This div is being injected within this div right here. So we've got this double div that we don't want. So you might think what I could do is I could just remove it. But that gives us some errors inside of our React code, and it brings up an important concept where essentially every React functional component can only return one top level basically element. That element can have subsequent children. For example, before we had a div and it had subsequent children, but we're essentially just returning one div with a whole lot of contents inside. We cannot, however, return a whole lot of stuff, which is what we would be doing in this case if we didn't basically containerize all of these elements. So if we want to return a whole lot of stuff, what we do is we wrap it in an empty div. And that's known as a React fragment, which is just the HTML tag signs, the opening and closing tag signs. We wrap these four components within it, and it's now just basically an empty div that's referred to as a React fragment. And because we're only returning one thing that technically contains a whole lot of stuff, our React functional component is now happy. And if I save that and reload this page, we can see now we have the body div, and then we have our functional components directly within, which is exactly what we want. So now to move into the React functional components themselves, at the top of our list is the header. So we're going to come over to the header component. Now this component is actually very simple. All we're going to do in here is we're going to have an h1 tag. Now this h1 tag is just going to say you have a number open to-dos or tasks. So it could say, for example, you have 3 open tasks, and then we're going to have a full stop at the end. Just like that. And now our styling has been applied, and we have a pretty h1 right here that tells us how many open tasks we have. Now, obviously, the number of open tasks is going to vary, and even whether or not tasks is actually pluralized is going to vary, but we'll see how we can account for that shortly. And what I'm going to do in here is the only class we need in here is the text-gradient class. And that's available within FantaCSS, and that's just going to give us this pretty gradient right here, where the FantaCSS actually works for both the dark and light theme. So we can see here's the light theme version right there. Every element is styled for both the light and dark theme. So that's our first component for the minute, pretty much done. Underneath that, we're going to have the tabs. That's the second component we need to work on. Now the tabs is ever so slightly more complex, and we're going to have 3 of them in particular. We're going to have an open, a complete, and an all tab. Now what I could do in this case, they're essentially all buttons because I click a button and it changes the tab, is I could write out 3 buttons in here, and I could have one button, I could copy this whole line, Control C, and then Control V it, and have 3 buttons. But that is, pretty much sacrilege in React. React is all about writing once and doing it lots of times. So what we're going to introduce here is a concept called mapping. If I have a repeated section of HTML, obviously I can create a component for it. So it would be very well for me to go ahead and create a tab component within the tabs component. So it's a nested component, but we're actually going to do something that's a bit clever in this case. We're going to create an array, and it's going to be called tabs. And this array is going to have all 3 tabs. It's going to have the all tab, it's going to have the open tab, and it's going to have the completed tab. And what we're going to do is we're going to map over this array, and for every element in this array, we're going to return some JSX, and that's going to be equivalent to writing out 3 times. So instead of writing out the button 3 times, we can just return 1 button, but because we've mapped over every element in the array, JavaScript is essentially creating that element. Now because this is JavaScript inside of the JSX, we're going to need the curly braces. And this technique, this mapping technique, works specifically on arrays. And what we can do is we can target the tabs array, and where you can use the .map method, which receives an arrow function. Now the arguments for the arrow function that we need for this mapping technique, the first one is what we're going to refer to each element in the array. And that's just the tab. Every element in the array is just one of the different tabs. The second argument it's going to receive is the tab index, and we'll see why we need the tab index shortly. Now as for the logic within this arrow function right here, this map, what we're going to have to do is return some JSX, because we want to, for every element in the array, return some JSX that populates the JSX of the tabs component. And that's going to be a button. And so just like this little line of code here is basically saying for every element in this array, and that should be completed, return a button. So essentially we're writing out 1 button, but we're returning it 3 times for every element in the array. And within that button, what we can do is we can have an h4 tag, and then once again, we can write JavaScript directly into this JSX using the curly parentheses. And then in here, all we're going to do is return the tab, and that's the name of the tab. So we're going to get 3 tabs where each respective tab is going to contain these text elements right here. Now technically this is valid JavaScript, yet we have an error. And that's because in React, whenever we use this mapping technique from the return JSX, we need to identify all of the different buttons with a unique key. So what we do is we add a key attribute and we set it equal to a unique code. Each of them has to have a unique value. And that's why we get the tab index. The tab index, obviously every element in the array has a unique index, and that just helps React keep track of all the different buttons that it's mapping out onto the screen. So if I go ahead and save that, we can see we now have 3 buttons, even when we only had to write the button code once, and that prevented us from having a repeated body of code. So that's super clean. We'll get to the styles in just a second. I'm just going to cover that once more because it can be a slightly complex topic to wrap your head around. So what we did is we have 3 tabs in this array right here, and consequently we need 3 buttons, but we only want to write out the button once. So what we do is we map over every element in this array and we return a button for each of them. That means that we only have to write the button once, but we get as many buttons as we need to complete this array. The mapping function takes in an arrow function that returns JSX, and that itself is within the curly braces because all of this is JavaScript written within the JSX of the tabs component. We have to be able to distinguish all of the buttons, hence they all need a key, and the key is added as an attribute to the parent component returned for that JSX. So whatever is returned at the top level, we don't add the key to the H4 because that's not the top level element returned. And just like that, we have some nice neat code to get our 4 tasks. And this is super convenient because if we had 1,000 tabs, that would do the trick for us. And this concept is known as mapping inside of React. And most JavaScript frameworks introduce this concept. The syntax just looks different. So now that we have these tabs, we just need to throw in some classes. This one has a class name of tab container, just like that, tab-container added to the nav. And the button itself has a class name of tab button. Now I didn't mention this earlier, but typically in vanilla HTML, when you add a class, it's just got the class attribute. Class is a reserved keyword inside of React, so we instead use the class name attribute. It's important to remember that we don't just write class, we have to use class name. And we'll see how we can make these classes a bit more dynamic shortly, but for now that's going to do. And if we save that, we now have some pretty plain old buttons that will look a bit cooler very shortly. Now the one other thing I'm going to do in here is I'm going to add the circular parentheses, which do absolutely nothing, and then a 0. And that's just an indicator or a placeholder for when we come back that we need to add quantities to these tabs, see how many are available. And they themselves are going to be wrapped within a span tag because we'll give them some subsequent styles. So we can see those styles have already been applied, in fact, and they just gray that out a little bit. So that's pretty hunky-dory. That's our tabs component done for the minute. Now the next one we're going to work on, coming down the page, is the to-do list. And obviously in here we have a whole lot of to-do cards. Since we're repeatedly rendering out that to-do card, you might have guessed that we can actually map it out. And we'll be doing that very shortly. But to actually map out some to-do cards, we actually need a list of elements that we can map out onto the screen. We need some to-dos. So what we're going to do is come into our top level component right here, the app, and right above where we return the JSX, I'm just going to open up some new space. And in here, in this part of the function, is where we have all of our logic. Now what I'm going to do is just define an array called to-dos, very simply, and I'm actually going to copy these across from the GitHub repo. I pre-prepared them, where each to-do is just an object with 2 key value pairs. The first key is input, and that's the actual to-do, and the second key is a status check. It checks whether or not the to-do is complete yet. So this to-dos array has 4 to-dos. Now you might say, James, why don't we just define that inside the functional component where it's actually being used. And there's a good reason for that. We've seen how we can render out different components within our React.js project, but how do we communicate information one to another? Well, we do that using a system called props, which we'll introduce very shortly. But the main thing to know about this communication between components is that for the most part, it goes down the hierarchy. So it can go from parent to child, but it's much more challenging to get information to go from child to parent. Now, if we look at the components, we're going to need access to the to-do list inside the header component because we need to know how many tasks are available. We're also going to need access to the to-do list inside the tabs because we have this little number here that's going to count how many completed tasks we have. We're obviously also going to need this information available inside of the to-do list. And so because we're going to need that information inside all three of these components, and they sit at the same level in the hierarchy, which is a direct child to our app component, I can't communicate across, I can only communicate down. So I'm going to need to define the information in the parent component, and then I can pass it down to all of them as properties from the parent to the child. So you're probably wondering, how on earth do these mysterious props actually work? Well, it actually has a lot to do with the term props, which is short for properties, where we communicate the information from parent to child by giving properties to the tags, which are actually very similar to how attributes work. So basically, if we give an attribute to the tag, that's one of two types of properties that we can give to the tag. So in this case, as I said earlier, the header component is going to need access to the to-do list because we need to know how many active tasks the user has so we can then display that in our pretty h1 tag. So consequently, what we're going to do is we're going to give this tag a property. And the way I like to think about these attribute style properties is that they're like boxes containing information. They're like presents, where the present might have a label on the outside that we can use to refer to the present. So in this case, I might call it to-dos. I could call it to-dos list. I could call it to-do list. I basically just need a name for it. And then what I do is I assign to it a value. Now the value is what's contained within the attribute property or prop. So in this case, I'm going to have to-do lists, and I just want to assign all of our to-dos in the array to that attribute style property or that prop. Now, as I said before, we're going to need access to that, and I'm actually just going to call it to-dos for consistency. Keep it the same. So the label is equivalent to what the value is, and I need that prop for a whole bunch of these. I'm going to need access to it in the tabs, and I'm going to need access to it in the to-do list, just like that. Now, that's giving the components that property. But now to actually finish that communication network down to the child, what I'm going to have to do is tell that property where I define it, so inside the actual component, that it needs to expect to receive these properties. So if we start off with the header, we can tell the header that it's going to be expecting some properties by adding props as an argument. And then it's like a big present van that's, or like even better, it's Santa's bundle of presents. We need to get out the properties that we're looking for. And so what we can do is we can use the destructuring syntax within JavaScript, which basically you can think of props as like a massive present object. It's got all the key value pairs, all the properties, all the attributes of the tag. And now what I can do is I can destructure out the props that it was expecting. So in this case, the header received the props or the properties, and then from within the properties, we can destructure out the to-dos, which is the to-do list. And so in this case, what I could do is I could say const to-dos length is equal to to-dos.length, because to-dos is just an array. And so then I have a JavaScript variable, and this is where the React magic is really going to go crazy. I can copy that variable name, and I can now use the curly parentheses inside the JSX and just render out the dynamic value of to-do's length. And so here we can see that we have 4 open tasks. Now the task is funny because it's only plural if the number is 1. So in here we're going to define another variable, and that's going to be called const is tasks plural. And that's going to be equal to todos.length is equal to 1. So if the length of the to-dos array is equal to 1, then tasks actually need to be singular. So that's the opposite, not equal to 1. So when the to-dos length only has 1 item, you have 1 open task. Otherwise, you have 0 open tasks, or you have 4 open tasks. And what that allows us to do is write some more JavaScript, where in here, what I can do is I can use the curly braces, and I can say is tasks plural. And actually what I'm going to do to make this even clearer, so we've determined whether or not tasks is plural, and so now I could have another variable, could be just like task or tasks, and that's equal to the question mark conditional. So if is tasks plural, then we have tasks, lowercase, otherwise we have task. And now we can literally, inside of these curly braces, inject our JavaScript straight into the JSX. And now if we go ahead and save that, we can see we have 4 open tasks. And then if I were to comment out 3 of these, now that it's 1, we can see it's 1 open task. And yeah, as I said, you can just really start to appreciate how easy it is to add JavaScript straight into your project. So once again, just to summarize that process, we added the properties to the tag, the attribute style prop. We'll touch on the other style of prop soon, but the attribute style of prop. And then the second half of that equation is that we need to let the component know that it's actually meant to receive some props. So we add the props argument, and then that's like a box we can unpack it, and we can access information via the label we assign to it. So in this case, we assigned the to-dos array to a variable name or an attribute name of to-dos. We can unpack that, and then we can do all sorts of stuff with it, such as get the length, find out if tasks should be plural, and then consequently inject that into our header. So that's the first one. We can also do that with the tabs. Here we have to-dos. So if we come into the tabs, we've already assigned the prop to this component. Now we just need to tell it that it needs to receive the properties. And then once again, we can destructure out to-dos from the props. Now what we can do in here is where we're mapping over and returning a tab button for every element in this array, we can find out what the number right here is meant to be. And we can do that via the status. So if we come in here, before we return out, we can actually write a whole lot of JavaScript in here. We can have a lot of logic, and it's scoped specifically to that tab. So what we could do is we could create a variable called num of tasks, and that could be equal to, and we can then add in some JavaScript to figure out exactly how many tasks. And the first one is going to be, if tabs, or the tab is equal to all. If it is, we can use the question mark. Then what we want to do is return todos.length, because we want to accumulate or count all of the tasks. Otherwise, we can check if the tab is equal to open. If the tab is equal to open, then what we want to do is filter the to-dos by the ones with the status complete as false. So the way we can do that, if we come into the tabs, is we can say todos.filter. We can access the value, and we can check if the status is complete. And I think it's actually not status, it's complete. So let's come back into tabs, and we want to access the complete key within that object. Now it's actually inversed, so we just have to inverse that value, because obviously if it's open, it's not complete. So if it's not complete, and then we can just get the length of that value, And then if it's neither of those two conditions, we know that it's the closed one. So then we can just say todos.filter. We can access the val, and now we can just access val.complete, and we don't have to inverse it. We also have to get the dot length of that. So essentially what we have here is just like some chained conditional logic where we use the question mark conditional. If the tab is equal to all, then we get the length of the entire to-dos list. Otherwise, if the tab is equal to open, then we filter them by ones that are incomplete, and then we access the length of that array because we'll only return the to-dos that are still incomplete. And if it's neither of those two cases, then all we want to do is filter them by the ones that are complete, because that's going to be the completed tab, and then we can just access the length of that array. And now what we can do is, using the curly braces inside the circular parentheses, we can just inject that value into that tab. And now if I come back, I can see that in all, I have 4 to-dos, in open I have 2, and in completed I have 2, which should match up perfectly. Here you can see we have 2 completed and we have 2 open. So once again, super dynamic, it's going to vary all the time, and React just handles it really nicely. We have a little bit of logic to calculate the number of tasks, and then we just inject that straight into each button. So now that we have our tabs working, logically the next thing we need to do is render out our to-do list. Now this one is actually going to be a little bit interesting because it's going to be dependent on the tab that we have open. So that actually should give you a hint. These two components are going to have to communicate, which means that the tab status is actually going to have to be defined inside the parent component. Now that might not have made all the sense in the world, but we'll see how that works very shortly. For the minute, I'm just going to define a value called tab, and that's just going to be equal to all, and it's just going to be a hard-coded value for the minute. Now, like the other ones, we passed in the to-dos as an attribute property to this component. We have to let the component know to receive the props, and then once again, we can destructure out the to-dos from the props, just like that. And within this list, what we can do is now render out all the to-do cards for every element. Now coming into the JSX for this component, what we're actually going to do is remove this div because it's completely unnecessary, and we're going to use, once again, the React fragments. That's just an empty div that allows us to return a whole lot of stuff, but it's containerized within something so that we're technically only returning these fragments and the contents within. And then we're going to use the curly braces to take advantage of that mapping syntax, because we're going to need an undetermined number of cards rendered out on the screen dependent on the length of the to-dos array. So for that, we're once again going to use the .map syntax. We're going to go todos.map, and that takes an arrow function. Now the arguments for the arrow function are the to-do and the to-do index. And then we can open that up and add in the return line. It's important that you return something out because the JSX that you return from the map has to be left behind to then be rendered on the screen by React. And in here, we're going to render out the to-do card component, and that's going to be self-closing. Now, as I said earlier, we need to add the key attribute that has to be a unique value, which is why we get this to-do index up here. That just ensures that React is happy and that it can distinguish between all of these to-do cards that it's mapping out onto the page. And the other thing we're going to do is actually need to pass in the to-do index as a secondary attribute or prop. Now, the last one we're going to have to access, if we come into the to-do card, this is where we're going to have all the information about the to-do. So we somehow need to pass in the to-do object. And I can do that very simply by actually, I could either go to-do is equal to to-do and just give it access to that to-do, or I can actually use a sneaky syntax where I can spread all the props. Now this syntax right here always has to be the last prop that you add to the tag, the last attribute style prop. And what it does is it just says whatever my parent is receiving, give me all those props as well, and send them straight down into this child as well. So that means that inside of the to-do card, we have access to the entire to-do list. We also know the index of the current card in the array, which means that we can figure out which to-do we're passing down, and then we can consequently then render that on the screen. So here we have this to-do card. We've given it a whole lot of props. We need to come into the to-do card and let it know to receive this information. So here we've got the props, and then from within that, if you recall, we can destructure out the to-do index. You can't destructure out the key. The key serves a very unique purpose, so we're just going to leave that one, but we're also going to have to destructure out the to-dos array. And since we have the to-dos array and the current index, we can say const to-do is equal to the to-dos list at the to-do index. And we could go ahead and console.log the to-do in here, and we should see a whole lot of them show up on the side, and indeed they do right here. And one for every card, which is what we would expect, because we should be, via the mapping method, returning 4 to-do cards where each one has access to its own to-do. And now within the to-do card, what we can do is make it look pretty. And all we have to do for that is give it a class name, where the class name is card, it's a string, and it's also to-do item. They're going to be 2 separate classes, so they're space separated. And then within here, we're going to have a paragraph with some curly braces. And the curly braces contain some JavaScript, which is the to-do.input. Pretty straightforward. And then the last thing we're going to do is have a div, and the div is going to have a class name equal to the to-do buttons, which are going to be some action buttons. And then in here, we're going to have a button, where the first button is going to have an H6, and that's going to say done. And then we're going to duplicate this button, just like that. And the second one is going to say delete. And these are our action buttons within the to-do cards. So here we have all of our to-do cards rendering on the screen, and we only had to write out that logic on one line. But because we mapped out every to-do in the array, we essentially get a to-do card for every to-do in the to-dos list. Now the one thing I want to do is add a special attribute to the button, which is called disabled. Now the disabled is equal to the status of the to-do, so we can say to-do.complete. And the reason we want to disable it when the to-do is complete is because if it's complete, we can't click this done button. It's already done. So we just want to remove that in the case where it's already finished. So that's looking pretty cool. The only thing we're missing is we actually need to filter them out dependent on which tab is currently open. And we can do that very simply in React. And the way I'm going to create this filtered list is I'm going to come over to the to-dos list. And right here, what I'm going to do is say const filtered to-dos list, define a variable called filters to-do list. And this needs to go underneath the tab. And what I'm going to do is very similar to the logic we had in the tabs case. So if the tab is equal to all question mark, then I just want to assign to-dos to the filters to-do list. Otherwise, if the tab is equal to completed, then what I want to do is I want to have to-dos.filter access the value and check if val.completed is true. If it's completed, I only want to return the ones that are completed, and otherwise, then I want to return to-dos.filter, access the value, and then I want to have the inverse, not completed. So what this logic right here is doing is it's creating a filtered to-do list where if the tab is equal to all, we access all of the to-dos and we assign that to this variable. Otherwise, we check if the tab is equal to completed, then we filter out all of the to-dos that aren't completed, and what's left over we then assign to this variable. Otherwise, in the final case where we have the to-dos that are active or open, we just filter out the ones that aren't completed and we assign them to this variable. Now at this point, I should mention, if you're wanting to brush up on your JavaScript, I have a course linked in the description down below. These are pretty common JavaScript methods, the dot filter, all that kind of stuff. So if you are looking to strengthen your JavaScript, be sure to check out that course. Lots of people gone through it. Everybody loves it. Something to think about. Anywho, now that we have this filtered to-do list, what we need to do is vary the to-dos that are actually rendering out on the screen. And the way that we do that is we simply swap the to-dos to the filtered to-do list. And so what that's going to do is it's going to check the tab, it's going to filter out all the ones that aren't relevant, and then we're only going to map out the relevant cards. So while the tab is equal to all, we would expect to render out all of them. However, if we change the tab to open, and obviously this is hard-coded to the moment, we'll make it dynamic shortly, we would expect to only render out 2 cards. And that's currently still printing out all 4, and that's because I made a spelling mistake where that should actually just say complete. The key is complete, not completed. So now we're in the open tab, hard-coded, and we only get 2 showing up as open. And then if we were to change that to completed, we would expect to still only have 2 showing up. And that's exactly what we get, which is perfect. Now, the one thing I'm going to do to make this ever so slightly cleaner is actually change this props. We don't have to pass down the entire list. We can actually just pass down the to-do directly. And so I'm going to add another prop called to-do, and I'm going to assign the to-do object to it, which contains the input and the status. And that gives us an error. And what I'm also going to do is just enter these onto a new line to make the code a little bit neater. So that looks a bit better. Now, because we're not passing down the entire to-do list anymore, what we'll have to do is come into the to-do card, and instead of having this line right here, where we figure out the to-do, what I'm instead going to do is delete this, and instead of destructuring out to-dos and to-do index, all we need to do now is destructure out the actual to-do, and that should work once again. And now our tab system is completely finished, and our to-do list filters out the ones that aren't relevant. And we've got these 3 nice attributes, and everything is super clean. And actually, in all fairness, we technically can also remove that to-do index property as well. So we've just got the 2 props, the key, which is important for the map, and then the actual to-do. So that's looking excellent. And that also leaves us with our very last component, which is the input. Now, if we come across to that file, currently it looks pretty blank, but it's actually super simple. We have a div here, and this div is going to have a class name equal to the input container, which is pretty simple. And in here, we're just going to have an input with a placeholder that says add task, and that's a self-closing tag. And then after that, we're going to have a button, and the button is going to be an icon. Now, we haven't yet added any icons to our project, and so what we're going to do is come over to a website called fontawesome.com, and this will be linked in the description down below as well. And we're going to click on this icons tab, and we're going to search for, not that, but instead the plus. And when we hit enter on that search, we scroll down, we filter by the free icons, we see this plus right here. We're going to select this plus, and then if you scroll down, we don't want the React code, we just want this icon right here. We're going to copy this icon, and we're going to paste it inside the button, and we're going to replace the class with class name, because obviously class is the reserved keyword. Now if I go ahead and save that and come back to our project, we have this button right here, and it's got nothing in it. And that's because there's one last thing we have to do to get Font Awesome working, and that's come over to the Font Awesome 6.0 CDN, which will also be linked in the description down below. And if we scroll down here, we just want to copy this top link tag. Now, when you're adding links to a project such as this one, CDN links, what we're going to do is add them to the meta information of our page, which is inside this index.html. specifically inside the head tags. And where we have this title tag, we're going to come underneath and paste that tag in. Now, two things we're going to do here. First, the meta information also has the title of the document, which is what we see up here, and currently it's Vite plus React, which is not what we actually want. And this is super important for things like search engine optimization. We're going to change it to to-do list or to-do app. You can obviously get more creative. My first to-do list was called 5do because I believed at the time that a to-do list should never be more than 5 items long. So you can name it whatever you like for your project. Pick a name that you're going to choose for the URL when we deploy it at the end as well. And the other thing I want to point out at this point is if you're wondering about how I get my code to jump around sometimes, I just made a little website called VS Code Shortcuts. And it's got some of the key commands for all the nifty little things I like to do in my terminal to accelerate my programming speed. So this will also be linked in the description down below. Be sure to try some of them out. I try not to use them too much in my tutorials because it can accelerate them. But if you do want to become a faster programmer, these can really save you some serious time. So that's linked in the description down below. You can also check out the GitHub code for this as well. Anywho, back to the project. Now that we have added that CDN link, we now have this plus icon added to our project, which looks super cool. When we hover over the input, we get a nice little border color change, and it just looks, and the button is pretty fun to click as well. So these are all the UI elements officially added to our page. Now what we need to do is actually make everything functional. And the first thing we're going to do is start off once again at the top level of our application. I'm going to close a bunch of these tabs up here. And the top level of our application is the app. Now, new concept introduction, here we come. Currently our app is not functional. I have a to-do, I can enter into it, but when I click the plus, nothing happens. When I click the delete, nothing happens. When I hit the open, none of this stuff does anything. And the core of all of these issues is actually the way that we've defined the to-do list right here, which is a standard variable inside JavaScript. If you were doing this application of vanilla JavaScript, you would probably manage a to-do list pretty equivalently to how we've defined it here. And in JavaScript, there is absolutely still a place for standard plain old variables, but React is created for making very dynamic applications. And when you're creating things, or specifically when the user is going to be interacting with state or values or data on the page, we have to use a variable system that is specific to React. And that is specifically known as useState. So what I'm going to do for the minute is comment out this to-do list right here, which is going to break our whole application. And we're going to convert this plain old variable, which wouldn't work in the React context. React doesn't know how to listen to variables. If we were to change this variable around, it wouldn't know that the screen needs to be adjusted and all these things. So when we're trying to do dynamic stuff on the page that the user is specifically going to interact with, such as varying the values of a to-do list, we need to use what's known as useState, and it's a React hook. Now it works in a similar manner to how a traditional variable works. We just initialize it slightly differently. So we still have the const, we still have the to-dos, except now what we do is we wrap the to-dos inside of square parentheses. So we'll put to-dos inside of an array, and then we're going to have a comma and a second entry in the array, and this is going to be a function name. Now in this case, the convention is typically just to throw the word set in front of the variable name. So this is called set to-dos, and this is known as what's a setter function. So the first entry in the array is the actual variable name, and the second entry is the setter function. And we have a setter function for manipulating or modifying the value associated with that array. So instead of just saying to-dos is now equal to a new array or modifying the original to-dos array, we always need to use the setter function instead, and we'll see how that works shortly. After that, we have the equals, and now what we're going to do is have the actual hook, and this is called useState. Now, useState is a React hook, where React hooks are just functionalities for manipulating or managing data on a page, basically. That's the long and short of it. And the first thing we have to actually do is import that hook, and it's part of the React npm package, which we saw at the very start of this tutorial. So what we're going to do is import some stuff from the React package, specifically useState. And once again, that is known as a hook, a React hook. Now, when you call the useState hook, or when you instantiate this variable, this useState variable, this stateful variable, you call the hook and you invoke it, and as an argument, you can either leave this empty, or if you want to provide a default value, which in our case is going to be an empty list, you can just add that in. So that is going to be the default value for our to-do list. Now, if I wanted to, I could actually add all these in as well. And I am actually going to have this first one be part of this default list. So in here, what we've done, if we now come back to our application, we can see it's actually still working now. We had a whole lot of errors before as we were making those adjustments. Now the variable is working the same as it always is, except it's, instead of being a traditional variable, it's now a React stateful variable, which means that we can allow a user and their behavior in our application to modify and manipulate the values of this to-do list. So that's super cool, and it's important to know about, and it might seem a little complicated at first, but the more we use it, the more you will feel confident and start to understand how these React hooks actually work. So that's pretty cool. The syntax is we have an array, we have the variable name as the first entry in the array, and then we have the setter function as the second input. After that, we initialize the hook, useState, we call the useState hook, and we pass in a default value, which is this array of to-do lists, which we can then modify at a later point using the set to-dos list. And the input is optional. We could also just have it blank if we didn't want to have any default value assigned. So the next thing we're going to do after that is actually enable a functionality that allows us to edit or add to this list, because currently we have, we can't do anything. We can't actually modify the list. So what we're going to do for that is create a function. Now, we already have this setter function for modifying the to-do list, but I typically like to create what's known as a handler function, where a handler function has a specific subtype of modification for that list. So in this case, I could have a function that's called handle add to do. And this is going to contain the logic to add a to do specifically. Then we could have another one that's delete to do, or just as equally update to do. So we're going to add them all in. We're going to have a secondary function called handle edit to do. And then after that, we're going to have a third one for handle delete to do. And this all comes into, the paradigm called functional programming, where we just have functions to compartmentalize our code, make sure it's super clear and that everyone understands exactly what, each body of logic is doing. So when we're adding a to-do, we can obviously expect an input, and that's going to be the new to-do. And so if hypothetically we called this function and we got access to a new to-do, you might think we could just, modify the existing to-do list and add the new to-do. And that actually wouldn't work in React. These stateful variables that we've defined here are what's known as immutable, which means we cannot mutate the original version. So if we're going to make adjustments, we need to essentially create a duplicate or a copy and then completely overwrite the original. And so in this case, what I like to do to make it super clear is just do it line by line. And so in here, what I'm going to do is say const new to-do list is equal to an array, and then I'm going to use the spread syntax to spread out the original to-dos. And so this is going to create a duplicate of the original to-dos array. And then what I'm going to do is throw on the new to-do. And this is actually going to just be the input value. So what I'm going to do is create that as an object, assign the value to the key input, and have the complete status be false because we've just added it. So essentially what we've done right here is we've created a completely new list. We've spread out all the original values inside the list, and then we've appended a new one to the end of the list. And that new one is just a plain old object where we have the input key that has the value or the actual description of the to-do, and then we have the complete status. And now that we have this new array, what we very simply do is we call the setter function, and we pass in the new value to be assigned to that variable. And when we call this setter function for this useState, the stateful value, it's going to handle all of the extra stuff like making sure the screen is adjusted to accurately represent the changes to any data that has been made. So now what we can do with this setter function is we can copy it and we can pass it as a property to the to-do input, which is where we're actually going to need to call the function. Now you might ask me, James, couldn't we have defined the function inside of the to-do input? And technically we could have, but once again, since we're modifying state in the app, that's where I like to have my handler functions, because it means that I can directly access that state. Whereas if we did it inside of the to-do input, I would then have to get access to the to-do list inside of the to-do input to be able to create that duplicate. So that's some super nice code. We've now passed in this prop down to the to-do input, and what we can do is copy that prop name and then come into the to-do input component, let it know that it's meant to be expecting some properties, so we can add props as an argument, and then we can destructure out handle add to do from the props. Now you might just think, okay, so we access the value of the input and then we click the button, and when we click the button has an onClick attribute to which we assign the handle to do function. And you're close, but you're not quite right. So in this case, this onClick is going to receive an arrow function event, and that function is going to get executed when we click the button to add in the new to do. But before we do that, we have to learn a little bit about how inputs or field values work inside of React. So obviously if we have an input, we're expecting a user input, which should prompt you to think, and it will over time, that we're going to need some state to manage the value associated with that input. So what we're going to do up the top of our application is import inside of the curly braces the useState hook from the React package. And that's going to allow us to then define a variable const input value and set input value. And remember, that all goes inside of the square parentheses, and that's equal to useState, and I'm going to give it a default value of an empty string. So what we've done on this line is we've created a variable, a stateful React variable, that is going to manage the value inside of the to-do. And then what we can do with the input component, or the input tag, is we can provide it a value attribute where the value needs to match the input value. And then what we also do is provide an onChange attribute. And this is also an arrow function. We have a function that gets executed when the value of the input changes. And in here, what we need to do is receive an event. The event is the change. Someone types a new key, that's an event. And then all we do inside of this arrow function is we call the setInputValue setter function, which is going to update the value of the stateful variable. And inside here, we access the e.target.value, which is going to be the new key that gets added to this stateful variable. So if I throw that down onto a new line, and let's just go over it once more for security. So the first thing we do is we have an input, and because it's an input, it's a dynamic component or element. We know that we're going to need a stateful value to manage the value or text inside of the input at all times. And so we initialize this stateful variable right here. Then what we do is we make sure that the value of the input always matches the current value of the stateful variable. And then we have an onChange function that gets executed every time the value inside of the input changes. And when we get a new value inside of the input, we make sure that we use the setter function to update our variable. So now that I've done that, I can console.log input value. And now what we would expect is in here, as I'm typing, we can see we're actually consoling the new values. And you can see that React is listening for all of these changes, and every time we type a new value, it's re-rendering this component on the screen so that the value is updated, so that everything is reflected visually and matches the data that we're managing in the actual code. So now that we have access to the value at all times, what we can do is when the user clicks this button, we can execute this function. And inside of this function, we can say handle add to do. We can call the handler function to update the value of our to-do list. And we can just pass in the input value, which is the text currently inside of the user input. And what I'm going to do to this is add what's known as a guard clause, which says if not input value, then I just want to return. And so this little guard clause here says that if we don't have a value in the input, if it's an empty string, exit the function and it will never reach this line. So that means that we're not going to get a whole lot of empty to-dos. It's just a nice little preventative measure to keep your code super clean, known as a guard clause. It guards the second line of code because if we find out that we don't have an input, we return out of the function before we get a chance to execute it. So that is super cool. And that, if we save this component, should actually now allow us to add to-dos. So I could type in here, go to the supermarket, and click this add button. And now if we come to the to-do list, and just make sure that we change the hard-coded tab to all, which we'll update in a second, we now have go to the supermarket added as a to-do card, which is super cool. One thing we need to do last is make sure that we clear the value of the input after we've added the to-do. And that's really easy. Underneath this line right here, we can just say set input value back to an empty string. So once we've added the value, we've got access to it, we're going to blank it out and set it back to the value that we initialized as, which is the empty string. And so now if I have one here that says, pick, go to the gym. Now when I add this, it's going to add a list, it's going to add a card to the list, and it also blanked out our to-do input ready for the new one. So just like that, we have added the first real interactivity to our application right here. We learned about the useState hook, which is used for managing dynamic or interactive pieces of information on the page or data, essentially just data that the user is expected to interact with. For example, if we have a to-do list, we can expect that they are going to modify the values in the to-do list. So we know we need to initialize it using the useState hook as a stateful variable inside of React, as opposed to using a traditional variable, which for the minute could just be the tabs if we happen to want to hard code them. So now that we've done that, the next thing we're going to do is learn how we can modify these tabs. And it's actually more straightforward than you might expect. Essentially, how it's going to work, well, first what we need to do is understand which components need access to this tabs state that we're going to have. Now, one other thing I'm just going to throw in here, when I refresh my application, all of the state is blanked out and reset to default. And towards the end of this video, we're going to learn how we can persist it across page reloads so that we have like a mini database where everything is saved. But it's just good to be aware that when you refresh the page, the tabs will be reset, and currently our to-do list will be also reset to the default value. Anyway, back to the tabs. So the components that are going to need access to the current tab is obviously the tabs. We're going to need it in there to show a user which tab is selected. And we're also going to need it inside of the to-do list because this is where we filter out any irrelevant to-dos, any to-dos that don't belong in the current selected tab. So because both of these two children are at the same level, they both need access to the information, we're going to need to define the stateful variable to manage the active tab inside of the parent, which is the app. So up the top here, underneath our current to-dos stateful variable, I'm going to define a second one that's called tabs. And so if you recall, all we have to do is say const, and in this case, I'm going to call it selected tab. That's a little bit clearer than just tab. And this is pretty much a standard variable, except we're going to initialize it with useState, which means that we throw it inside of the square braces. Now we know there's a second entry in this array, and that's set selected tab, and that's a setter function that we can use to update or modify the value associated with the stateful variable. And then the last thing we do is just set it equal to useState. And in this case, I'm going to set it equal to 0. Or actually, no, the default value is going to be all. Well, actually, you can make up your mind about this. Maybe open is actually the best one that we wanted to set it to by default. Now, just to explain a bit more about the syntax, how it actually works, is technically this is like an array destructuring syntax. So when we call this hook, we're actually array destructuring out these two things, where the first thing is the variable name and the second thing is the setter function. So, that's quite a complex topic that I'm not going to dive into, but just if you're wondering how the syntax actually works, it's just array destructuring. But besides the point, we now have a new stateful variable that we're going to use to manage the state or the selected tab. Now, as I said before, obviously the tabs is going to need access to this. So we're going to have to pass it down as an attribute style prop. So in here, we're going to have the selected tab, and we're going to set the value. It's just going to be the same thing, basically. Selected tab is equal to selected tab. And we're also going to pass down the set selected tab setter function so that we can change the tab from within this component. Now, when we went to modify the to-dos, that was a state, and we defined some handler functions for it. And the reason I haven't defined, I could technically create a handler function for the set selected tab, but I'm not going to do it in this case because when we set the selected tab, it's very simple. We literally just update the new value. The handler functions are typically for when you're managing a more complex data structure, for example, a list, modifying values in that list, so on and so forth, whereas the selected tab is just a string. We just overwrite the string, so I don't necessarily feel the need to create a handler function for it in this instance. So we passed in these two props to the tabs. Now we need to destructure them out of the props. So one is the selected tab and the other is set selected tab. Now the reason I'm passing in the selected tab into this component is because these little tab buttons right here are going to have a dynamic class name. And this is really important for when you want to use JavaScript to assign different classes. So in this case, if one of the tabs is selected, we need to be able to identify and assign an additional class to it that basically, changes the styling so that it shows that it's selected. And the way that we create these dynamic classes inside of JavaScript is when you have the class name, all you have to do is wrap it inside of the curly braces, and then we can start adding stuff to it. Now, I like to throw on an empty space at the end of the string because any other strings or classes that we append onto this have to be space separated. And now I can actually use some JavaScript to modify the final string. So in this case, I'm going to concatenate on some extra classes. And the stuff that I want to concatenate on is going to go inside the circular braces because it's kind of like bedmess. I want to figure out what string we're going to add on, what class we're going to add on, and then add it on secondarily. So we have the circular braces in here. And currently, our tabs, these are our 3 tabs. I want to check if the tab, which is this one right here, if the active tab is equal to the selected tab state. And if it is, that means it's the selected tab, and we can give it a different style. So I'm going to say in here, if the tab, which is the one from the array, is equal to the selected tab state, then I'm going to have the question mark for the one-line conditional. If it is, I'm going to give it a class, an extra class called tab selected. Otherwise, I'm just going to add on an empty string because we don't need to give it any extra classes. And so this little line right here, this extra class, is now dynamic. And so JavaScript is going to construct the final class and use this conditional logic to assign this extra class to only this selected tab. And now if we refresh our page, it still looks pretty much the same. And that actually is showing up, which is all well and good. And the other thing I realized I've forgotten to add is at the very bottom of this nav component in here, we just want the horizontal line to show up. So here we have this horizontal line coming across our page, and then we're going to have the permanent tab underline to show to the user which tab is currently open. So that's super clean. Now with that done, what I want to do is now let the user change the tabs. And the way that we're going to do that is we're going to assign an onClick event to the button that takes the arrow function that to be executed whenever the button is clicked. And in here, all we're going to do is call the setter function and set it to the tab that has been selected. So in this case, now when I select completed, we can see that we get these new tabs adjusting real time. The user is interacting with them, the state is being updated, and the classes are being dynamically applied to indicate to the user which tab is in fact selected. So that's super clean, looking absolutely excellent. Now that we've got the tab working, the last thing we need to do is make sure that the list is being filtered accordingly. So when we come over to the open, we shouldn't be showing up this card. It should just be in the completed status. So what we're going to do is come into the to-do list right here, and this needs the selected tab. So we're going to need to receive the selected tab, and that means that we're going to have to pass down the selected tab into the to-do list. So selected tab is equal to selected tab. We pass down that prop. And then from within the to-do list, what we're going to do is remove this tab line and just change everywhere we have the tab to the selected tab. And I think just making that adjustment should pretty much do it. So now you can see that when we're in all, we show all of them. When we're in open, we show none of them. And when we're in completed, we show all of them. So that's excellent. Now the very last thing we need to make functional in our list before we learn how to persist all the information and deploy the application is how to get these buttons to work. Now these buttons are the handle, edit, to do buttons. We actually already have one handle function and we have the handle edit function. So they're actually already created. And the way that this is going to work is if we have a list of entries, the first thing we need to know is which entry we're actually modifying. And the second thing we need to know is what the modification we're making is. So for the edit to do, we're going to need to receive an index of the to-do that we're going to be editing, or i.e. changing the status of. And that's exactly the same for the delete to-do. When we go ahead and delete a to-do, we're going to need to know the index of the entry in the array that we're going to delete. Now, what I'm going to do in these cases is come into the function and just write my logic before I actually assign these handle events. And the other thing I'm going to do is actually rename this function, this handler function, for clarity, and it's going to be called handle complete to do. But you can just recognize this one as the update slash edit slash modify, as one of the CRUD actions, update. That's what this handler function is for. Now in here, the way that I'm going to do this is similar to how we add a new to-do. I'm going to construct a new list. So I'm going to say let new to-do list equal to an empty array. And we're actually going to do the delete one first because the delete is often slightly easier. So we're going to do the same thing here, let new to-do list equal to, and for the delete one, all we need to do is use the filter array method to filter out the to-do at, the index that we don't want. So that's actually super simple. All we have to do is go todos.filter, and in this case we need the val and the val index in this as arguments for this arrow function. And in here we have to return true or false as to whether or not we keep the entry in the array. And we want to say if the val index is equal to the index, remove it. So in this case, we actually want to say if it's not equal to the index, that's true, keep it. If it is equal to the index, then remove it. And so this condition right here will handle that for us. If the val index is not equal to the index, then that evaluates to true, so we keep it. And if it is in fact equal to index, then we do not keep it. So now we have this new to-do list. We can't modify the original one, but we can overwrite it using the setter function. So I'm going to say set to-dos equal to new to-do list. And now what I can do is take this handler function, pass it down to the to-do list as a prop, just like that. And in this case, we're going to have to pass it into the card. So what I'm going to do here is just use that technique I had earlier, where I'm just going to right here, spread out the props, pass them all down into the to-do card. And that's going to ensure that whatever this to-do list receives are passed down to the to-do card. And then in here, I can destructure out the handler function. Now this is known as prop drilling. Typically, if you're passing props through more than 3 levels of components, you want to use what's known as a global state. We'll learn more about global state later in the final project. But for now, we're within that rule, so it's absolutely fine. And this is a handle delete to do. Now we're going to need to know the index. We'll get that in a second, but this is for the delete button. So we're going to add an on-click event. And as always, that takes a function. And in here, we're going to call the delete handler and pass in the to-do index, which is a property that it turns out we are going to have to pass down. So we're going to need to pass down the to-do index as a prop, save that, and then destructure out the to-do index. And just like that, to summarize what we did, we defined a handler function in the app because that's where we're managing the state. We passed it into the to-do list. We then, inside of the to-do list, recognized that we needed an index. The index is right here. And we need all of that inside of the to-do card. So we passed down the setter function via the spreading of the props to propagate all of the props down to the to-do card. And we also threw in the to-do index so that within the to-do card, we have access to the index, which we need to delete the to-do item. And we also have access to the delete handler function. So if I go ahead and save that, we should now be able to click delete, and we can see that completely eradicates that item from the list. Obviously, if I refresh the page, everything is reset and we have that entry back. But now I should be able to add one, go to the gym, which is exactly what I'll do after this recording. We now have this new entry and I can go ahead and delete it and it is gone. So that logic is working perfectly. Now the handle complete to do is ever so slightly more complex. Instead of deleting the value, we actually need to modify it. So what we're going to do is create a new list and we're going to spread out the previous ones. There's not really an array method we can use for this. And then what we're going to do is we're going to say let new, or actually completed to do, equal to to-dos at that index. So we're going to get the specific to-do that we're completing. We're going to change the complete status. We're going to say completed to-do, and then we're going to access the complete state and set it equal to true. And then we're going to access the new to-do list at the index and overwrite the previous to-do with the completed to-do. That's going to create a new array that changes the state of that to-do, changes the complete status. And then all we have to do is reset the to-dos to the new to-do list and override it using the setter function. So once again, that's slightly complicated. All I've done is I've created a duplicate array, a duplicate list of my to-dos. Then I've accessed the to-do specifically that we're completing. I've modified the status of it. And then in my new list, I updated that entry. So I saved that entry to the new list. And then I overrided my state to match the new list that we've created. So now that I've saved that, we have handle complete to do. That once again needs to get passed down to the to-do list, just like that, similar to the handle delete to do. And then that will be propagated down via the props to the to-do card. And then I can destructure out that function, that handler function. And then I can simply assign it to the button, which takes an arrow function, some logic to be executed. And in here, I pass in the handle complete to do with the to do index. So now if I come back to my list after saving that and say go to the gym, that should be added to my all list. And this should give me the ability to say done. And you will have noticed that it went from the open to the complete tab. And then I could go ahead and delete it. And that's all the logic we need to manage all of the states inside of our application. It's completely reactive now. So I could say go to the gym. I can click add. I could say go to the supermarket and get food. Save that. And I could say pick up the kids from school. Save that. And so now we have one completed, hello, add your first to do. We have 3 open, go to the gym, go to the supermarket and get food, pick up the kids from school. And then in our all list, we can see all of them. I can complete some, I can delete others, and the list is absolutely excellent. Now, obviously the last thing is saving all of this information. It can't all just be lost every time I refresh the page. And adding that functionality to our project is easier than you might think. It's going to rely on 2 concepts. One is known as local storage, which is essentially just a JSON database specific to the web and JavaScript. And the second is a secondary React hook known as useEffect. Now, the trend for hooks in React is that they all start off with use and then the name of the hook. We can also write custom hooks. We'll look at that later in this course. Now, if we just take a second to understand how our application is actually working, that's going to make this data persistence system much easier to implement. So there's a few things happen when we first come to our application. Obviously, we load the page for the first time. Now, the important thing that we need to do in this particular event, the event where we load the page for the first time, is if there are any existing to-dos, we need to read them and add them to our project. Make sure that our project is updated to reflect the saved to-dos. So that's how we implement the reading part of this logic. The next part is the updating, deleting, and saving. So if we make any changes, we then need to make sure they're saved to our local storage database, which we'll learn how that works very shortly, so that when we next refresh the page, be that today, tomorrow, and a week, our application then goes to fetch the to-dos from the database, reads them in, and updates our application to reflect any saved to-dos. And so the moral of that story is that we need a system inside of React that allows us to execute some code whenever our page loads for the first time. Now, if you're not familiar with the mounting of a web application, unfortunately, that process is not as simple as just throwing in the logic right here. This is where we render our to-dos. These are the default to-dos. So it would be reasonable to think that we could just have some logic in here that reads the database and then sets the default to whatever we've read from the database. And unfortunately, that doesn't work, and that ultimately comes down to the order in which our application is actually created for the web page. So if we were to try add this logic right here, the components that we need to access, specifically local storage, haven't actually been initialized yet. And instead, the moment when we need to fetch the to-dos is the instant after the application is completely built and loaded and ready to go. Now, that particular point in time is known as the on-mount event, and all of these kind of events can be accessed via the use effect hook inside of React. So we're going to need to add that to our little import line so that we can access the use effect. Now, use effect is a React hook specifically for tracking events, whether or not it's telling us when the page is loaded and then running some code because the page is loaded, such as fetching data from the database, or, for example, if we wanted to listen to certain events, for example, when the user goes and does something, we can listen for those events and then run some code immediately afterwards. So it's super handy and it's very common. Now, the way that use effect works is we import the hook as we have here. And you don't want a million use effects. It's best if you can get away with just one. And in this case, we will be doing exactly that. But what we're going to need to do here is invoke the use effect hook. Now, I like to place my use effect directly above my JSX. It's kind of the last thing we go through in our logic. And it takes two arguments. The first is an arrow function. That's the first argument for our use effect. We can comma separate the arguments, and the second one is an array. Now, the array is known as the dependency array. And this, depending on what contents it contains, determines when the use effect logic gets called and when this function gets executed. So if I leave this dependency array completely blank, which we plan on doing for now, that's telling the use effect to run as soon as the page is available. So that's essentially the on-mount event. And what we can do is specify the logic we want executed just in here, inside of this function, to be called dependent on what events we're waiting for. So in this case, we need access to local storage, and that is native to JavaScript. But in this case, for security, I like to run a check. It's called a guard clause. And so I'm going to say in here, if not local storage, and then I'm just going to return. Now, what this little check does is a guard clause, and it says if local storage is not available for us, if we're not ready to access the database, then just exit out of this and wait until it is. So that's a little protective clause just to stop us getting any potential errors going to read from the database. The next thing I'm going to do is define a variable called db, and that is going to be an empty array. Now, once I've got db, then what I'm going to do is actually go to the database. I'm going to say if local storage, and I'm going to get an item. Now, this .get item is a method. It's a function to be invoked, and all we have to do is tell it the label of the data that we want to fetch. It's basically a JSON database, so we just give it the key, the unique key under which all of our information is saved. And in this case, I'm going to call it Todo App. Now, obviously, the key should be unique, so you don't want to have the Todo App for 100 different local storage databases, otherwise you'll always overwrite them. But this just here should be absolutely satisfactory. Now, what this line of code right here is going to do is it's going to check our database and look for the key Todo App. And if it exists, then we can actually go ahead and say database is equal to exactly that. We can get the item Todo App. Now, when we save to this database, we save it as JSON. So when we read from the database, we read it as JSON, which means we then need to pass whatever gets read from the database. Now, what I think we can do to make this code even cleaner is actually add this line to our guard clause. So we could say if not local storage or not local storage.get item Todo App, then we could actually just return, and that allows us to remove these lines right here, which is pretty cool. So that actually just tidied up our code a little bit more. And once again, to explain what I just did here is I updated our guard clause to check if there's no local storage, or in the case where there is local storage, if we can't find the item to do app, if we try to get the item to do app and it's not there, that returns undefined. So that will trigger this clause and return from it. In the case where we both have the item to do app and we have access to that database, then we can basically pass in the JSON. It's a JSON database. We can pass that, assign it to our database, and now what we can do is we can set to-dos equal to database.todos. Now this code right here, when I go ahead and save it and reload the page, appears to have worked perfectly. But currently, if I throw in a console.log here, we'll just say console.log here, we're not going to get anything executing because we don't have anything saved to our to-do app. So what we're also going to have to now do is add a save function where anytime we make an adjustment to our new to-dos or our to-do list, that is persisted inside of our database. So I'm going to define that right here, function, and it's just going to be called handle save data. And in this function, all I'm going to do is say local storage, and I'm going to use the set item method, and in here we pass in the key that we want to assign the information to, and now we pass in an object, and in this case it's just going to be our to-dos. So this is the object literal syntax, where basically it's as if I were to assign my to-do list to a key to-dos, but it's just a shorthand syntax. So this object is going to have the key to-dos, and it's going to have the value of the to-do list. Now the reason I have to make this an object is because I then have to stringify it to JSON. So I have to wrap it in the circular parentheses and call the JSON.stringify method on our little object right here. And this is going to stringify our to-do list and save it to our to-do app. So now that we've created this function, I'm actually going to make one more adjustment to it. Instead of reading the state, what I'm instead going to do is pass in an argument, because that's going to ensure we always have the latest data. So I'm just going to call that current to-dos, like so. And now what I'm going to do is actually assign current to-dos to the key to-dos. And with that final adjustment, we're now ready to add this function, the save data function, to every single basically data manipulation method that we make. So when we go and add to-dos, we need to call handle save data, and we're going to pass in the new to-do list. When we go and complete a to-do, we're going to do the exact same thing. After we've updated all of the screen, all of the states, we're then going to save our new to-do list. And the same with handle delete to-dos. We're just going to go ahead and save the data, passing in the new to-do list, which will match what is then set as the state, which will be reflected on the screen. And so with these simple changes, when I come back and refresh the page, now what we're going to do is come across to the developer tools. So if we right click on the page and go to inspect, that's going to bring up the Chrome developer tools or whatever browser you're in. And you're going to look for application. Now inside of application, you'll see storage and you'll see local storage. That's our database. And if we click on our web name, we can see there's nothing saved in our database. And there's a good reason for that. Basically, as of yet, we haven't invoked any of these functions right here, which means that no data has been saved. But if I come in here and say, go to the gym, add that, you might have seen over here that the key was in fact added. We now have to-do app, and in here we have our little JSON database. Also note quickly that we've never run this console.log, which means we've never found the item to-do app. But if I now refresh the page, since we've confirmed the data is saved in the database, we can see we do in fact get that use effect being executed and printing out that we're here. Now the reason it's printed out twice is specifically because of this strict mode, React strict mode. And that's just for development. When we go and deploy this application, that won't be an issue. If we were getting 4 instances of it, then we'd have some kind of inefficient programming going on. Typically, you only want your use effect running the bare minimum number of times, which in development mode would be 2, and in production 1, dependent on the number of use effects that you have and what they're doing. But just like that, to summarize, we have essentially added in data persistence to our application via this use effect hook and also the local storage JSON database. Now, as I said earlier, the use effect hook, when invoked, takes 2 arguments. The first is a callback function to be executed when the event that we are tracking is triggered, and we can determine which event that is via the dependency array, which is the second argument to the use effect. In this case, it's empty. That means that whenever the application is ready and loaded on the screen, run this code. And if we didn't have this, local storage wouldn't be available to us for us to then go and basically assign it to our state and ensure that our state matches our saved information. So it's super helpful. Just to demonstrate, if I wanted to track every time to-dos gets adjusted, I could just add to-dos in here. And now this use effect would only run when the value of the stateful variable to-dos changes. So it's pretty cool. It can be a bit complex when you first encounter it, but as we continue throughout this course, it will become more and more familiar and start to make a whole lot more sense. So that's data persistence done. We're going to go ahead and delete that console log because it is not necessary over there. That's looking super clean. Refresh the page. And now we have data persistence added. Now, there is one small bug in this application that we need to resolve, and that's to do with the filtering of our cards. When we complete a to-do, we hand in the to-do index, but the to-do index depends on what ones we're currently filtering out. So what we have to make sure we're doing is, instead of using the filtered to-do list, we have to find the index in the original array. And so where we render out this to-do card, which is within the to-do list, the to-do index right here should actually look for the index in the original array and not the filtered array. And so all we instead have to do is look through the original to-do list array, and we just have to find the value where the value.input is equal to the to-do.input. And actually that should be find index, not just find. And so now if we go ahead and save that and come back to our application, we can click done in here. But if I add another one, which is where it's going to be buggy, and say finish React.JS course, click add. Now that's added. If I come to open, that should match the original index. And so now when I click done in here, it is completed and that is updated. And with that done, it is time to deploy the application. So for deploying this application, you're going to need GitHub. Now I have a link to a GitHub video in the description down below if you have no idea what GitHub is. It's just an online cloud storage for saving your code. You can think of it when you have a Google document, you make revisions, Google Docs tracks all of those revisions. GitHub is just the same thing except for all of your code. Now, if you don't know Git is a terminal language to make using GitHub easier. You can also download GitHub Desktop. This will also be linked in the description down below. And that's what I'm going to be using in this instance. Obviously, also you will need to create a GitHub account. That can be done by coming over to github.com. Just create an account, sign up, and then you might need to connect GitHub Desktop with your GitHub account if you haven't already. So I've got that installed on my computer and I've opened up a window of GitHub Desktop. And what we're going to do over here is all of our repositories, which is just basically a code project. We're going to select the little down arrow and add a new project to our window, add the existing project. It says add the local repo. We have to choose the path. So we come into our folder options. And in here, I'm just going to the folder where I create all of my coding projects. I'm looking for the React full course. And specifically, this to-do app. Now for this to-do app, once I've selected the project, don't select within the project, just select the project and then click the open button, which is right beside the cancel, just behind my head. If we hit open, it's going to say there does not appear to be a Git repo here. We're going to say create one for us, initialize it with a readme.md, that just explains the project. And in here, what we're going to do is add a description, and it's just going to say React.JS to-do app with FantaCSS and local storage. A little description, nice and neat. And then we're going to hit the create repo button. GitHub Desktop's going to handle all the magic. And then the last button we need to push is publish repository. And in this case, I'm going to make this code public. When we hit publish, it's told me this is going to fail because a React app under this name already exists for me. That should have worked for you. I'm just going to add a React full course to the end of it. So we're going to publish that, and that's going to save it to GitHub. Now with that push to our repo, we should be able to come across to your profile and you can see the to-do app right there. And we're going to need that in GitHub for the next step, which is deploying it. And we're going to use Netlify to deploy our application. Now you'll need to also have an account with Netlify. The link is in the description down below. It's totally free, it won't cost you anything. We're going to log in. I obviously already have an account. And deploying with Netlify is insanely easy. What we're going to do is click this add new site button, and we're going to import an existing project, and we're going to do that from GitHub. That's going to ask you to authorize your account. And once you're authorized, it's going to load in all of your projects. Now you can search through them. I have 100 million of them. If you can't see your project there, scroll down to the bottom and click this configure the Netlify app on GitHub. Once you've authenticated, you should be able to come over to a page that looks a little bit like this. If we scroll down to the bottom, it will say repo access, and it will say only select repos. In this case, I should honestly just say all repos, but I'm going to select a new one, and it's going to be to-do app RFC, and I'm going to go ahead and hit save, and that's now going to make that repo available inside of Netlify. So we can just search for it, to-do app, right here. Scroll down. It's going to come up with some settings. We don't need to touch any of them. It should actually automatically recognize that this is a React.JS application, sort out all the build stuff. All we need to do is scroll down and hit this deploy to-do app-RFC, or whatever it is that you've called it. And that's going to go and publish our site to the internet. We can see it's in progress here. Now the last thing we're going to do is come over to domain management, and here Netlify gives you some random domains until you add your own one. Now obviously if you own a custom domain, you can add that in. In this case, we're just going to say options and edit the site name. And here, the sky's the limit in terms of what you can name it. I'm just going to call this one super-cool-to-do-app. Now that's going to be unique and that will be taken, so if you try to steal that, I got it first. But obviously whatever you want to call it, save that, and then that is the link for your project. So we can now click on that. Our application is successfully deployed. You can check that by coming over to deploys. We can see that it is officially published, and now that is live on the internet. And this is a link that you can send to anybody. And even better than that, every time you make changes to your code and publish them via GitHub Desktop, your code will be automatically redeployed so that the changes are reflected in the production version. So it means that you have what's known as CI/CD pipeline. Essentially, when you publish your code to GitHub, the deployment automatically happens and all of your changes are then made live. So it's super convenient. And just like that, we have a beautiful app. If I add one in, I could say go to the supermarket and buy apples. Now I can click the plus button, and if I go ahead and refresh that page, we can see our database works perfectly. I can say done, And once again, those changes are persisted on page reload. Now at this point, congratulations, you have officially finished project number 1. If you haven't already, if you go over to the GitHub, make sure you star it, love that support. And also, I challenge you to make your own adjustments at this point. Have a fiddle with the styles, the layout, some of the functionality. Perhaps you could add in an edit functionality. That would be pretty cool. Instead of deleting them, you could change this so it's edit. The way that I would recommend doing this is simply by coming back into the app and adding in a new handler function. And typically a good way to add an edit functionality inside of this handler function is just to filter out the current one, take the current value, and set the input text equal to what it was, because then the user can just go and edit it very simply and re-add it, and it's totally updated. But that's just a little challenge I'd recommend giving a shot. Make some modifications, get creative, because that's where you'll really start to consolidate your skills. And also be sure to add this project to your portfolio, add a GitHub link so that employers can see it and they can be super wowed and impressed. Likewise, if you want to share this with me, you're more than welcome to. I'd love to see what you guys end up making. I'm pretty active on LinkedIn. You can tag either myself personally or the Small James Education page. Love to see it. And once again, well done on completing project number 1. It's time to move on to project number 2, the Pokemon Pokedex. So it is now time to dive into project number 2, which should be absolutely wicked. We'll encounter some of the stuff we've already seen in project number 1, and we'll also build upon that with some additional React functionality, such as how we can fetch data, all sorts of cool stuff as we build out this Pokedex. Now for this project, I've opened up a completely new blank instance of Visual Studio Code. And what we're going to do is we're going to hit open, and we're once again going to navigate to our React full course project directory. Once we've found that, it's inside my folder with all of my coding projects, I'm going to click the open button, and that's going to open up VS Code into our React full course folder. And we can see in here we have the first project, which is the Todo App. That's all complete. And we also have some of this code open, which we're just going to go ahead and close if that's happened for you. Now from within here, we're also going to need to open up a terminal. If you're looking for all of the terminal commands, be sure to come over to the VS Code shortcuts.smalljames.com. It has everything on, how you can basically become a VS Code wizard. And to open the terminal, we're just going to hit the Control plus backtick keys, and that is going to bring up a terminal for us. Now, just like with the previous project, the first thing we have to do is actually initialize a new React project, and we're once again going to do that with Vite, which, as always, is linked in the description down below. And if you come to this page, the command we're going to need is a Node Package Manager command, where we create a Vite project. Now we're going to go ahead and type this into our terminal, npm create Vite at latest, that's just for the latest version of Vite. And then we're going to have a space, and we're going to name our project Pokedex. I'm going to hit enter on that. It's going to ask us to select a framework. I'm going to come to the React framework, and I'm going to choose JavaScript. Now, lucky us, we have the commands to get started with our project. We're going to cd into Pokedex. So that's the change directory command into Pokedex. And then we're going to run npm install, which is just going to install all of the packages, node packages that we're going to need for our React project. You can actually come and see them if you open up this Pokedex folder. You'll see all of the code that comes with a boilerplate React project. And inside of the package.json, we can see that the npm packages, which are also referred to as dependencies, are basically just React. So it's super simple, and that is going to get everything running. And now we're basically ready for the last step, where we just have to run npm run dev. But just before we do that, let's quickly go over these folders again. We did it before, but we're just going to do it once more real quickly. So first we have the vite.config. We don't need to touch it. It's just saying that we have a vite/react project. After that, we have the readme.md. These will all be filled out at the end of the course. I'd recommend throwing these in because if an employer is looking at your projects, it's a great place for you to give them a text overview of what you've done, why you've done it, and how you have gone about doing it. So that can be super cool. readme.md uses the .markdown syntax if you weren't familiar, and it's basically just a simple text formatting language. I actually have a course on it linked in the description down below if you want to become a Markdown pro. After that, we have the package.json. That's just got some important information for configuring our project. We have the package-lock.json, which we do not touch. We have the index.html, which is where all of the React code gets rendered within this root div via the main.jsx script, which is inside the source folder, which renders out our app, which we can find in the app.javascript. And when we come into the app.javascript, which is the parent of our entire application, we can see we've got some boilerplate code, and we're just going to get rid of absolutely everything. We're going to blank it all out because we don't need any of it until all we have is the bare bones of a React functional component. The functional component is just a function. It's called the app, and from within it, we return the JSX that then gets rendered on the screen. Now we can also get rid of this app.css. We don't need it. We're going to use FantaCSS for this project as well. All of the styles are once again pre-completed for you. All you have to do is come over to the index.css file inside of the GitHub repo. Don't forget to star the repo if you haven't. Love that support. And either download the file directly from there into this folder, or you can just copy the styles across like I'm about to do. So here I'm going to copy all of the styles across. It should be about 276 lines of styles. This is all for the layout. And then we're going to also need to download the fanta.css file, which once again should be available inside of this repo, or you can go to the FantaCSS repo. And I'm just going to paste that in here. So we've got our CSS files. We've got a blank app.jsx. We don't need to touch the main, except for importing the new FantaCSS styles. So we're just going to go ahead and import fanta.css. Now, with all of that done, we can boot up our application by coming back to the terminal and running npm run dev. That's going to start up your project, I presume, on localhost 5173. And we can go ahead and paste that into the browser, and that's just going to load up our blank application. And we can check that it's working by coming into the app inside of the JSX. You can just write something, save the file, and that is now loaded onto the screen. Excellent. Now for the Pokedex, we're going to introduce a new concept in this video, which is how we can fetch data from an external source known as an API. And the API in question is the Poke API. So if we Google that, once again, linked in the description down below, we can load that up, and it's a RESTful API that serves over 2.5 billion API calls per month. Now, if you're not familiar with APIs, all that happens is your website basically makes a call, a network request to someone else's body of code that is linked or connected to the internet. And when you send that request, they basically just send you back a whole lot of data. So it's super efficient. And in our application, we do that very simply. If you think about our use effect in the previous project, that was used to read in information from our database when our application is good to go. This works very similarly. We could almost think of this REST API as a database, an external database that we can access. You can try it out here. You can kind of see how the URLs work, how to make the requests, what the information that you get back looks like, and that is what we're going to be implementing into our project. Now, the other thing we're going to need for our React project is a whole lot of components. So what I'm going to do first, inside the source directory, I'm going to create a new folder called components. Now for this project, we'll need a few of them. We're going to need a header.jsx, which is obviously the file extension. And there we're going to export a function called header. And that's just going to, for the minute, return the header tags. A simple 5 lines of code, and we have our first React functional component. Now when I'm making these, you'll notice that each component is basically one of the building blocks of our application. And that for me is like a great way to practice compartmentalizing the different pieces that come together to build an effective application. The second one on our list is going to be the side nav.jsx. Now notice that the nav is capitalized as well. And once again, in here, we're going to export a function called side nav. And that's going to return the nav HTML tags. Now this nav is going to basically render out all the different Pokemon from the original 151 Pokemon in the first Pokedex. And then the user is going to be able to select different Pokemon and get the breakdown of all the stats, all the different moves, see all the pictures, and it's going to be wicked. Obviously, when they've clicked on one of the projects, we're going to need a pokecard.jsx. And in here, once again, we're going to export a function called pokecard, and that's going to, just in this case, return an empty div. And this is going to contain all of the Pokemon information. After that, we're going to have the typecard.jsx. And here we're going to export the function type card, enter that onto a new line, and just return an empty div. Now the type card is a little component I made specifically for the code that is used to render out the type of Pokemon. If it's poison, if it's flying, if it's steel, if it's normal, if it's water, ice dragon, so on and so forth. And then last but not least, and this is going to be a new component, modal.jsx. And in here we're going to just export that function modal. And in this case, we're going to just type the return keyword. And for the second, we're not going to return anything from this modal. Now, if you're not familiar with what a modal is inside of React, it's basically just a pop-up overlay on the screen. And they can be super helpful. And in this case, this pop-up is going to allow a user to click on a skill or a move that a Pokemon is able to learn, and then get a breakdown, a text description of what that move actually is as an overlay that they can then click out of afterwards. And with that all done, those are the components complete for this project. Now there's another configuration folder that we have to set up in just a second that is new. But before that, the other thing I want to mention is that in this project, we're also going to learn how to cache information that we have searched from an external site. And the reason we're going to do that is because if you don't cache the information, where a cache just refers to saving it locally, and we're going to use the same local storage database that we used in the previous instance, what can end up happening is you can end up overwhelming, let's say 100 people use your site and they're all fetching information from the Pokemon API. You could end up DDoSing them, which means overwhelming their servers with a number of fetch requests saying like, get me this Pokemon, get me this Pokemon. And if you do that thousands of times, they can block you. So what we end up doing is we cache everything that we fetch, which means that we only have to fetch the information for each Pokemon once. And after that, we have our own, we basically build up our own database, and then we can just access it locally and we don't have to overwhelm their servers. So that'll be super cool. Now the last thing we're going to need to create inside of our source directory is another folder, and this one is called utils. Now utils folders are typically for any kind of utility function or JavaScript that you're going to have. And we have a fair amount of utility necessary for this project. In here we're going to create a file. It's a JavaScript file using the .js extension called index. Now we're going to hit enter on that file, and I'm just going to go ahead and copy it straight from the repo, so you can look for this folder and file and just copy everything into this file, and now we're going to have a breakdown once that's copied across of what everything does. So first up, we have a list of the first 151 Pokemon, which we need in order to be able to render out that side nav. So we're going to return basically a button for every Pokemon, which allows the user to click on a Pokemon and then consequently show up all the information. Underneath that, we have some color specification information, and these are for all of the types which will be relevant in this type card component. So when we render out the little tile for a water Pokemon, it's got the text color in addition to the background color to create the appropriate tile. Now these are just super annoying admin colors that I wanted to have basically done in advance, so it's good just to have them available when we go and do that. Underneath that, we just have two functions. The first one is to get the Pokedex number, and the reason we've got this function is because JavaScript is a zeroth indexing system. So when we go and render out that side navigation using the mapping syntax, we're going to get access to the index, which is going to start from 0, but the Pokemon start with 1. So when we want to get the number of a Pokemon, all we have to do is find the index and add 1 onto it. And I created a function for it just to add all the clarity that we possibly can. And then the last function we have down here is to get the full Pokedex number. And this is just some string formatting where basically all of the Pokemon are 3 digits. Even if it's the first Pokemon, it's 001. Obviously, if we just get the Pokemon number, it might just return 7. And so this is just some string syntaxing that will throw in the extra zeros so that we always have a 3-digit number. And those are our utility functions and objects and arrays for this project. So that's pretty cool. All of that is done. I'm going to go ahead and close that file, and now we have open our main components. So we're going to start at the top of the application inside of the app.jsx. And in here, what we are going to do is start off by rendering out the components. Right here I've got James. James is not going to be a part of this application. The first one we're going to render out is the header component. Now I'm going to take advantage of the auto import, and that is going to be self-closing. After that, we're going to have the side nav component. Make sure we import that up the top, and that is also self-closing. And then under that, finally, we're going to have the Poke card component, which is going to have all of the Pokemon information in our application. Now, if I go and save these and come back into our application, it's still completely blank, and that's because these are currently empty components. And the other thing I'm quickly going to do at this point is just change the title of our application, which, if you recall, is inside of the meta information, which is contained within the head tags, which is in the index.html. In here, we're just going to change this to your name. So this is going to be James's Pokedex. Very nice and simple, and I'm actually going to use the special E with the right-hand side thing, and that's going to now change that to James's Pokedex. So that's looking pretty good. We have a totally blank application, but we've configured just about everything. So since we've got all of these components rendered, and the first one I'm actually going to start off with is the side nav. Now this project is a little bit clever because in making it mobile responsive, we have some elements chop and change as to whether or not they show up on the screen. So the side nav is going to be the primary navigation method on the larger device size, whereas the header is going to be the start of the navigation system for the mobile device size. And this is all going to become very clear as we build it out, but just for the bigger screen, I'm going to start off with the side nav. Now, if we come into that component right there, we can see it's very simply just got these two little nav tags. And what we're going to need inside of this side nav is access to all of the Pokemon. So what we're going to do is now import the first 151 Pokemon from that utils folder. Now, one interesting thing that you might notice is that I obviously don't specify the index.javascript in the path for the file. And the reason I can get away with doing that is specifically because any file called index is the default export from that folder. So basically, if I'm just wanting to have one file inside of this utils folder, if I name it index, then I don't have to specify it. I can just import the folder as if it were actually the file. Now the nav is going to be pretty straightforward. First, what we're going to do is get all the Pokemon rendering on the screen. So I'm going to use the curly braces to add some JavaScript inside of the JSX, which is going to allow me to map out the array of Pokemon. So we're going to access that and use the map method, which takes the arrow function. Now in here, we're going to return from the arrow function a button, and that's going to allow the user to click on the Pokemon. Now this mapping function is going to need some arguments. The first one is obviously the actual Pokemon, which is the element or the entry in that index of the array. And the second one we're going to access is the Pokemon index, which is the index in the array, which is also going to allow us to access the Pokemon number or the number of the Pokemon in the Pokedex. So we're going to expect those two things as arguments. And now in here, what we can do is just create some paragraph tags, use the curly braces, and throw in the Pokemon. And if I go ahead and save that and reload the page, we can see that we now have a big old list of Pokemon on the side of our application. Now the styling is a bit random because we haven't added a whole lot of classes, and we'll tidy that up in just a second. But that right there is our side nav with 151 Pokemon that a user can go and select that will be displayed in here. So how handy is that? All we had to do is write out, a good 5 lines of code, and we've got 151 buttons available to us. Now the other thing I'm going to have within the button is some more JavaScript that's within a paragraph. So we're going to have another paragraph tag, and that's also going to have the curly braces because it's JavaScript. And in here we're going to call our utility function get full Pokedex number, hit enter so that we automatically import that up the top. And we can invoke that function with the circular parentheses, and we can pass in the Pokemon index, and that's going to return the string formatted Pokemon index. So now we've got 001 all the way up to 151, which is Mew. After that, we're going to give this button some classes, and that is going to be class equal to, and I'm actually going to backspace the strings here and use the curly parentheses because this is going to be a dynamic class name that we're going to add some stuff to later. And then I'm going to create the starter string, and this is going to be the default, and I'm just going to give that the class of navcard. And now all of these just look a bit cleaner, and you can see we have a slight hover effect. Now above all this stuff inside of our nav, we're going to have a div. And this div is going to have a class of header, and it's also going to be wrapped within the curly braces. Now at this point, I just want to make a reminder that all of the classes, when I use the keyword class, it's obviously meant to be the class name. And that is the attribute that gets added to the opening tag to apply these styles. Now within here, we're going to need an h1 tag, and that is going to have the class name equal to text gradient, and that's going to have the text pokey, where the E is actually this E. So I realize I made that mistake earlier. The first E is the accented E, and now that's going to show up at the top of our list, super clean. And then underneath this div, we're going to have an input, and that's just going to be a self-closing tag, and that's going to let a user search for a Pokemon at a later point. So just like that, we actually have a pretty tidy looking side navigation bar. So I'm super pleased about that. Very nice. Now with that done, we're actually going to get straight into the nitty-gritty, which is all of the fetching information and also how we can cache that information. And that's possibly going to be the biggest part of this entire project. So because it's slightly more complicated, we're really going to take a second to break everything down. And before we dive into that, I realize we're quickly going to come back into the index.html and swap these E's around because we can't have them the wrong way around, the Pokedex. And that is now correct. That's the accented E. So to dive into fetching data from an API, specifically the Pokedex API, where the Pokedex API is basically just an external database that we create a network request to request the information, the data, from the API. We first need to understand where we're going to have all of this code. And if we're getting a whole lot of data, it ultimately comes down to where do we need this data in our application. And so if we quickly run through all of our components, we have a header, which we haven't really coded out yet, but I can tell you it doesn't need this information. We have a modal. We also don't need it there. We do need it inside of the Pokedex. We don't need it in the side nav, and the type card is a subset of the poker card. So the moral of the story is that we're going to initialize all of this logic inside of the poke card. Now the other thing that's important is the data we're fetching is dependent on which Pokemon is selected. And that is something that the user is going to be able to interact with, which should prompt you, and gradually will over time, to think that we're going to need to initialize a stateful variable, which in this case is going to be named selected Pokemon, so that the user can select the Pokemon they want to research. Now in this case, we will need the information in the header and the side nav and the poke card. And because we can't communicate that information horizontally across components, we can only do it from parent to child. We're going to have to define that inside of the app. Now, the first thing we need to do to initialize a stateful variable is import and destructure out the useState React hook from the React package. So we have the curly braces and then we have useState. And then within the functional component, we can now initialize that stateful variable. We can say const selected Pokemon, and that goes within the square braces. And then the second entry in the array is the setter function, which is just set selected Pokemon. And that is equal to useState. We call the hook, and I'm going to initialize it at the index 0. For the 0th index in our Pokemon list, which I believe is Bulbasaur. That's going to be the first Pokemon. So the default Pokemon that is shown is always going to be Bulbasaur. So now that we have initialized this variable, we're going to pass it everywhere it's needed, which is going to be inside of the side nav. So we're going to pass it down as an attribute style prop. We're going to label that information selected Pokemon, and we're going to provide the value, which is going to be the currently selected Pokemon. We're also going to need to pass down the setter function. So we're going to say set selected Pokemon, and we're going to assign the setter function to that key or that attribute style prop. And likewise with the poke card, we're going to just need the selected Pokemon, because within there, we're going to fetch all the information about that particular Pokemon. Now, I'm not going to worry about receiving the props in the side nav just yet. We'll get to that shortly. We're just going to focus on fetching the data for, in this case, the very first Pokemon, because that's what is currently selected, even though it's default. So just here, we've passed down the selected Pokemon information via the attribute style props. So what we now need to do is come across to that component and let it know that it needs to receive the props or the information. And from within them, we can destructure out the selected Pokemon. So we use the destructuring JavaScript syntax, and that's going to give us access to the Pokemon. Now, if you recall back to what I said in this video earlier about when we fetch the information, and even further back to our to-do list, we fetch the information to display on the screen once our application is fully loaded, and we do it using the useEffect React hook. So the next thing I'm going to do is come up to the top of my component above where we actually define the component, and I'm going to import the useEffect hook from the React package. Now, if you recall to our first video, the way the use effect works is we invoke it, and it takes two inputs. The first is a callback function. It's the function to be executed whenever the event that we're listening for is triggered. The second input, or argument, is the dependency array. And that is, you can actually see it here, we have the React dependency list. And in this case, if present, effect will only activate if the values in the list change. So that's super handy. And so the question becomes, what events are we listening for? Well, we're listening for whenever the selected Pokemon event changes. Because whenever we change that event, we're going to need to re-download or refetch the new information for the new Pokemon. So we're going to throw the variable selected Pokemon into that dependency array. Now, what I'm going to do next is open up this callback function, the logic to be executed whenever the event that we're listening for is triggered, in this case, whenever selected Pokemon changes. And we're going to start off by writing some pseudocode to break down exactly how this data fetching process, in addition to caching the information, is going to work. So I'm going to leave a whole lot of code comments to walk us through this process. First up, what we're going to do is we're going to have a loading state. So we're going to say if loading, exit loop, because we don't want to refetch multiple times if we're already loading information. And that should actually be exit logic. After that, what we're going to do is we've established we're not currently loading anything, so we're safe to go and fetch information. We need to see if we can access that information from the cache, which means that we've already got it before and we can withhold from fetching new information from the API. So we need to check if the selected Pokemon information is available in the cache. Now this is going to happen in a few steps. First, we need to define the cache. And then the second is to check if the selected Pokemon is in the cache, otherwise fetch from the API. And then if we do fetch from the API, the third step is pretty much to, actually I'm just going to write this out. If we fetch from the API, make sure to save the information to the cache for next time. And these three steps are going to prevent us from basically getting banned from the API, and we're going to have a very efficient application. It's so important to learn to cache appropriate information. Now, you don't want to cache everything for all different projects. Caching only exists when you can guarantee that the information you're fetching changes very infrequently. So it's pretty much the same for all of eternity, such as the information about the first 151 Pokemon. Now, the other things we're going to need for this data fetching process is some stateful variables. And these are things that are going to be very interactive, and that's how we know that they need state. And the first one we're going to define is going to be const data. And that's going to be the actual Pokemon information. So we're going to define a stateful variable. It's going to be data and set data inside of the square parentheses. And that's going to be use state. And when we're fetching data, I like to set the default to null. Now, the reason I like to set it to null is because it just makes it very clear when we do and do not have Pokemon available. After that, we're going to need a secondary state, and that's called loading, and set loading equal to use state, and that's going to be by default false. Because when we first load the page, we're not loading anything, then we go and fetch the information, at which time we start loading stuff. Now you can define a third state called useError. I'm not going to do that in this case. I'm going to, at a later point, show you how I like to manage errors inside of React. So these two states for the minute should do it for us. And that means we can complete the first step inside of our use effect by saying, adding a guard clause, if we are loading, if loading is true, return, if I can spell that correctly, and exit out of this code block. And that just means that if we're already fetching information, this doesn't continually get executed, because we'll catch this guard clause and we'll just return out of it, and it's going to ensure that we don't get any weird errors or, parallel events with race conditions and all that kind of complex stuff. So that's the first step done. Now we come to the next step, and we have to check or initialize our cache so that we can check if our information is available. Now I'm going to add something to this guard clause using the or condition, and I'm going to say if we don't have access to local storage. So if loading is true, or we do not, we use the not key in front of local storage, then we want to return. And the reason we're doing this is because we're about to check local storage, which is our cache database. So if it doesn't exist, we're not ready for this logic to be run, and we want to exit out of this useEffect callback function. So what we can do now is, since we've guaranteed that if we get past that guard clause, local storage exists, we can define our cache. Now I like to make my caches very simple. I'm just going to say let cache equal to an object. Now the reason we're going to use an object is because if we come over to the Poke API and submit, we can see that the information we're going to get back for the Ditto Pokemon, for example, is an object. Here we have this object. We can view the raw JSON. It's an object data type, and so that's why I'm defining my cache as an object. Also, because the JSON database that we're caching the information within is also an object once we pass it from JSON into an object. So we're going to define the cache as an empty object. After that, we're going to have some logic that says if local storage.getItem, and we're going to access the Pokedex. Now, if we do find something when we look up the Pokedex within the local storage cache, then we can guarantee that we have cached something before, and that database exists. So now what we can do is overwrite this empty object cache, and we can say local storage.getItem Pokedex. So we can literally get the item, which is the Pokedex, the cached Pokedex, and that is going to be returned as JSON. So we now have to pass that information. And that's going to update our cache so that if the cache does exist, if the local database does exist, we now have access to all of that information. So we've defined the cache. Now what we can do is say if selected Pokemon in the cache, then in here we can read from cache, and else we can fetch the information. So how this is going to work is we're going to say if selected Pokemon is in cache, then all we need to do is set data equal to cache and target the selected Pokemon, because that's going to access the data specific to that selected Pokemon from within the cache. Now, I've actually made a slight call. I'm going to change something just here. If we did find the information in the cache, what I'm actually going to do instead is turn this into a guard clause and return out of here. And that just saves me having an else block, and it makes my code a little bit neater. And instead, if we get past this clause right here, that means that we've done everything we need to check the cache. It doesn't exist, so we have to go and fetch the data from the API. So here, we passed all the cache stuff to no avail, and now need to fetch the data from the API. Now to do that inside of a useEffect, we define a fetch data function, and then we invoke that function. So here I'm going to define a function, async function, and it's just going to be called fetch Pokemon data. Pretty straightforward. Now when I'm fetching data from an API, I love to use a try, catch, and finally block. And what this provides is a whole lot of error handling for our fetching of data. So we try some logic, If we get an error, we catch it, and in here we can console.log the error.message. That's going to show us the message if we receive one. And then at the end, we can set the loading to false, where at the start of invoking this function, we can set the loading equal to true. And just like that, we nearly have all the logic we need to go and fetch the information, with exception to the actual fetching of the information. Now, what we need to fetch data from an API is first off what I like to refer to as the base URL. And that's just a string. And in this case, the string is this one right here. This is the API where we're fetching this information from. I also like to define the suffix, which is the specific part, which is pretty much this here. So Pokemon/ditto. Except in our case, it's going to be Pokemon/ plus the selected Pokemon. So then what we can do is we can construct a final URL, which is where we're going to fetch the information from, and that's going to be the base URL plus the suffix. And then what we can do is we can define our fetch data. Now here, we're going to use the fetch API, so we say const response is equal to await. We use the async await syntax because this is an asynchronous process, and we call the fetch API, and all we do is we pass in the final URL. When we execute this line of code, we're going to send that network request to the API, fetch the data, and that's going to be assigned to the response, where we can then access the Pokemon data from the response by awaiting the res.json method. And then all we have to do from here is set data equal to the Pokemon data. And that's going to do the same thing as fetching from the cache. We now set the data equal to the Pokemon data. And the last thing we have to do is update the cache. So we now have the cache. We're going to update the cache at selected Pokemon. That's equal to the data that we've just fetched. And then we just need to say local storage.setItem, and then we just json.stringify the cache. And that's going to cache the information we've just fetched. So the next time we run this, we can just fetch it from the cache instead of from the API. Now the last line before I run over this whole process once more, over everything that we've done, is we now come to the bottom of this function, and we just have to invoke the fetch Pokemon data. Just like that. That is our data fetching process done. Now let's go over it once more to make sure we completely understand what has just happened. So for step one, we realize that we need to use a use effect because we need some code to go out and fetch new Pokemon data whenever the event where a user clicks a new Pokemon is triggered. So when a new Pokemon is selected, the value of selected Pokemon changes. We need the code to be executed, so we just think use effect. We listen for that event. Once we've initialized our use effect, we add a callback function where the callback function is the logic to be executed when that event occurs. And the first thing we do is we have a guard clause where we say if we're currently loading information, we don't want to load more information, or if we don't have access to our cache, which is our local storage, then we just want to exit out of this. We want to return out, and we just want to stop executing this logic. So we add this guard clause. If we get past the guard clause, then we know that we can, in fact, access the cache. So we define an empty cache, and then we go to the local storage to see if we have any information saved to the string Pokedex. If we do actually get an item under the name Pokedex, then we confirm that we have that information. So we can get that out, pass it, because currently it's JSON, we pass it into an object, and then we update the cache to now be equal to that entire cached Pokedex. Now that we have the cache, we simply check if the selected Pokemon is in the cache. If it is, we update this state to match the value. We fetch it from the cache, and we set that new state to match, and we exit out of this whole code block because we've just gone and fetched the information. If we get past this code, then we don't have access to that Pokemon in the cache. Maybe there's no cache, or maybe we just haven't cached that specific Pokemon. So now we define the logic we need to go and actually fetch the information from the API. So we create an asynchronous function called fetch Pokemon data. And when we initialize or invoke this function, which we do down here, the first thing we do is we set loading to true. And that way, if we encounter or execute this code block again, we're going to exit out of it because it's currently loading. So we say we're loading some information. We define exactly where we're going to load that information or fetch that information from. And then we simply fetch from that API. And then when we get the response from the API with the information, we basically access the JSON from within the response object, and then we assign the Pokemon data to our state. The screen updates to match, and then we also add that new information about that specific Pokemon that we've just fetched. We add it to our cache, and then we update our cache, or basically save it to local storage. Now I made one mistake in here. Obviously we stringify the cache, which is turning the object into JSON, but we also have to assign the key, and we're saving it to the key Pokedex, and that is the first argument in the set item. So we first define the key that we're setting our JSON database to, and then we actually specify the data that we want to save to that key. And if we go ahead and save that, as I said before, that is all of our logic to fetch the information done. Now I'm going to go ahead and throw in one line here, console.log Pokemon data, because that's going to tell us exactly what the information we've fetched looks like. And now that I've added that line, if I save the file and we come back to our application, James's Pokedex, it loaded some stuff. We should be able to come over to the developer tools, to the console, and we get some errors. So first up, it looks like in our side nav, we haven't added a unique key. So let's come across to the side nav. Here we have this map. When you use a map, if you recall, the parent that is returned from that map needs to have the unique identifier key attribute, where the key is just equal to the unique value, which is going to be the index in the array. So if we save that and reload the page, we still get some secondary errors, where it looks like now we just haven't defined use state inside of our Pokecard. And that's absolutely true. We're calling the hook, but we haven't imported it. We've just imported useEffect. So we just have to add in use state just like that. And now when we save that and refresh the page, we get some more errors. And the reason we're getting this error is because I muddled up some of these commands. So this should all be Pokedex. All these keys should be Pokedex, not Pokemon. And one quick thing to note, if you do find yourself sending out thousands of networking requests, DDoSing the Pokedex API, all you want to do is come to your terminal, Control-C to exit out, and refresh the page, and it will stop that process, just in case that does end up happening. Now, one thing I'm going to do, because I realized it was causing an error, is actually remove loading. And the reason we don't want to include loading in the dependency array is because we don't want to re-trigger this useEffect when loading changes. We only want to trigger it when the selected Pokemon changes. And the last thing we're going to do is update this URL here so that we can actually fetch adequate information. And basically what's happening is that this shouldn't just be selected Pokemon. It actually needs to be one of our util functions, which is get poke. Let's look at what it's called. If we come into utils, scroll down the function, we need to get Pokedex number. So we have to get the Pokedex number and then access the selected Pokemon. Now we'll have to import that utility function from the utils folder. And now when we save that code, basically what's happened is we were fetching the 0th Pokemon, which doesn't exist. The first index is 001, so it's the first index. And so now that we're actually fetching the information, we can see that it's logging out, and we have all the abilities, the cries, the forms, the game indices, the moves, and all that good stuff. So we had a little bit of an error there, but we have fixed it. The only thing that should be in the dependency array is the selected Pokemon, not loading. So now that we have this data, what we can do is display it on the screen. And that is pretty straightforward. First, what we're going to do is open this div up onto some new lines. So we're going to split that open, and it's going to have the class name attribute equal to Pokecard. Inside here, we're going to have a div, and this is going to have an h4 element within it. And that's going to contain the curly braces because we're going to run some JavaScript. And in here, we're going to call the get full Pokedex number. With the selected Pokemon, we're going to make sure we import that utility function. And then we're just going to throw a hash in front of it because that refers to the number. So we'll put the hash in front. And now when I save that, that shows up on our screen. Now, one cool thing we'll note, if we refresh the page, all of that information goes away and our use effect does not run again. Well, actually, that's not true. Our fetch data specifically does not run. The use effect has run, except we now access that information from our cache. If we come over to the developer tools and the application tab, within our local storage for this website, we can see we have the Pokemon right here and all of its information. So that's good to be aware of. Now underneath this H4, we're going to have an H2. We're going to have the curly braces, and that's just going to have access to the name. And we need to actually get the name, where the name is going to, let's define this above the use effect. Typically my use effect, I like to put it above the actual JSX, and then everything else goes above that. So here what we're going to do is we're going to have a line that destructures out a whole lot of information from data. So we're going to access the name, the height, which is going to be the Pokemon height, and this is all data that's available just in here. We're just destructuring it out of that object. So we're going to access the height, the abilities, the stats, the types, the moves, and the sprites. And that's going to come out of data. And I'm going to provide a backup or of an empty object. So I'm going to say data or empty object. And so that just says if data is null, then destructure it out of this empty object because we can't destructure out of a null data type. Now the one other thing I want to do down here is I'm actually going to provide a secondary return. But I'm going to put that inside of an if clause that says if loading, return an empty div with an h3, well actually we'll make it h4, and it's just going to say loading ... And so now when I refresh this page, it happened too quickly, but when we didn't have any data, basically the loading state will have been saved, and this should actually be loading or not data. So if data does not exist, show a little loading screen, return this JSX, and then if neither of these cases are true, return the legitimate JSX. And that just ensures that we're not going to basically be rendering out a whole lot of undefined values because we don't actually have any Pokemon information. So you can conditionally render a whole lot of stuff depending on what you return from your component. Now that we have access to all of these values, we can continue on down here inside of the JSX. And what we're going to do is now have a div with a class name equal to type container. And in here, we're going to render out some JavaScript. We're going to map over some items for all the different Pokemon types. So we're going to use the curly braces, and we're going to say types.map. And in here, we're going to pass in the arrow function that takes two inputs. This is going to be the type, and then we're going to have the type index. And from within this arrow function, we're going to return out the type card component, which we've created over here. Now we're exporting that, so we should be able to import this component. But first I'm just going to make sure that it has the key attribute, which is equal to the type index. And we're also going to pass down the type, which is equal to the type. And that can be a self-closing component. And let's just get that auto imported. So we can now see that the type card is in fact imported from the /type card. Now one thing I've actually forgotten to do in all of these components right here is we want to make these exports default. So I'm just going to go ahead and come into all of them, and when we export them, after the export keyword, I'm going to change it to default, and I'm going to explain what that does in just a second. Now, this isn't a critical process. You could leave it as it was, but essentially what's happened is when we're importing all of these, we're now importing them as if they weren't the primary or the default export from that file. But if we add that default component, then we can just import them directly instead of having to destructure them out of the exports object. And I just think that's a cleaner syntax, and so since we've done that, we can also update the one inside of the poker card and just import the component directly. So that is now much better. So here we've got Bulbasaur showing up. It looks like we might have got an issue. Did I forget one? Does not provide an export name default, and that's because within the poke card I also have to add that default keyword. So that's now fixed our application, and we're now showing Pokemon number 1 Bulbasaur. So coming back down to our type card right here, we're passing in the type, and this is actually a lie. It's not that straightforward. It's ever so slightly more complex. If we come over to our data inside of the application, and if we open that up and have a look at types, which you probably can't really see, just here, you'll see that types is an object that contains a whole lot of stuff. So when we're mapping over everything within the types, the type is this object. And when we open the object up, we then have to access the type within the type and then consequently the name parameter. Now I recognize that possibly sounded like a whole lot of jargon, but the moral of the story is that type is actually an object. So what I could do is I could just say type object is the entry that we're accessing from within the types array. And then to actually get the type, we access the type object from within the type object, and then finally the name field. So essentially this is an object, this is another object, and this is just the name within the object. So that's unnecessarily complicated. So now that we have access to that, we can come into the type card, let it know that it's receiving some props, and we can destructure out the type, because that's the label we assign to that value or the prop name, from within the props. And finally, in the type card, what we can do is we can render it out within a paragraph tag. Within the curly braces, we can access the type, and then the div gets a class name of type tile. And if I save that, we now see we have these two little types, the type name showing up for that Pokemon. Now the other thing we're going to do is actually be a bit naughty and use the style attribute to style this component. Now to do this inside of React, it's basically a double object where the inside object is the styles object. So in here we can pass in a color, and the color is just the Pokemon type colors, which is available within our utils, so we need to make sure to import that. And then within there, we access the type, so that's going to be the question mark dot square parentheses to access the type, and then we're going to question mark, and then access the color within that. And the question mark just adds security to our subsequent chaining of key value pairs. And then we can comma separate and style the background parameter. And that's going to be virtually the same. We're just going to go Pokemon type colors, access the type within that. So that might be poison or grass in this case. And then access the background field. And now when I save that, we can see that the types actually have the appropriate colors, and all of this is just coming from this object right here. So if it was type ghost, that would be the color, and that would be the background color. So we're making some progress. Next thing we need to display is the image. Now for the images, the API provides a low resolution small image. And I decided that wasn't good enough for our project. So what I went ahead and did is created a higher resolution image for each of the Pokemon that we're going to use as the primary image, and we're going to use the sprites as the secondary images. Now these images are going to be local to our project, and they're available in the GitHub, so you have to go and download them from within the public folder. There'll be a folder called Pokemon, and that's where you'll find them. And while you're there, don't forget to start the repo. Thank you very much. Love that support. So I'm going to go ahead and copy this folder across, and right here I pasted it within the public directory, and we now have the Pokemon folder with a picture of every single Pokemon. And what we can do with that is come into our Pokecard, and underneath the types, we can now render out a big old image. So just underneath this div right here, we're going to hit enter, and we're now going to render out an image tag that has a class name of the default image. And we're going to give it a source directory equal to the curly braces so that we can write it in JavaScript. And it's going to be within the Pokemon folder. And we don't have to access the public directory because the public directory is the default folder that's searched for basically local assets. So it's the Pokemon folder within the public. The slash basically says the home level directory. And after that, we just have to add on the get full Pokedex number for the selected Pokemon. And then we just have to add on the .png suffix. So this is going to access the, 140, whatever relevant number it is, add on the PNG and access that file from within the Pokemon folder. And then we can give it a description tag equal to, and I'm going to use the backticks for some template literal string construction, where we're going to have the name of the Pokemon inside the $ curly braces. That way it's going to use JavaScript to inject that name into the string. And then I'm just going to say large image, and finally I can self-close that image tag. And now we get this big pretty picture of Bulbasaur showing up on the screen. And once again, just to go over that, the public directory is the default folder that's searched for all of our assets, our images in this case. We need to access the Pokemon directory, so we go /Pokemon, and then the file that we need to show the image is the full Pokedex number, so 001 in the case of Bulbasaur, plus .png, that creates the string to access the image, and then the alt is just the template literal string to basically provide some text description to what image is being displayed. So that looks pretty cool, and that is the first of 5 images completed. Now after that, we've got some more images to show. Specifically, if we come over to our local storage state and look inside of the Pokedex and open this up, we're going to display these sprites just down here. So there's a whole bunch of them, and you can see they're labeled by the different kinds of shots that we'll be looking at. So back default, front shiny, and some of them have links, and those are links to the low resolution images. Also, I went for a walk today along the beach, and I'm just oversharing here, and I saw a pod of orcas. So here is the footage of the orcas that I saw. In this one you can see a parent orca with a little baby orca just by the side, and these 2 orcas really wanted to eat something that was trying to hide from them in the rocks, which I thought was super interesting. It was like dogs trying to get a ball out of a corner, but it was just very special. Anyway, enough of me rambling on about random things that happen in my life. Back to the images. Also, it's a good chance to, if we open up the screen a little bit, we can really start to see our app coming along. And we've got our Pokedex, the nav bar, the side nav bar looks great, and we're working through the actual app just here. Anyway, back to all these sprite images. So if we come down to where we're going to render them out, they are all going to be rendered out within a div. And the div is going to be called the image container. So we're going to go ahead and create this div, give it the class of image container class name. And in here, we're going to map, because there's a bunch of them and we just want to render the same image for every element in the array. So we're going to go, I think it's sprites. Well, actually, no. If you notice inside of our sprites list, there's a bunch of empty images. So we're actually going to need to filter some of them out first. So what I'm going to do above this is underneath where we destructure out all the information, I'm going to come down onto a new line, and I'm going to create the image list, and that's going to be equal to, and I'm going to get all the keys, create an array from all the keys, object.keys, from the sprites. And if we don't have any sprites at the moment, then I'm just going to do a backup object, because we can't use this object.keys method on an undefined data type. And then I'm going to filter them out. And in here we get a function, and the function is going to take a value as an argument. And we're going to say if not sprites value. So basically if we go to the sprites object, which has all the images, and we access a particular key and it returns undefined, then we want to return false and filter that out. We have a secondary case that we want to filter out as well, is all the different random Pokemon versions. We just want the main ones. So if we create an array with keywords that we want to eliminate, so versions, I think is one of them, and the other one is other. And if that array includes our value, so if basically the key name has the word versions in it, then what we want to do is also return false. And if neither of those two cases are true, then we want to return true. And basically what this logic right here is going to do is it's using the filter method to filter out when sprites at the particular value returns undefined, or if the value, which is the key name, has either of these keywords in it. If neither of those two cases is true, then we keep the image, and if one of them is true, we filter it out. So this is going to give us an array of the different keys that we can now map over. So if we come down to where we have our squiggly parentheses, we can go image list dot map, and in here this takes the callback function or the arrow function, and we have some arguments to provide to the function. So this is going to be the sprite URL, and we're also going to access the sprite index because we need the unique key. And all we do in here is we return an image that has the key attribute equal to the unique sprite index, a source parameter, which we'll enter in a second, and an alt tag. And the alt tag is going to be actually also some JavaScript. So we're going to throw that inside of the curly braces. And inside here, we're going to have a template literal string. And we're going to have the name dash image dash sprite URL. So that's going to be the unique identifier for this particular image. So we've got the name injected in using the template literal syntax, same with the sprite URL. So that would just construct a unique description. And just before we return, we can throw in some logic in here, and we're going to say const image URL is equal to the sprites object at the sprite URL. So that should actually be sprite key, because it's a key from the sprites dictionary or object. But the point is we get the image URL, and that's what we assign to the source. And if we now save this code, we get these 4 little images just down here, and they're nice and responsive as well. So as we come onto a smaller screen, we can see they drop down, and on a bigger screen, they show 4 in a row. So that's kind of fun. Now underneath that, we have the stats. So we've got the images underneath this div right here. We're going to have an h3 tag that says stats, and this is going to have a whole lot of Pokemon stats. Now these are going to be contained within a div that has a class name of stats card. And in here we're going to use the map method again, where we're going to map over all of the stats, which is an array. We're going to say stats.map. This takes the function, the arrow function that has 2 entries. This is a stat object, and this is a stat index. And the stat object is the entry in the array that has all of the information about the stats, so the value, the name, and all that good stuff. And what we can do is we can destructure out the actual stat and the base stat from the stat object. And then after that, we can just return a div. The div obviously needs the key. The key is the unique stat index. That's why we always get the index. And this has a class name of stat item. And inside of this div, we're going to have a paragraph tag and then some curly parentheses, because we're going to access the stat, have the optional chaining syntax, and then we're going to access the name, and we're going to use a string method where we replace all of the dashes with an empty space. And then underneath the paragraph, we're going to have an h4, so some bigger text then the curly braces because it's a JavaScript value, and that's just going to have the actual value of that stat. Now if we save that block of code, we see we have all these little values coming up right here. So Bulbasaur has 45 HP, an attack of 49, special attack of 65, and once again we see that that is nice and responsive for the different screen sizes, so that's pretty cool. And then finally, underneath the stats, we're going to have another H3, and this is going to be all the moves. Now the moves is going to be interesting because it's going to have a special functionality which we'll learn of shortly, but we're just going to add a div that's going to have a class name of the Pokemon Move Grid. Now obviously if you want to go look at these styles, there's not actually that many of them. They're all in the index.css. You can fiddle around with them, but for now we're just going to carry on with the JavaScript, and once again we're going to map over all the different moves. So we're going to say moves.map. That takes the function, it takes the two arguments, which is the move object and the move index. And in here we simply return, and in this case we're going to return a button that has a class name of button card and Pokemon move. So those are space separated because they're actually two different classes. And we also need to give it the unique key, which is the index from the array. And we're going to finally give it an onClick, if I can spell that correctly. And that's just going to take an empty arrow function for the second. And then inside of that, we're going to have a paragraph tag. And that's going to have the squiggly parentheses for some JavaScript. And that's going to be the move object. And from within there, we're going to access the move key. And then we're going to access the name field and do that same replace all. All the dashes get replaced with an empty string. Well, it's actually a space. There's a space key in there. So notice that this one is also the space. It's not just a completely empty string, but it's the space key. So if we go ahead and save that, now when we scroll down, we see we've got this responsive list, which is super nice. That's a really cool flex display of all the different moves that the Pokemon can have. Solid. We're actually making some serious progress on this display. If we close out of the side, we now have a super nice nav bar where we can select all of the Pokemon, and we actually have the Pokemon display come up. And we haven't added it yet, but shortly when we select the different Pokemon, we'll obviously change this information. But that's pretty much this display done. Now before we finalize the functionality of the side nav, I just want to get these move displays showing up. Now this is going to bring into play two new concepts. Well, actually three new concepts in what we're about to do. First up, we're going to learn all about the modal. Now the modal is currently an empty blank component, and it actually isn't returning anything for the minute. Now, typically when we use modals, we want them to completely overlay everything in our document. And there's a couple of ways you can do this. All of them are correct, but the way that I like doing it the most is very first principles, I guess is the word to describe it. And essentially what we're going to do is, we learned at the start of this video that when we create a React application, it's injected into this div with the ID of root. Well, a good way to create a top level overlay is to have a new div underneath with an ID of portal. Just like that, we can create this div inside of the index.html, give it the unique ID of portal, and when we have a modal that we just need to overlay everything, inject it into the portal, and that takes it out of context of our React application, and it makes it really easy for it to overlay everything. So now that we have that div with the ID of portal, we can finish off our modal, where the first thing we need to do is come outside of our actual functional component and import React.DOM, careful with the spelling, from React-DOM, from the package React-DOM, which you will note if we come into our package.json is a default dependency of our React application. So now that we have that, what we can do is inside of our modal, we can make sure it's rendered out in this new div with the ID of portal instead of our root div. And the way that we do that is we return React DOM, which we imported, and we use the create portal method. And then in here, this takes 2 arguments. The first is a div. And this is going to have a class name of modal container because it's going to be the container for our modal. And then we comma separate a second argument. So the first argument or input is actually some JSX. The second argument is document.getElementById, and we have to pass it the div with the ID of portal, and this is how we select it. So we select our document and we say find that div with the ID of portal and inject all of this code in there instead of our original div. And now that we've done that, what we can do is open up this div right here, and the first thing we're going to do is add a button. And this is going to have an on-click event called handle close modal. Now we don't have that yet, but we'll see where that comes from in a second. And this also has a class of modal underlay, and I'll show you why we have this momentarily. And that's actually a self-closing button, so it doesn't have any contents. And then we have a secondary div with a class name of modal content, and in here we're going to have what's known as the children. Now, 100 million things have just happened, so let's take a second to break it all down. First up, we've now found out there's a new way to render out contents of our page that doesn't get injected into that original div with the ID of root. And that's what we like to do when we use modals, is we create this portal overlay that has just specifically the modal content. So that's super helpful. The second thing we've done is we've rendered it out inside of the div with the ID of portal by actually selecting that div and passing it into this method as an argument. Now we also pass in the JSX to be rendered from within that div with the ID of portal, and we have one div that's the container for this modal. And essentially that's just styled to overlay our entire page and fit to all 4 corners of our screen. And within there we have a button that's a modal underlay. Now if you think of a modal, typically when they pop up you might see a darkened area around the main content of the modal. And often when you click on that surrounding darker area, it will close the modal. And that's exactly what the underlay is for. The underlay sits behind the contents of the modal, and when you click it, it's going to execute this function right here called handle close modal, and that's going to exit out of the modal. And then lastly, we have this div, which actually has the content of the modal, and that is going to be children. And children is JavaScript, so we render it out within the curly parentheses. Now, what on earth is children? Well, for a long time, I've been talking about the 2 types of props that you can use to communicate information between components. And the first one is the attribute style prop, and that's actually the only one we've come across so far. The children is slightly different, but we access it the same way. So we tell the modal it needs to receive the props, and we can destructure out the children from the props, where the children is actually any contents contained within the opening and closing component tags. Now so far we only have self-closing components, but what if these had an opening and closing equivalent and within them they had a whole lot of contents? Well, that is referred to as the children, and we have to specify from within that component where and how it gets rendered on the screen. And we do that just like this. So I've destructured out the children contents, which is what will be in between the opening and closing modal tags. And then I've said specifically render that content within this div modal content. Now to demonstrate how that actually works, well actually first let's just also destructure out the handle close modal. To demonstrate how that works, we're going to come back into the Poke card, and inside this div right up here, we're going to render out our modal. Now, the way that we do that is simply by rendering it out like a normal component. We have to make sure that we import it up the top, but we're going to give it an opening and closing tag. And within here, anything we type becomes the children contents. Now this needs the attribute prop handle close modal. So in here we can have a function handle close modal, and that is equal to just an empty function for the minute. We'll come and specify how that works shortly, but that's the attribute style prop. Now for the contents. And all we're going to have in here is a div, and this is going to contain an h6 element that says name, and then underneath that we're going to have an h2, and that's going to contain the name of the skill, which we don't have access to yet. And then underneath that we're going to have a div, and this is going to have an h6 of description. And then underneath this h6, we can actually render out a paragraph tag that's going to have the description. Now, if I go ahead and save that, this obviously isn't finished, but if we come back to our application, we can see that we now have this modal overlay. And that's super cool. We can see we have the grayed out background. That's the underlay. That's technically a button, and that's why you can see the cursor pointer on it. And then we have the contents contained within this section right here. And we can see that the modal is fixed in the contents of the screen. Now, when I click the background, it's not closing, and that's because we haven't wired that up just yet, but we'll finish that shortly. But what will happen when it's done is when we click that background, it will exit out of the modal for us. Now, the modal is used for displaying the description of the skill. So how the app is going to work, we rendered out all of these buttons down here. If you remember, every single move was rendered out as a button. Currently, it's got an empty on-click event. When a user goes to click one of these buttons, we're going to open the modal and load a description of that skill that's going to explain to them exactly what that move does. So if they want to read about razor leaf, they know that's what razor leaf does. That comes up in the nice little modal, and it looks super clean. But the way that this is going to work is we're going to maintain a state called skill. And when they click the skill, we're going to set the state to skill, and that's when all of the magic is going to happen. So up the top here, we're going to define a new state that's going to be const skill and set skill. And that's going to be equal to use state, and for now it's going to be null. It's an empty state. Now, fetching the information from the skill is actually going to rely on the information received first about the Pokemon, and we have to make a secondary fetch request to a different URL in the API. And we're going to go about doing this differently from how we fetch the Pokemon data in the first place. For the Pokemon data, we used a use effect, which listens to when the selected Pokemon changes, and whenever the selected Pokemon changes, it goes out and fetches the new data. But for the skill, we're actually going to fetch that information when the user clicks on the button to display the skill. So for this process, we do not need a use effect. We'll still have the asynchronous function though. The other thing we're going to do is learn about conditional rendering. Now, conditional rendering, as the name implies, says I only want to render something on the screen dependent on a condition. And the way we do that is we wrap that body of code inside curly braces because it becomes some form of JavaScript. I then like to wrap it inside of the circular braces. And what we can do is throw a condition in front of this where, in this case, I want skill and modal. Now, this syntax right here, basically what it does is it says, if skill is true, render this out. If skill is false, do not render this out. And that makes sense because we only want to display the modal when we have the data about a skill. So what's going to happen here, if I now enter this on a new line, we've thrown in some conditional rendering where we see the modal goes away because currently skill is null. So it's essentially a falsy value, which means that we do not display the code on the other side of the AND condition, on the other side of the double ampersand. Now that also makes closing the modal or creating this handle close modal function very easy because all we have to do in the logic or the body section of this function is we just say set skill equal to null. So now when the user clicks that overlay, it's going to empty out whatever skill currently is, and then the modal will go away because this value becomes false. As for how we actually go about fetching the information, what we're going to do just underneath, or actually above the use effect, is we're going to create a function. Now this is going to be an asynchronous function, and I'm going to do it just above the use effect because the use effect is the final thing above the JSX, and this is going to be called fetch move data. And in here, it's going to receive an argument. Well, it's actually going to receive two arguments. It's going to receive the move and the move URL. Now, if we come back to our developer tools and over to the application, what we'll see if we look behind my head right here, if we come into the Pokedex and open up all of this data that we have when we go and fetch the Pokemon data, we see we get moves, which is an array of a whole lot of moves. We can see all the moves right here. And the Pokedex API has very kindly shown us that we can access more information about the move from this URL. So I can actually go ahead and copy this URL and paste it into my browser, and my browser will demonstrate the data that we get back. And so here we get a whole lot of stuff. A lot of this is jargon. We'll learn how we can filter it shortly. But if you look for these little flavor text elements, it gives you a description of that move. A fighting dance that sharply raises attack. And each of these flavor texts is dependent on a version. So in this case, the version group is for Pokemon Crystal. So all we have to do is filter for the flavor text relevant to Pokemon Leaf Green or Fire Red in this case. So it looks complicated, but it's actually not as bad as you might think. The point is that we get the URL that we can then go and fetch from to get the data, and that's an argument for this function. Now in here, once again, I'm going to have the states. I'm going to say, first actually, define a loading state for these skills. So we're going to define loading skill and set loading skill, and that's going to be equal to use state false. And that's a state we need so that when we're loading a skill, we can prevent a user from doubling up on the skills that they're loading. And so now what we can do is have that first clause that says if we're currently loading a skill, return out of here. The other thing I want to do is also say or not local storage, or we do not have a move URL. So these are all just defensive clauses or guard clauses to make sure that our fetching data doesn't break. We need the move URL to actually know where to fetch the data from. We need local storage because we're going to employ caching here as well. And we obviously don't want to fetch data if we're currently loading data. Underneath that, I'm going to say check cache for move. And in this case, I'm going to be lazy and define cache and assign it equal to a variable C. And then we're going to check if local storage.getItem. And in this case, it's going to be different key. It's going to be Pokemon moves. It's going to be a different object. And then if that exists, we can say C is in fact not equal to an empty object, but it's equal to our cache. So we see if it exists in local storage. If it does, we json.parse whatever we get out from local storage. So we say local storage.getItem Pokemon moves. And now we can say if move is in the C or the cache, then we just say set skill equal to cache for that move. So we access the move from within the cache where cache is actually just C. And if that's the case, I'm going to throw in a line that says found move in cache. And I'm going to return out of the function because we don't want to do anything further. Now, one other thing I'm going to do in here is for when we fetch the Pokemon data, I'm going to throw in a line that says console.log found Pokemon in cache. And this is just going to make it extremely apparent where the information is coming from. Likewise, if we come into the fetch Pokemon data, instead of console.logging the actual data, I'm just going to say fetched Pokemon data. And that's just going to allow us to easily debug what's going on in our application and also just ensure that our cache is behaving appropriately. Anyway, back up to our fetch Pokemon data. If we get past the cache, which means that we haven't found it in the cache, we now need to go out and fetch that information. And we're going to do that inside of a try catch the error console.log the error and a finally block. And this is how I always like to fetch data. And once again, if this is unfamiliar, I highly recommend checking out my JavaScript course because we cover all of this JavaScript syntax in there. Anyway, in here, the final thing we always do is set loading skill equal to false. And at the start, we set loading skill equal to true. And that just manages a loading state while we're fetching the data. After that, we say const response is equal to, and we fetch from the move URL, which was passed in as an argument. And after that, we can say move data, const move data is equal to, and we can access the JSON from within that response. And we could go ahead and console.log that move data just to see. And I'm also going to, in that same console.log, throw in a string that says fetched move from API. And then after that, comma separate the actual data. Now, if we've fetched from the data, what we're going to do is access the description. So we're going to say the description, which is specifically the flavor text, and this is where we're going to do our data filtering. And this is just going to be admin. You'll want to copy it. It might not make a whole lot of sense, but I'm basically filtering out all of those different texts specifically for when the version matches fire red and leaf green. So what we do is we access the move data, then we use the optional chaining, and we say flavor underscore text underscore entries dot filter, and we filter the vals, and we return specifically when the val.version underscore group dot name is equal to fire red dash leaf green. So that's going to filter out every flavor text entry that does not have a name parameter equal to fire red leaf green. And then after that, we access the value of the 0th index because we should only have one value left. And from within there, we access the flavor text. Just like that. And that's going to get the flavor text specifically for the move, which is the description. You can go and dive into that object if you want to really understand how that process works. And then we can create an object called skill data, which has a name, which is equal to the move, and a description, which is just the description. And that's what we can set as the skill, as the skill data. And that's all we need to render out our modal. And the other thing we can do is cache that information. Now, we don't want to cache everything. We just want to make an entry in our cache for that specific move, and we just want to assign the skill data to that. And finally, we just need to local storage.set item for the Pokemon dash moves key, and we just want to json.stringify the cache. That's all we have to do, and that's going to cache it so that next time we fetch that same data, we'll hit this block of code and it will save us from duplicating or basically doubling up on our fetch requests, massively reducing the amount of bandwidth we, unleash on the API. And that's our whole function for fetching the move data. Just to go over that once more, we start off with a guard clause that says if we're loading the skill currently, don't do anything, exit out of the function. That's for when a user double clicks or triple clicks if they're impatient. Otherwise, we check if the cache is available. If it's not, we exit out of the function. And finally, we see if we've got a move URL, which is critical to have that URL to know where to fetch the data from. If that's not available, we return out. After that, we've guaranteed we have access to our local storage, so we can create our cache. We start off with an empty cache, and if we have an existing one from within our local storage, we update our cache. We first access that cache, which is stringified, so it's JSON, we pass it, and then that passed object is assigned to our cache and overwrites the original blank one. Then we see if the move is currently in the cache. If it is, we just fetch that and set it to our skill state. If it's not, we carry on and we fetch it from the API. We pass the information so that it's only the stuff that we need. We set it equal to our skill state, which is then going to re-render the screen with all the information. In addition to opening the modal, this will automatically open the modal because the modal is open whenever there is data assigned to the skill state. And the last thing we do is we add it to our cache and we save our cache for next time. So that's just a really good data fetching process. We've seen two different ways that we can fetch data, and that was actually the main reason I included this project, because data fetching is a critical skill when you're building front-end, full-stack, back-end applications, and this is how you do it in React. So now that we have this fetch move data, all we have to do is come down to all of our moves where we've rendered them on the screen. They're all these buttons right here, and they have an on-click event. And in here, all we have to do is call the fetch move data, and we have to access those two values. So we go within the move object, and then we access the move key and subsequently the name, and that's going to be the name of the move. And then we do the exact same thing to access the URL. And so now we've passed in those two entries, the name of the move and the URL. And with that done, I should be able to come back to my application, close all this stuff, scroll down, and actually I'm going to keep it open because we should be able to look at the console. So we keep finding the Pokemon in cache, which is appropriate because we're looking for Bulbasaur every single time. But now when I select Pokemon Razorwind, we get an error. Res.json is not a function. Let's have a look. And that's because I forgot to await both of these lines right here. Super important, they're asynchronous lines within JavaScript. If we don't await them, they return a promise. So let's blank that out. Found the Pokemon in the cache, access Razorwind, reading undefined. So it looks like we actually got the move data back, which is perfect. And then we're having an issue within the flavored text entries right here. We can see all of the descriptions right here. So flavor, and that's because I keep using New Zealand spelling. Flavor is spelled without the U. So now if I save that once more, we've already fetched the information, but because our application broke, it didn't save it in the cache in time. So now we fetch the data from the API. We've got it right here, and consequently we set it equal to our skill and updated our screen. So now that we have that skill information, we can come down to the modal where all of this children contents gets rendered out as this children field right here. That's how we pass the contents. If you forget this line, you won't get any of that children contents rendering on your screen. And now when we have the name, we can just access the skill.name, and for the description, we can just access the skill.description. And I think for the name, we also have to use that replace all string method where we replace any dashes with a space character. And now we can see we have Razorwind showing up, and we have a description, first turn, prepare, and second turn attack, which isn't a brilliant description, but it's from a very early generation of Pokemon. The other thing I just want to do quickly is make sure that the name, the H2 right here, has a particular class, which is skill-name. So if we go ahead and save that, now when I open up headbutt, an attack that may make a foe flinch. So that's super cool. And now for both of these, we can see we fetch the move from the API. But if I open up Razorwind, we can see second time round it's found from the cache. And that is our caching done. It's super effective. And you can come over to the application tab in your developer console. And inside of local storage, you'll see that we have a second key now, Pokemon moves, that just here has our two moves, headbutt and Razorwind. And you can do this with as many as you want. Mega Drain steals half of the damage inflicted. Growth raises the special attack rating. Poison powder, a move that may poison the foe. String shot, terrible move. I always thought this was such a useless move. A move that lowers a foe's speed. And it's super cool. False swipe leaves the foe with at least 1 HP. That sounds massively overpowered. And you can see these are all being added to our cache so that when I refresh the page, try render them out again, our application is insanely quick because everything is just looked up in the cache. We don't have to fetch anything over the internet. So with that all done, we've now rendered out everything we need for our Pokemon. It's all looking very mobile responsive, which is super nice. The modal works well on the mobile screen as well. And the last thing we need to do is obviously figure out how we can have the side nav for the mobile device and also get these click functionalities work so that we can look up information on different Pokemon. So of those two, let's first start off doing the select Pokemon functionality so that we can actually click and change them, because it's actually not that complicated. So obviously the selected Pokemon state is managed from within the app. That's super straightforward, and it's defaulted to 0, which is the first entry in our Pokemon array, which is Bulbasaur. So what we're going to do is first figure out where all of these states are managed within the side nav. So let's come into the side nav. Now, one thing you'll note in this process is that we provide the attribute props to the side nav, and we haven't yet destructured them or basically informed the side nav that it needs to receive these props. So if we come into the side nav, we can receive the props and then we can destructure out the two props. One is selected Pokemon and the other is set selected Pokemon. And we're going to destructure them out from the props object. Now that we have access to both of them, the first thing we're going to do is add some selective styling. So basically, if we're currently on a Pokemon, we want the display to show up differently. We want it to be highlighted to let us know that's the Pokemon we're currently on. So what we're going to do is where we have these buttons right here, we currently have a dynamic class set up. So that was obviously intentional because we're about to revisit it and make it dynamic. So the default or the first style that all of them get is the nav card, and that gives them the look where we hover, it's going to suggest that we select them. What we're going to do is add on a statement, add on a class only if that button is the currently selected Pokemon. So what we can say is we can say plus, add the circular parentheses, because within these circular parentheses we're going to decide which string we're going to concatenate to the original class. And we're going to say if the Pokemon index, which is the index in the array of the currently mapped out Pokemon, happens to be equal to, so we're going to use the triple equality. If that's equal to the selected Pokemon, if so, we want to add on this string. Otherwise, we're going to add on this string. And if it's not, and we get the secondary case, we don't need to add on anything, so we're just going to leave it blank. But if it is, we're going to add on the nav card selected state, or class, basically. So then for the button that's currently selected, or the Pokemon that's currently selected, it's going to get the second class appended to the first one. And so we can actually see that's been applied. Now by default, our Bulbasaur is selected, and it shows that highlighted state that basically we could then change if we then go on and select a different Pokemon. Now, as for how we're going to change the Pokemon, that's actually super simple. All we need is the set selected Pokemon function or setter function for that state. And we assign this as an on-click event to the button, where when we click on it, we execute a body of logic, so we pass in an arrow function, and within here, we call the setter function and we pass in the new Pokemon index. So now, whenever we click on a button, it's going to update the selected Pokemon state, and then the use effect is going to be triggered, which is going to render the new information. So if we go ahead and save that, that should be all the functionality we need for our little search bar. So currently we're defaulting to the Bulbasaur. If I refresh the page, we default to the Bulbasaur, and let's actually show the console. So we found that Pokemon in the cache. If I then click on Ivysaur, we get an error, set selected Pokemon is not a function. So that means that I've done something wrong here. What's the state called? Set selected Pokemon. Right, so that's my bad. Where I was passing down the prop set selected Pokemon, I was actually passing down the state name instead of the setter function. So we just had to update that. Set selected Pokemon is equal to set selected Pokemon. Let's refresh the page, and now I click on Ivysaur. You saw the loading state, and it loaded in all of that Pokemon information, and we now get all these wicked pictures, and all of its skills, all of its stats, the Pokedex number, and everything. Furthermore, we can see that we fetch the Pokemon data, and now if I reload the page, we find it in the cache. We're back to Bulbasaur, but I would expect the next time I click on Ivysaur for it to be found in the cache. And you could see that was actually faster. We didn't even get a loading state, and then we had access to that information. And now we can select Leech Seed, and we get the description of that move, and it's all cached. So that is brilliant. That's all done. We could come down to, let's look for an interesting Pokemon. May as well go for the legendaries. Let's go for Articuno. Blue is my favorite color if you didn't know that. So this is ice and flying type. We can see the types work well. We've got all the stats, huge stats, and we've got all of the attacks. My favorite, I was a big fan of Ice Beam. I presume Ice Beam is in this list somewhere. What we could actually do, and this might be a challenge for you, is you could see if you could alphabetically order these skills right here. Because that would probably make it easier to look through them all. Maybe Ice Beam isn't learned by default. Oh, there it is, Ice Beam. Excellent. An attack that may freeze the foe, and it was absolutely powerful. So that is amazing. Now after that, all we have to do is get the search functionality working, because that's not currently doing anything. And the way that we're going to do that is from within the side nav, because that's where our input is. Now if you recall from the To app, an input is interactive, so we need a state to manage the value in that input. So what we're going to do is say const, and I could say search value and set search value, and obviously that's within the square brackets, and that's equal to use state, and I'm going to default it to an empty string. Now we're going to have to import use state, so above our React functional component, I'm going to go ahead and import use state from the React package. Just like that, and now we have initialized our search value state, and we can wire up the input to basically be tied to this stateful variable by first giving it the value attribute and setting that equal to the search value, and then also passing in an onChange event handler. Now this is just an arrow function to be executed whenever the value of that input changes, and the default argument for this function, this callback function, is to receive the event. Now from within this function, then what we can do is we can update the state to match the new event.target.value. That's how you get the current value from within the to-do. And so now whenever a user enters a value into the input, we're going to set the new value to our state, and the input is going to basically match that. Now that wires up our input, so that works well. What we now need to do is filter out the first 101 Pokemon. And the way that I'm going to do that is actually change, or basically initialize a new variable. And this is going to say const filtered Pokemon. And how that's going to work is I'm going to say it's equal to the first 151 Pokemon, and then call the array filter method, where that also takes a function, an arrow function, and it receives the value, or the current element value, the generic keywords for the element in the array. And what we're going to do in here is have two search filters. So first, we're going to let them search up via the Pokedex number. So what I'm going to say is if, And actually for this, we should probably receive the index as well. So let's go ahead and do that. I'm going to receive the element and the element index, and that needs to be now wrapped in a set of circular parentheses because there's 2 arguments. And what we're going to do inside of this filter is have some conditions. So first what we're going to do is we're going to say if the full Pokedex number includes the current search value, then return true and keep the value in the array. We're also going to say if the Pokemon name includes the current search value, return true and keep it in the array. And then we're going to have an otherwise exclude from the array. So we can now go ahead and code these out. So the first condition is going to say if, and in here we're going to call the get full Pokedex number, which we've already imported. And we're going to pass in the element index. And now this is going to potentially return a number or a string. It should return, anywhere on the spectrum of 000 through 051. And what we're going to do is wrap that inside of circular parentheses and just force it to a string type by using the toString function, which is native to JavaScript. And then we can use the includes method to see if that string includes the current search value. And if that returns true, or if that evaluates to true, then we want to return true from that if block. So that's the first condition. Then underneath that, we're going to say if, and we're going to say the element in the array, which is the name of the Pokemon, dot includes the search value, then we also want to return true. So the alley is the current entry in the index. So at the first entry, it's Bulbasaur. And then if neither of those return true, then we want to return false and filter the value out of the array because it's not adding up to our searches. So essentially what we've done here is we've taken our original full list and we've just filtered out any values that don't match the criteria of the search input. And then what we can do is we can use this value right here and we can swap out first 151 Pokemon for only the filtered Pokemon. So that's going to show everything when we don't have any value in the search input. So let's try Bulbasaur. And when we go ahead and now try that, we'll see right here that we're actually getting an issue. So we're typing in BU, and that's not bringing up Bulbasaur, but it is bringing up Buzz, Boo, and Kabutops. So, and also worth noting is that the Pokedex numbers are incorrect. So we're going to have to do something about that. And the reason that's happening is because Ellie actually needs to be lowercase. So we can use the toLowercase string method. And we also have to lowercase the search value. So we could say .toLowercase here. That way everything is lowercased. So if I now redo that, we can see that Bulbasaur is now included in this list. Same with Butterfree. However, the Pokedex numbers are in fact wrong. So the one change we're going to have to make here is where we use the Pokemon index for this Pokedex number right here. What we're actually going to have to do is access the first 151 Pokemon and find the index of the Pokemon. And that means that when we're filtering out and we're changing our list and all the indexes are going all over the place, it will always retain the original Pokedex number because we're looking from the original list, not the filtered list. So that's the first thing that we can fix. And the other thing we want to do quickly, because I'm a numpty, is that toString is from Python. I'm confusing the languages, and actually it's not even necessary because the function always returns a string type. So all we need is get full Pokedex number for the element index and then ensure that it includes the current search value. And with these two clauses, we can now search through the Pokemon to create a filtered Pokemon list, specifically looking for either a Pokedex number or the name of the Pokemon. And so that obviously fixed the typing one, and the number one also works well. So I can search up now by the Pokedex number, or I can search up by the name. So I could search up Articuno, and Articuno comes up, and we should see this loaded from the cache. Now, I also notice one other issue that we're having right here, and that is when I filter out these values and I click on Wartortle, we get Bulbasaur loading. And that is happening because we're doing it by the Pokedex number or the Pokemon index in that array, but if we're using a filtered array, that's not actually going to work. So what we instead have to do is copy this logic right here, where we search for that Pokemon and the index in the original array, because that's its true Pokedex number. And what I'm going to do is actually above this return, define a variable called true Pokedex number and have that equal to the first 151 Pokemon and getting the index. And now what we can do is actually replace this code right here. And I'm using a variable because I'm going to have to use this twice, and I can also place the true Pokedex number in there. And so now when I click on Articuno, Articuno loads and we get all of the images showing up. And if I were to select Wartortle, we load it for the first time, we fetch the Pokemon data from the API, and now we have all its skills and stats, and that is totally working. Now just for the input, I want to give it a placeholder. And I want to add in 001. I'll actually do e.g 001 or bulba ... And that's just going to inform the user that they can either search by the Pokedex number or by Bulbasaur. So that's all done for our search bar. We've got loads of different Pokemon. Application is looking wicked. The last thing we need to do is finish off the mobile responsivity. Now the thing that we're missing is how do we navigate between all the different Pokemon when we're in this mobile responsive state? And that all comes down to the header. Now the header has some conditional displays, and it basically only shows up when we're in the mobile device size. So it's a special header. And the code for this is pretty straightforward. Inside of the header, what we're going to do is start off with a button, and the button is going to have a class name equal to openNav button. And we'll see how this works in a second. Inside here, we're going to have an icon. So if we come over to Font Awesome Icons, the icon we're going to need is the menu icon. And so we're basically going to have a side menu that the user can choose to open up and toggle, and that's where they're going to see all of the Pokemon. So what's going to happen is we're going to copy this icon with the class, not the React one, just the HTML one, update class for class name, and that is now going to show the bars. Or at least it would if we'd actually imported the CDN package. So if you recall from the first tutorial, when we went to use the icon, we had to import the CDN package, and so we're going to have to do that again. That is once again linked in the description down below, and we just copy this tag that's going to enable this icon set in our project and paste it into the index of our document, index.html, within the head tags underneath the title right here. And so now that we've saved that, if we come back to our project, that should enable it to actually read in the icon, and we can see that shows up right there. Now it's not doing anything for the minute, but we will get it working very shortly. So after we've added that in, let's keep going with our header. The other thing we're going to have underneath this button is an h1 tag that has a class name of the text gradient style that just says Pokedex, using the accented E in the second one. So now that's just going to match the style of our home screen, except when we come down onto the smaller screen, we can see that we lose the side nav, or at least it's not originally available, and now we just display a little menu icon that fades out when people hover over it, and the nav. Now the last thing we have to enable is a display state for that side nav. And we're going to do that with a state from within the app, because this is where everything's rendered. Basically, we need a display state that is available from within the side nav that's triggered from the button within the header. So because we need it in both these two components, we define the state in the parent of the two of them. And so this is just going to be a stateful variable inside the square braces called show side menu. And then obviously we have the setter function, set show side menu, and that is equal to, what am I doing? That is equal to use state, and it has a false value to start. Now, when I'm doing these toggleable menus, I like to define a handler function for them called handle toggle menu. And all this function does is it sets show side menu to whatever it is not, because it's toggling between a false and a true state. So if we just throw the exclamation in front of it, that's going to say not its current state, which will just invert it from either true to false or false to true, hence having the toggle ability. So we're just going to set it to whatever it's currently not by inversing it with the exclamation. And then we can very simply pass that down into the header component, where we're going to toggle the open state using that menu button. But we're also going to have to pass it into the side nav, and we'll see why in just a second. So first we're passing down the prop to the header. So we have to come into the header after saving the file and let it know that it has props to receive. And then we can go ahead and destructure out that toggle function from the props that's going to invert the state. And then we can very simply assign that function to the onClick event. Now you might wonder at this point why in some cases I use an arrow function and then call the function from within the arrow function, and in some cases I just directly assign the function. Essentially, if you're actually going to call or invoke the function, that has to be done from within an arrow function. So if I was going to invoke this function, that would be valid syntax, and I would have to do it from within an arrow function. That's the onClick function or callback to be executed. Now the invocation is caused by the circular braces, but if I remove them, then I can just pass the function directly in as the onClick event, because it's not actually being invoked. It's just passed as a reference. It's basically saying refer to this function when you go to invoke it. So that is valid syntax. And so now when I'm on the small screen and I click that, it's not currently working, and we'll see why in just a second. There's some stuff in the side nav that we have to wire up. But it will be changing or toggling that state, which is what we need it to do. Now we also need to destructure out this toggle state from within the handle toggle menu. And the other thing we'll actually need from within the handle toggle menu is the show modal state. So we're just going to say show side modal. Is that what it's called? Is that what we called it? Showed side menu. So we're going to have to pass down the show side menu state into the side nav. Now if you end up with a lot of props, what you can do is just enter them onto their own independent lines, and that can sometimes just add a bit of clarity to all of your code. It's by no means necessary, but in this case we can see that the nav has these 4 props. So we need the show side menu and the handle toggle menu inside of this component. Now for the handle toggle menu, if the menu is currently open and the side nav is showing on the mobile device size, then the toggle function is going to have the effect of closing it. And what we're going to do is, where we have this div right here, we're actually going to add a button inside it. And this button is going to have a class name of open nav button, and we'll see how that works in a second. And in here we're going to have an icon, and the icon that we're going to use is the right, actually I think it's the left arrow. So if we just look up left arrow in here, we're going to search through the free icons, and we're going to go for the long left arrow. So if we click that, we can copy it and paste it inside of this button and update the class to be class name. So now that we have that, we would expect to see that icon showing up permanently in the side nav. And it's currently not, and that's because of some sneaky styles. But the other thing we're going to need to do is add some dynamic classes, and the first one is actually to the navbar. So what we're going to do is add a class name, and we're going to make it dynamic, so we use the curly parentheses, and it's not going to have anything by default, it's going to be blank. But then we're going to add on some JavaScript, and we're going to say if not show side menu question mark, then add the class open, otherwise just have a blank class. So what this does is if the show side menu state is toggled, we add the class open. Now the other thing we're going to do is add that same class to this div right here. So we're going to add a space to the end of the header and just add that exact same logic, or at least very close. No, in fact, that exact same logic. And now what's going to happen if we add that in is we get this button showing up. Now if I come onto a bigger device size, the button goes away. So the button in the side nav is specifically for when the mobile device search menu is open. And there's a whole lot of styles going on in the background to make all this work, but the moral of the story is that on a mobile device size, if we have the side nav open, that means we're toggling the menu across, and we need a little button to be able to close it afterwards. And so the last step in this whole process, before I go over it once again, is just to add an on-click to this button with the handle toggle menu state. And so now when we click it, that's going to close it, and then we can use the menu button to open it, close it, open it, close it, and in here we can do all of our searching. I could search up Metapod, and when I click that and close the menu, we can see that Metapod has been updated, and so on and so forth, and I can get rid of it and it's all good. And this only shows up on the smaller mobile device size. So that is looking very cool. Let's go ahead and close that and just go over that once again. So basically, on a mobile device size, this side nav becomes an overlay. It's an absolutely positioned element, and it only shows when a state managed inside the app is set to true, when show side menu is set to true. Now we defined a toggle menu state, which basically if we click something that's going to toggle the state, we'll either open or closing it depending on the current state. And the first thing we did is we assigned that to the menu button in the header component. So when we click the menu button, it opens up the side menu. Now the other thing we had to do is provide the functionality to the side nav to close that. And so how that works is within the side nav, we have some special elements in here. We added some dynamic classes to the nav and the div, where basically if the side menu is set to true, we add the class open. And that just gives it the necessary styling to hide this button on a big screen. If we come across to a big screen, we don't want the arrows because the menu is always displayed. So it will hide the button on a big screen. But more importantly, when it's a small screen and the menu is open, when we click on it, it's going to once again toggle it to now close it. And just like that, we have our fully fledged application. We can see that Metapod is currently selected. Everything is working well. It's super responsive. We can click on the Pokedex. I can go to Bulbasaur, come back, and Bulbasaur is now displayed. Now the last thing we're going to do is actually adjust this toggle menu. I think it's weird when we go and select a Pokemon, it should actually close the menu. So what we're instead going to do is define a function called handle close menu. And that's going to set showed side menu to false. And I'm actually going to pass this down instead of the toggle menu. It's going to be handle close menu, because if the menu is open, the only functionality we need from within it is to be able to close it. And now if I come back into the side nav, I can update the name of that prop, handle close menu, and I can also update the function assigned to that state in addition to coming down to when we select a Pokemon. So here we say set selected Pokemon to the true Pokedex number, but we also want to invoke the handle close menu function. So that's going to update the Pokemon, we'll load a new Pokemon in, and we'll also close the side menu. So now what happens if I refresh the page, we find the Pokemon in the stash, And for some reason that's not working. And I think the reason that's not working, and I'm just going to change the default from false to true, is because somewhere in the logic I have reversed these value names. So for some reason this does the opposite of what it should do, i.e. when show side menu is true, it's actually false. And that's a little artifact that I challenge you to go and resolve, because it works and it was the last step, and now I think it's time that we deploy the application. But yeah, that's looking absolutely wicked. Let's load in Venusaur. We've got the little loading state. This one has loads of pictures. You know, we can look at sword dance, a dance that increases attack, and we can once again bring this down onto a mobile device size. We've got all the pictures. We can open it up, the Pokedex, search up Squirtle, and everything is working beautifully. Now to go ahead and deploy the application, the first thing we need to do, as we did in the first project, is actually deploy it to GitHub. And the way that we're going to do that is by opening up GitHub Desktop. And with that window open, we're going to select this repo button, add a new one, add an existing repo, and just choose the path directory, which is now this Pokedex folder from within our React full course. If we go ahead and open, we can create a repo here, initialize it with a repo. And this is just going to say a React.JS Pokedex styled with FantaCSS. That's pretty cool. And it might just make it more authentic by, once again, using that E. Now, I think when we initialize a project with React, there's actually a default repo, so it's up to you whether or not you click this button. If we initialize it with a repo, I think it will overwrite the React blank one, but that's actually fine. So we're going to go ahead and create this repo, and then we're going to, at long last, publish it, and I'm going to keep it public. So if we go ahead and publish that, that's going to push it off to our GitHub page, which allows us to access this code inside of Netlify. So if we come back over to our browser, now that that has been published, we can load up netlify.com. You'll need to sign into your account once again. I always log in with GitHub so that everything is just connected. And from within here, what we can do is go add new site, import an existing project. I'm going to import it from GitHub. That's going to ask me to do a whole authentication thing. And then we can look up that repo. And if it's not there for you, you obviously click this button down below and add it from those options. But I'm just going to look up my Pokedex, which we find right here. And then if we scroll down at the bottom and hit the Deploy Pokedex button, that should go ahead and deploy our new project for us. Now, while that's deploying, what I always like to do is come over to the domain management, and in here, I like to edit the site name. And so I'm just going to call this cool-small-james-Pokedex, whatever kind of name you like. That's going to save that, and that's going to be the URL that we're going to use to share our project with the world. And then if we come up, we can see that has been deployed to the internet, and I can now load it up, open it up in the browser. It's been successfully deployed. This is a live link that I could share with anyone, including me. If you've just done this, you could absolutely share this with me on LinkedIn, tag me in the project, make some customizations, and we have a fully functioning app. We can see that the menu works. If we come over to the console, we can see it fetch the Pokemon data because we don't have an existing cache yet. And then I can scroll down, I can click on a move, it opens that up, binds the target for 2 to 5 turns. We can also click on a new Pokemon and it loads up the stuff for Ivysaur. So that is absolutely brilliant. You know, I think it's a wicked project. Once again, slam this in your portfolio, start applying for some jobs. And obviously, congratulations, you are now 2/3 of the way through this course. I hope you're having an excellent time. And with that all done, how about we now go ahead and dive into project number 3, the coffee tracker. All right, it is now time we embark on the final part of our adventure together. I hope you're having an absolutely brilliant time. And this project that we're about to build is insanely cool. It's a coffee tracker, it's got database, authentication, everything you could possibly want. You could literally add monetization to this super easily, start charging a monthly subscription fee, and people are going to pay you. You'll make absolute bank. The world is the limit with what you're going to learn from this project. And it's literally the tech stack, well, pretty much, that I use to develop my own software, which people pay for and I make money. The backbone of this technology, Hire.sh, my resume builder software, is very equivalent to what we learn in this project. So you could take this, adapt it, and turn it into your own profitable SaaS platform. So it's super exciting, should be absolutely brilliant, and by the end of it, you should really be feeling comfortable in the driving seat of React.js. Now, as always, you can find a link to the GitHub code in the description down below, so if you get stuck at any point along the way, you can always compare your code to mine. And likewise, if you have any questions, leave them as issues on the code repo, the GitHub repo, and either myself or someone else will help answer any questions, qualms, or queries you may have. Now, third time's the charm. It's time to initialize our final project, and I'm going to start off doing that from within an empty Visual Studio Code window. So this is a completely brand new window. Now I'm going to go ahead and click the open button right here, and I'm going to navigate to the folder where I have my React full course. Right here, let's look for React full course. And we're going to go ahead and open this folder. We're not going to select any of these subfolders. That's going to open up our project. Here we can see we've got our Pokedex app. We can also see we've got our Todo App. You know, these should be committed to your GitHub. And now we can open up a new terminal instance using the Control and backtick key. Once again, if you want all the VS Code shortcuts, you can find them at vscodeshortcuts.smalljames.com. This is also linked in the description down below. So now that we've got that terminal open, we can come over to the Vite documentation and find that special command for initializing our React.js project with Vite, which is just the build tool. So from within the React.js full course directory inside of our terminal, I'm going to type the command npm create Vite at latest, and this project is going to be called Caffeined. I thought that was a super clever name because it combines the word caffeine, even though the "ed" is technically spelled incorrectly, where a fiend is someone who is an addict, and it combines, smushes coffee and addict together. So we're going to hit enter on that. We're going to select the React.js framework. We're going to select JavaScript, and then we're going to follow the instructions printed out in our terminal by cding or changing a directory into caffeined, just like so. Hit enter on that. Then we're going to run npm I or npm install. That's going to install all of our node modules for our project. And for now, that should just about do it. We're not going to boot it up just yet. Now I'm also just going to close out of all of those tabs that we had open up there. And here we have our final project, Caffeined. Now that has all the same files as usual. Obviously the ones we ignore, node modules, any of these lint config files, the package.json, all of that stuff we're going to ignore. For the README, I would recommend having a what's the problem, how am I going to solve it, any issues I came up with, what is the final solution. And that's just great because if you're uploading these projects to GitHub, employees can read through them, gain some context as to what and why you are building stuff. So that's super cool. You don't have to do it just if you want to. And then for the main stuff, all the magic happens inside of the index.html, the public folder for all of our assets for our projects, such as images, and the source directory with all of our React.js files. Now, straight off the bat, we're going to delete the app.css. We'll keep the index.css, and inside of the app, we're going to clear out this React functional component and get rid of all of the JSX. Keep these React fragments which are the empty divs. We can get rid of the state until we are left with just a few lines of code that is a bare bones React.js functional component. Now this application, just like the rest of them, is pre-styled. So what I'm going to do is come into the index.css, delete all the code that is currently in there as part of the boilerplate React.js project. And the first thing I'm going to do is copy the code from the index.css sheet inside of the GitHub repo. It should be around 278 lines of code. We're going to go ahead and save that. And then we're also going to copy across the fanta.css sheet. And that obviously has all of the styles for the elements and all that good stuff. So now that we have completely styled our application, we're the world's fastest React.js stylers, which is a pretty cool title to have. The last thing we're going to do to finish our configuration is come into the main.jsx, which takes our app and injects it into that div with the ID of root. Now in here at the top, we're just going to import that fanta.css sheet, and that's all of our styling done for this entire project. Now also pretty typical when we're just starting a new React.js project, I like to set up my folder directory. And the only thing I really need to do in this case is to create two folders. The first one is components from within the source directory. The second one that we're also going to make is a secondary folder. And that second folder is just going to be called utils. And it's got all of our utility functions for this project. Now, as for the components that we're going to have, if we just go ahead and make some JSX files, the first one on our list is going to be a layout.jsx. Now, this is a new file. It's pretty cool. We'll see how it works shortly. We're just going to create it for the second. After that, we've got a secondary one. This one is going to be called authentication.jsx. Now, this is obviously the first time we're dealing with authentication inside of a React.js project. And this project is actually a full stack project, as we'll be using Firebase for all of the backend database and authentication functionalities. So that is super cool. We'll learn how to set all of that up. After the authentication.jsx, we have another one. This is going to be called coffee form. The form is capitalized .jsx. That's going to have a form that allows us to take in all of the data about a user's coffee habits. After that, we've got a stats.jsx. This component just breaks down all of the statistics about the user's coffee habits. After that, we have a history.jsx. Let's hit enter on that. And then pretty close to the end, we have a modal.jsx. That's very equivalent to the modal that we used to display the Pokemon move information in the previous project. And is that all of them? We have one more, and it's called the hero.jsx, where the hero section or the hero component is for basically the converting of a site visitor into an official user. For example, if we come back over to my site, this section right here is the hero section. It takes a person from visiting the website to deciding that they want to commit to it. So that's pretty cool. In this project, we're actually going to learn how we can speak to a user and try to really get them to convert to our site and become someone who habitually visits the website. So that's going to be pretty cool as well. Now, I always love creating components at the start because it really helps me just compartmentalize in my head what's actually going to go on in this project. Obviously, I'm going to have the hero section, then I'm going to have the coffee form. Then underneath that, I'm going to have all the stats and the history of people's coffee addiction so they can see just how appalling it is and how much bank they are unleashing on the coffee industry. And obviously, we also have the authentication system, which is going to allow a user to create an account, sign up. This is going to be displayed from within a modal. And then, they can log out and obviously reload the page, load the website on their phone and get all the same information. It's persisted everywhere. Now, the other thing I've done for this project, and this is specific to when I'm building full stack projects that manage a lot of data, is I like to have fake data. And this is good because it helps me display everything and just mentally imagine what everything is going to look like without needing to actually do it 100 times before I actually have data that I can display on a screen. So for all of this data that I've prepared, we're going to create a file inside of the utils folder called index.javascript. And what you'll want to do is once again head over to the GitHub, and if you're there, if you could star the repo, love that support, go to the index.javascript file inside of the utils directory and just copy all of that code across. Once again, it should be about 200 lines of code. And the first thing we're going to do is understand exactly what is going on inside of this file. Now, this is a pretty important file for our project for a few reasons. First up, it has information about coffee levels. For example, we have a low caffeine blood level. If you're not familiar, a coffee might have 160 milligrams of caffeine. And there's also a concept known as a half-life, where the half-life of something like caffeine is the time taken for 50% of the caffeine in your bloodstream to be metabolized, which means that it's basically digested and no longer in your bloodstream. So that information is important because we're going to track how much caffeine is currently in the user's bloodstream. Let's say they had a coffee in the morning and a coffee now. Where are they at? What's the warning level? And what is the implication of that current caffeine level? Are they feeling high, where elevated caffeine levels can cause jitteriness, rapid heartbeat, trouble concentrating, signaling, which collectively signals an excessive intake? So we just have some status levels which tell us a bit more about what your caffeine level looks like. After that, we have all of the coffee consumption history. Now, once again, this is just fake data where the key is a UTC, which is a time zone, a millisecond amount for a time zone. So essentially, what we're going to do, the way we're going to track the data, is whenever a user adds a new entry, we're going to get the current UTC time, which is like the number of milliseconds that's passed since January 1st, 1970 or something like that. So it makes it a really good global time zone. And then we have a record of what they consumed and how much it costed. So at this particular time increment, a person got an Irish coffee and that costs $4.88. So that way we can tally up a bill, tell them how much they're spending. And if we scroll down, we can actually look up exactly how much that coffee option has. So I can't remember what we were just looking at. What is it? An Irish coffee. Here, if we look for Irish coffee, we can see that it has 160 milligrams of caffeine, which is not insignificant, where 1 cup of instant coffee might only have 30 milligrams. So this is just good information to have. We're going to need it for our project. We've got a whole lot of different coffee options that people can select from when they're inputting that information. After that, we have a variable that's used in some of the calculations beneath. This is the half-life. This is the hour amount. In this case, it's 5 hours. From a technical standpoint, the half-life can vary depending on how much food you've eaten, what your food eating habits are like, what your body weight is, what your fat composition is, all that kind of stuff. But on average, it's probably around 5 to 6 hours, so this should be fairly accurate. And then beneath that, we have some general utility functions. Now, these are just not really specific to React, so I wrote them out in advance. The calculate current caffeine level function, all it does is it takes the history object, which we have up here, and it calculates from all of those entries what your current caffeine level is, considering the half-life, which is the rate at which caffeine is metabolized or digested by your body. So it's not really that complicated. All it does is it basically takes all of the individual entries, adds them together as appropriate, and returns the final amount, the milligram amount. So that's pretty cool. After that, we have a helper function that just sorts through all the coffee options to find the caffeine amount associated with a particular coffee name. That's important because in our history, we only track the cost and the name. We don't actually track the caffeine amount because we have that information available in a different location. And this function just lets us go and look it up. After that, we have another function. This is called get the top 3 coffees. This just goes through our entire history and creates a tally of how many times we've had each type of coffee and returns the top 3. So that's an important statistic that a user can see. Oh, my 3 top coffees are a latte, an almond milk iced latte, and an oat milk iced latte. So that's a little bit of fun. After that, we have another function. This one's called time since consumption. And all it does is it takes the millisecond amount and converts it to a string that basically says 6 days, 4 hours, 2 minutes, and 37 seconds. So you can see that none of these are really React. They're just some utility that I thought could be done in advance and wouldn't really diminish on the amount of React.js covered in this course. It's kind of just some quality of life improvements. So that is the index that is copied across from the GitHub, and I just thought it was important to understand what's actually going on in the background of these functions. So now it is time to start coding. And where do we begin? Well, I think an appropriate place to start our project is inside of our now empty app.js. And the first thing I'm going to do, that I always do when I'm building an application with an authentication state, is I basically create a fake one to start off with. And this is a really good practice because it helps you develop your whole application as if a user was logged in, but you don't have the uptime of configuring all the authentication stuff until you actually need it. So currently, the way that I like to do that is with a variable defined inside of the app component that's just called isAuthenticated, and that's going to be set equal to false for the minute. And this is where we're going to manage our authentication state until we've configured our actual authentication. And this is basically just in conjunction to having the fake data that allows us to build everything and then use real data, swap out the fake stuff, add in the real stuff at the very end. Now, if we come down to the JSX right here, that is returned from the app component, the first thing I'm going to do is actually remove the React fragments in this case, and instead start off by adding the layout opening and closing tags. Now the layout component, which we've defined up here, if we save that, is going to be a React functional component where we export a default function called layout. Now this layout React functional component returns the React fragments, which is pretty straightforward. And essentially how it works is we come in here and this component receives props, where the props it receives are not the attribute style, but instead it receives children content. So we can destructure that out from the props. And this works very equivalently to how the modal worked in the previous tutorial, where the children contents is just whatever is contained within the opening and closing tags, where we actually go and render out the component. Now we obviously need to import that from the layout.jsx file. And in a bigger project, I almost always have this layout file specifically for when we have different states, for example, an authenticated state, and perhaps they're even on different pages. And what that means is that I can reuse this layout, which often contains the header and the footer components. I can reuse this layout across multiple different pages, and that keeps my pages looking very consistent and I don't have to rewrite any code. Now, as for what the layout component actually renders, bang smack in the middle, we're going to have the children content. So that's pretty straightforward, and we render those from within the curly braces, as that's what we throw JavaScript inside of to have it rendered within the JSX. And just above the JSX, underneath where we destructure the props, I'm going to define a variable called header, and this is going to contain the header opening and closing tag, and I'm going to define another variable called footer, and that is going to contain the footer opening and closing tag. And so now what I can do is from within the JSX, I can render out the header just as I did the children contents, and I can also render out the footer down the bottom. And just for correct HTML semantics, I'm going to throw the children contents within the main opening and closing tags. And so essentially what that means is that we just have our header opening and closing tags, then we have the main content of the document, and at the bottom we have the footer of the page. And so now this is a very reusable component where if we had lots of different pages, we could just throw in the layout as we have just in here, and whatever content we have on that page would be wrapped within the main section and consequently a repeated or reusable header and footer section. So that's just super convenient, and it's going to save us writing these out numerous times. So that is the layout done. What do we do next? Well, let's render out some contents within the layout tags. So if we think about how our page is going to flow, when a user comes to the page, the first thing they're going to meet is the hero section. That's the part that tells them why they should convert into a user. So this is a self-closing component. We're going to render it out, and we're going to export a default function called hero, and that's going to return a div. Pretty straightforward, and that is our hero component complete. And I actually think I'm going to change those to React fragments and make that the general practice for this tutorial. And obviously when I say complete, it's obviously just complete for now, not eternally. While we're here, what I might do is copy this template and just paste it into all of these components quickly so that we don't have to come through and finish them all out independently. And then what I'm going to do is just update the name of each of these functions so that it matches the file name. So in the modal, that's going to have a function modal. In the history, that's going to have a function called history. In the authentication, that's going to have a function called authentication. In the coffee form, that's going to have a function called coffee form. And then in the hero section, that one's done, history is done. And now all of our components are blank React functional components, which means that the auto import will now work. We can import the hero section. And after the hero section, we're now going to have the coffee form, making sure that we import that component as well. And that is a self-closing component. So if we think about it, our page, the hero section tells the person what the page is all about. And then the way that we're going to convert them in this application, there's a number of different ways, is by actually giving them the opportunity to see what the page would literally look like. They can start inputting all the information, and then when they go to add it, if they're not authenticated, we'll pop up the modal, we'll get them to sign up, save the information, and congratulations, we have converted a user. So that's how the coffee form is going to work. Now, underneath the coffee form, we have some information that is specific to users that have actually signed up to our page and are logged in. And for that, what we're going to do is create a variable that's called authenticated content. And that's going to be equal to some React fragments that are inside the circular parentheses. And in here, I'm going to render out the stats component. And beneath that, I'm going to render out the history component, making sure once again to import both of them. And then what we can do, now that we have the authenticated content separated and isolated from what's returned from the page, we can conditionally render it. Now, if you recall, conditional rendering is technically JavaScript, so we use the curly braces. And inside here, we need to define the condition for which the content is rendered. And in this case, it's only when is authenticated is true. And so I think it's the and short circuit is what this syntax is called. We say is authenticated true, and only then can you actually render out authenticated content. And so this logic right here, while very simple, just says if authenticated is false, do not show the authenticated content. If it's true, then render out the authenticated content, which is the stats and history components as well. And so now that we have all of that done, we can start building out these components, and we actually have a lot of the foundational logic complete for developing this full stack application. So it is now time to boot up our project. We're going to come down to the terminal and type in npm run dev, hit enter on that, and that is going to open up our project on localhost 5173. We can paste that in, click enter, and we obviously get a completely blank application. Now, at this point, and I should have pointed this out earlier, all of the applications that we're developing are also themed for light mode as well. It's dependent on what the user's default preference is. If you want to see what the light mode for any of these projects looks like, what you do is you open up the Chrome Developer Tools, and you click this little paintbrush right here, and you just select Prefers Color Scheme Light, and that will show you the light mode equivalent of the project. So maybe for a little while we'll keep it that way and see what it looks like. Now, the first component we're going to start off styling is actually the easiest, and it's the hero section, because it doesn't have a crazy amount of logic and is pretty much just some static content. So inside these empty React divs, we're going to start off at the top of our page with an h1 tag, and that's going to say coffee tracking for coffee, and then we're going to have the abbreviation tag, and that's going to say fiends, and then at the end we'll have an exclamation after the closing abbreviation tag. Now, if you're not familiar with the abbreviation tag, that is specifically used when you're going to add the title attribute, and because a fiend is a word that not a lot of people are familiar with, we're going to define it inside of the title attribute, which is added to the opening tag, and that says an enthusiast or devotee, and that's what the people using this application will be. So if we save that, we can see that comes up on our page right there. That's looking pretty hunky-dory, not too bad. Underneath that, we're going to have a div, and this is going to have a class name, where we use class name as the attribute instead of class inside of React, because class is a reserved keyword. And this is going to have a class of benefits list, and within it, we're going to list out some of the benefits that users will get from using this application. Inside here, we're going to have an h3 tag that just says try, and then we're going to have a span tag, which is a sub tag within this typography h3, and it's going to say caffeined, just like that. That's the name of the app, and the reason we're using a span is because we're going to give the span a class of text gradient, which is going to make it look all pretty. And the h3 itself also has a class of font-bolder, and then after the span it's going to say, so it says try caffeined and start triple dot, just like that. And then we can save that, and beneath it we can have a paragraph, and that's going to have the tick, if I can get it to show up. Come on, little tick. The tick emoji right here. If you don't have easy access to a tick emoji, you can obviously copy it from the GitHub repo. And then we can say tracking every coffee. So we're just finishing the sentence. Then I'm going to select that line, copy it, and paste another version beneath, and one more, because we're going to have 3 benefits, or 3 things that they're going to do. The second thing is measuring your blood caffeine levels, and then finally it's going to be costing and quantifying your addiction, because that's what it is. Caffeine is a drug, and most people, well, at least I'll get a headache if I go too long without it. If it's 11 or 12 o'clock in the morning and I haven't had my coffee, I'll have a headache, which isn't good. I should really go to Caffeine Anonymous, I guess. Underneath that, above the closing fragment, we're going to have a secondary div, and this is going to have a class of card. So let's add a class name of card and a secondary class, so we're going to space separate them, of info-card, and this is going to contain some information about caffeine that people might not know. So in here we're going to have a div, and this is going to have an icon. We're going to set the icons up in just a second, but it's going to have an h3 that says did you know triple dot. And now for the icons, once again, we're coming over to the Font Awesome CDN linked in the description down below. We're going to copy this top link tag, and we're going to paste it into the index.html of our document inside the opening and closing head tags beneath the title. So if we paste that in there, that's going to enable us to use Font Awesome icons. And while we're here, we're just going to update the title of our document to be caffeined. And then we're going to have a little bar symbol, poll symbol, I don't know what it's called. And it's going to say track your coffee, because that's what it's going to do. So now that we've imported that Font Awesome CDN package, we can now come into fontawesomeicons.com. We can select the icons and we can search up the info icon. So we want to sort by the free ones, and right here we're going for this info circle. We're going to copy it and paste it just above this did you know, ensuring that we replace the class attribute with class name. And then beneath that, we're going to have an h5 tag, and this is going to say that caffeine. And now, if you tried to add an apostrophe, React will be unhappy. So you have to use the HTML code for an apostrophe, which is an ampersand, and then apos, and then a semicolon. So you just need these characters to have an HTML recognized apostrophe. Caffeine's half dash life is about 5 hours question mark. And then underneath that we'll have a paragraph. Let's see who can type faster. This means that after 5 hours, comma, half the and obviously you can copy this from the GitHub if you want. Caffeine you consumed is still in your system, keeping you alert longer, exclamation. So if you drink a cup of coffee with 200 milligrams of caffeine, 5 hours later, you ampersand apos semicolon, you'll, that's why we do that, that's the apostrophe, still have about 100 milligrams of caffeine in your system. Cool. That is a little bit of information about how the half-life of caffeine works. And now if we come back to the application, which we just haven't been looking at because we've been so intensely focused on the code, we now have a nice little hero section where people know, they learn about the application, what it's for. It's for tracking let's make sure we spell that correctly, every coffee, save that, measuring your blood caffeine levels, costing and quantifying your addiction, and we have this nice little information card that tells them a bit about it. And once again, we could come back to the dark color scheme, and that's what we're looking at. So that's pretty neat. That is the hero section done, and that is actually our first component complete because it doesn't have any JavaScript. It's just some information about the application. Now the other one I want to focus on is inside of the layout. I also want to quickly develop or build out the header and footer for the entire page. So the header section or tags are very simple. We're basically going to have a div and in here an h1, and that's just going to say caffeined, all uppercase, and it's going to have a class name of text gradient. So that's going to be super cool. And on the other side of that, we're going to have a paragraph that says for coffee insatiates, which is a pretty cool word for people who are unable to satiate their caffeine addiction. And then on the far right hand side of the header, we're going to have a button. And obviously these are all miraculously pre-styled for us. And this button is going to contain a paragraph that says sign up free. It's obviously the conversion button. It's like book now or create a free account. We're going to say sign up free, and we're going to throw in an icon where the icon we're going to use is a coffee. Let's look up coffee. And we're going to go for this hot mug icon, copy that icon and paste it, updating the class to be class name. And just like that, if we save that and come back, we now have this nice little header section That looks good on a mobile device as well. The whole application looks pretty wicked on a mobile device. And we have the nice little sign up button. And once again, if we come over to the light scheme, it also looks good, which is convenient. We've got caffeine for coffee insatiates, and then we can let the user sign up for free. So that is the header done. And now we'll do the footer, and then we'll get to all of the logic. So the footer is going to be very simple. In here, we're going to have a paragraph, and it's going to start off with the span tags that just has caffeine once again. So we can add a class specifically to this word that says text-gradient. And then after that, it just says was made by, and then in here, we're going to throw in an anchor tag. And that's going to say small James. Obviously, if you have a portfolio website, you can throw that in. If you want to credit me, you're more than welcome to. And that's going to have an href attribute because it's an anchor tag to my website, www.smalljames.com. And then after that anchor tag, we're going to say using the, throw in another anchor tag. And then this is just going to say FantaCSS. With an href of https://www.fantacss.smalljames.com. And don't forget to add the target attribute to be _blank to both of these anchor tags, because that's pretty important to ensure that they open up onto a new page when you open the tab using FantaCSS design library, just like that. And so that's going to be our little footer, just to give credit to, whoever made the site, any other websites you want to link, and that just looks neat down the bottom of our page, and obviously looks good on a mobile device. And as we fill out more content, that will get pushed further and further down the page. But just like that, we already have the start of our coffee app. It's looking pretty cool, looks great on a mobile, and you can really see how it would begin to convert people into a user. They sign up free. We're going to have a whole lot of opportunities for them to convert, especially when we throw in the form, which is going to look absolutely wicked. And we'll do that by coming over to the coffee form component. Now, this component is interesting. We've got some more React concepts in here. We're going to map out some stuff, and we've also got a whole lot of inputs. So at the top, the first thing we're going to do is have a div, and this is going to have a class of section header. Now inside here, we're going to basically tell the person what they're doing inside of an H2, and it's going to say start tracking today, and these are all going to be capitalized. And above that, we're going to have an icon, and you could import it if you want. I'm just going to type it out. It's the I tag, and it has a class name of FA solid FA-pencil, and that can be self-closing. And so if I save that, we now have our little header right there. The other thing I'm going to do quickly is actually jump around to the footer, and just after the small James anchor tag, I'm going to put in the break tag. And that's just going to send that down onto a second line, which I think just looks cuter in the bottom left-hand corner, and it doesn't span across as one line. Anywho, back to the tracking. So if we come back into the coffee form, that's our first div. Underneath that, we have an H4 that says select coffee type. And this is where we're going to have the first input. So what we're going to do is we're going to have a div. This is going to be 6 buttons basically, and then if it's not one of the main 6 buttons, it's going to be part of the drop down. And this is going to have a class of coffee grid, which is going to be a 2 to 3 column grid of 6 different coffee options, the most common ones. So in here, what we're going to do is use the curly parentheses, because this is going to be JavaScript. We're going to map over the coffee options, which, if you recall, are available to us from this utils file. If we come in here and scroll down, we'll see that here we have coffee options, and it's just an array of all of the coffee options. And so we're going to go ahead and import that up the top of our document. We're going to import coffee options from utils. And then in here, what we can do is we can slice it. And we're going to use the array method slice from the 0 to the 5th, not including the 5th entry. So it's going to be the first 5. That returns a new array containing only the first 5 entries. And then in here, we're going to have an arrow function that receives basically an option and an option index. Remember, we need that unique key, so we're going to use the index. And we just return a button that has a class of button card, and it needs that unique key attribute of option index. Now inside this button, we pretty simply have an h4, and that's just going to be option.name to access the name key within that option. And then underneath that, we're going to have a paragraph that has the option.caffeine amount and then the little milligram sign. So if we go ahead and save that, here we can see we have our 2-column grid that when we hit the breakpoint jumps to a 3-column grid. And that looks super slick, and we can see we get a nice little border when we hover over them as if they were buttons, so that looks super clean. And then we're going to throw in, still inside this div, a custom 5th option. So it also needs the class of button card, and that's just going to have an h4 that says other. And underneath that, we're going to have a paragraph that has not applicable, because obviously the 6th option doesn't have a caffeine amount, so that's not applicable. But if they click this, then we're going to have an input show up that shows all the other options, and we'll get that working in just a second. For now, we're going to have it so that it always is present, and later we'll make it so that it's only conditionally rendered if that button is selected. So that's going to go within a select element tag. It's going to have the ID of coffee list, and it's also going to have the exact same name, coffee-list. And inside of this select, we're going to have options. So the first option is going to be a default, so it's going to have a value of null. And this option is just going to say select type, so it prompts the user to select something from the dropdown. After that, what we're going to do is map out all of the options. So in here, we're going to say coffee options.map, and we're just going to map over all of them this time. So it's once again going to be the arrow function, the anonymous arrow function. We're going to receive the option and the option index as the keys or the arguments for the arrow function. And in here, we're going to return, and instead of returning a button, in this case, within a select, it's just going to be a whole lot more options. The value is going to be the option.name. That's going to be the name that's going to be saved. And obviously, we also have to provide it a key, where the key is also going to be option index. And lastly, in here, we're going to have some text, so we're going to open that up onto a new line, and that's going to be some JavaScript that has option.name, and then inside of the circular parentheses, we're going to have more curly braces, and that's going to have option.caffeine space milligrams. Now, if we go ahead and save that, now we get this select type, where when we click on it, we get all of the options showing up, and I'm actually going to remove the space between the milligram and the caffeine amount. So that's just the native select. That looks pretty good, and that's only going to show up if the user has selected the other, and then we're going to allow the person to select from loads of different coffee options. Now there's obviously state that we need to manage within the select that we haven't done yet, but we will come back to that when we are ready for it shortly. First, let's just get all the elements on the page for this coffee form. So after the select, we're then going to have an h4 that says add the cost, and then it's going to have the $ inside of circular parentheses. Now underneath that, we're going to have an input that has a class of width-full, w-full, and that just ensures that the input takes up the whole width, and it's a self-closing element, and it's going to have a type of number and a placeholder of 4.50. So if we save that, we'll see that input show up, add the cost 450, and we can see now that the person can either enter a numeric amount or scroll through the different number values. So that's going to let them save the cost of the element. And then underneath the cost, the last thing we need is the time of consumption. So there we're going to have an H4 that says time since consumption. And then underneath that, we're going to have a div that has a class of time entry. And this is going to create a nice little grid for the user where they can enter the time. We're going to have a first div right here that has an H6 element that says hours. Underneath that, we're going to have a select because we're going to let them select the number of hours. So that's going to have an ID of hours dash select. And then in here, we're going to map out all of the options. So we need the curly braces. Inside here, we need the array that we map over. It's going to be a custom array. It's not defined anywhere else. And we're just going to go through the options, which are all the hour values for the day. So we're just going to go up to 23, and you could copy this across from the GitHub if you choose to. 18, 19, 20, 21, 22, 23. That's perfect. Then we just map over that. This is going to have the hour amount and the hour index. Technically, we don't need the hour index because the hour is actually unique. However, in this case, we're just going to return, once again, an option that has a key that is the hour index, a value that is the hour, and then in here, the text that's going to display is just the hour. And I made a spelling mistake right here. Hours should just be hour. So that's the first one done, and here we can see we have that amount. To be fair, this could also be an input of type number, just like we have here. I like the little select option because, you know, you don't have to write anything out. There's not that many options. So 7 hours ago, I consumed it, and then we just need an equivalent drop down. So we're going to copy this right here, duplicate it beneath, except this one is going to be called mins. And so I'm going to change the ID to mins select. And the options here are pretty simple. It's just going to be 0, 5, 10, 15, 30, and 45 minutes ago. So those are kind of the increments that we're going to allow the user to measure. And in here, we're going to change the values. Technically, we don't have to because, you know, it still works. It doesn't duplicate. But to keep the code clean, we're going to update all the values. So that's obviously the min, and then the hour index is now the min index. So we basically duplicated that select except for a minute equivalent. So now we have these two inputs where here I can say 9 hours and 15 minutes ago was when I consumed it. And then underneath that, all we need, very last, is a button that contains a paragraph that says add the entry. And that's our whole input form. So a user comes to the page, they're like, oh, I get to track on my coffee. This is a little bit about it. And then they can actually get straight to it. So what they're going to do is they're going to want to click these buttons, be like, I had a double espresso, I had a latte, you know, select the type if it's not there. And then what we can allow them to do is if they're not authenticated, we're going to prompt them to sign up. And if they are authenticated, then we can obviously let them complete the form. And so now that we have all of the contents for the coffee form, let's make it functional. Let's wire it up completely. So the first thing we're going to need is some state. Remember, stateful variables are when we have user interactions such as tracking what buttons or selections they're making on a page. So the first thing we need is a state that manages whether or not we show them this type menu. So up the top, we're going to import useState, the useState hook from the React package. And then at the top of our functional component just here, we're going to define a stateful variable inside of the square parentheses called show coffee types. And then obviously we have the setter function, so that's the set keyword in front of the variable name, set show coffee types. And that's going to be equal to useState. We invoke the hook and we pass in a default value, and that's going to be false by default. We do not want it showing until the user clicks the other button. Now, with that defined, the first thing we're going to do is actually allow this button to change that state. So for the other button, we're going to give it an onClick attribute. That's going to be an arrow function where when the function is invoked, it's going to say set show coffee types equal to true. So just like that, now when I click that, that state will be changed. Now the other thing I'm going to do is define a state to manage which is selected. So I'm going to define that above, and that's going to be called const coffee selection and set coffee selection. And that's going to be equal to use state, and that's going to be null by default because we don't have any selection by default. Now what we can do is for all of these buttons, these default buttons, we can assign an onClick, that's the arrow function, where when they click it, we set the coffee selection equal to the option.name. Now if the option.name matches this button or whatever option we're currently mapping out, we obviously want the styles to change. And we can do that very simply by making this class name dynamic. So what we can do is wrap that class name inside of the circular parentheses, which means we can write some JavaScript in here. We're going to throw a space onto the end of that string because we're going to do some string concatenation, and separate classes need to be space separated. And we're going to add the circular parentheses. The circular parentheses to ensure that this code is evaluated first and then appended to the string. And we're going to say if the option.name is equal to the selected, let's see what the state is called, the coffee selection. So that's actually going to be called selected coffee, I think. Let's change that. Set coffee selection, that's going to be selected coffee. Just makes a bit more sense. So if the option.name is equal to the currently selected one, let's also make sure we update the setter function just here. Then what we can do, we can use the question mark and have two strings. One is the true case and one is the false case. And if we have the false case, we don't need anything. But if it's true, we can say coffee button selected. And now in the case where the selected coffee is equal to the one that we're currently mapping out, then we can add the selected coffee button selected class to the original class. And now when I go ahead and save that and come over to our application, refresh the page so it's blank, when I click on Espresso, I would expect that hover state to be maintained. And now we can see that it is. We get that permanent border. Then when I click on the other one, it's all adjusting as we would expect it to. Now the other one currently doesn't work. So what we're going to do is do this custom, and I'm actually going to go ahead and copy this class right here because it's going to be very similar. So copy the class from the mapped out button, replace that one, but instead of having the option name, what we're going to do is show it selected when show coffee types is true. So in here, we're just going to say show coffee types. When we've clicked the button, we've opened up or basically displayed the secondary selection menu. Make sure that we also let them know that we're selecting from the other options. Now, one thing we want to do is make sure that this goes away when we click one of the primary options. So the way that we're going to do that is when we set the selected coffee, we're also going to say set show coffee types is equal to false. And what this is going to allow me to do is come to this selection right here. This is the optional one that's not always going to be displayed, and I can wrap it inside of curly parentheses and run some JavaScript on it. Wrap it inside circular parentheses because that's what I want to return, and then I can enter the select onto some new lines, and in front of the circular braces I can use that and short circuit. So I can use the double ampersand and say only show coffee types if show coffee types is true, and then display the selection menu. Otherwise don't display. If show coffee types is false, do not show it. And so now when I save that, currently I'm selected other, so I get the selection type. If I hit cappuccino, we can see that goes away. And now when I hit other, that shows up again. And furthermore, other maintains that state. However, one thing I want to do When I click this, right now, I'm showing this as a selected border and this one. So we have to make sure that when we select other, we reset the selected coffee type state. And we can do that very easily in here. We can just say set selected coffee types, set selected coffee equal to null again. So just to summarize that once more, because that's a bit confusing, when we select one of the primary 5, we set that equal to our selected coffee and it gets the pretty border. We also make sure that if we were showing the menu for the rest of them, that we then hide it. So we set that state to false. If we click the other button, we show the menu and we set the state to true, but we also make sure that if we currently have selected one of the 5 primary options, we reset it back to its default value so that it gets the border removed from it. So now once again, if I refresh the page, I can select espresso. That's now the selected coffee amount. And then if I hit other, I would expect the input to show up, the select menu to show up, and also that border to go away. And now we can see that the other state is selected, and I can now come down to this menu and choose from it. Now, this currently isn't wired up to also set the state, so that's the next thing we have to do. Now, the way that we wire up a select to set a state is pretty straightforward. All we do is we add an onChange attribute to the parent select tag that contains all the options. That obviously gets the callback function. And very similar to how we have an input, we receive an event. You could call that event, you could call that E, whatever you like. And all we do in here is we set the selected coffee, and I realize I made a spelling mistake. Selected should be capitalized in there, so I'm just going to go through and change that wherever we have it. Set selected coffee, set selected coffee, set selected coffee. I think that's all of it. And if we come back to where we were writing that out, we set that equal to e.target.value. So we access the event, we target it, and we get the value. Well, we actually set the value to option.name. So that's going to have the same effect as selecting one of those primary buttons. So now what we can do, when we click other, we can select a type. It could be Americano, and we can actually see that it selected the Americano option, even though we technically did it from here. And I don't mind having that as a functionality. If we change it to Cortado, obviously because it's not available up here, we wouldn't see it. And the selection state inside of this menu is obviously that tick right there. So that's pretty cool. That is our coffee selection working. And the main reason we need to manage that selected coffee state is obviously for when we go and eventually save it, we need to know which option has actually been selected. Now after that, we're going to need a cost state to manage the value associated with the cost. So in here, we're just going to say const coffee cost and set coffee cost. That's our stateful variable, and that's inside the square parentheses. And that's going to be equal to use state, and we're going to set it to a default value of 0. Obviously, it's going to be numeric. And all we have to do now is come down to that input. Wherever we had it, those are the coffee types right there. Then we've got the menu, then we've got to add the cost. Now in here, for the input, there's 2 things we have to do. First is we assign the value. So the value should always match the value associated with the stateful variable coffee cost. So that's pretty straightforward. And then just like with the select, we add an onChange that receives an arrow function as the attribute. It takes the event, and in the event of a change, we just set the coffee cost equal to e.target.value. That's how we get the value associated with an input. So if we go ahead and save that, we get no issue, that is working, and we now have officially saved the coffee cost that's associated with a variable, a stateful variable that we can refer back to at a later state. Once again, if we didn't do this stuff, when we go to submit the form, we don't have access to any of this information. So that's super cool. That's the cost done. Now what we can do is have the exact same logic for the hour selected, the minute selected, and then we can go ahead and be ready to submit the form. So I'm going to go ahead and define 2 more states. we're going to have a const hour and set hour, and that's going to be equal to use state, and I'm going to give it a null state initially. No, actually it's going to be a numeric value, so we're just going to set 0. And then I'm going to add once more, and that's going to be const min and set min, and that's also equal to use state, and by default it's a 0 value. Now if we go ahead and save those two states, we can now assign them to the inputs or the selects. And so in here we're going to have the on change to the select, the parent select. That takes the arrow function, it receives the event, and this one is for the hour. So all we do is we say set hour when this changes equal to e.target.value. And then we could literally just copy this, where if you remember the value is inside the option, and then we could just go ahead and copy this on change and throw it directly in the opening tag for the minute select, and just change that to set min instead. And now all of this is wired up. We can access all of the states, and what I'm actually going to do is define a function here, and that's going to be called handle submit form. And I'm just going to do this to demonstrate how the form submission is going to work. This might not be the final version, but I'm just going to console.log the selected coffee, the coffee cost, and the hour and the minute. And now what I can do is I can attach this handle submit form function to the submit button. So for the button down the bottom that says add entry, I can add an on-click event that simply references the handle submit form function. So that's instead of having an arrow function. And now what I can do is I can select a cappuccino. It was probably like $14.50 in the modern inflation. Crazy stuff. And that was 3 hours and 35 minutes ago. And now if I come over to the console, I'm already there. When I submit this or click this add entry button, I would expect all these values to be logged. And indeed they absolutely are. We can see we have a cappuccino coffee. It cost me $14.50, and that was 3 hours and 30 minutes ago. So that is working perfectly. Now at this point, it's also just good to note that everything is still responsive. That's so important. We have a nice little form and everything looks super neat. And once again, you can see how someone who came to this page for the first time is like, oh, that's so cool. I can just fill that out and keep a record. And then we'll start showing them the history and it will look absolutely wicked. So now that we've got the form done, the next thing we're going to do is show the data or the statistics basically, using all of our fake data for the minute. Obviously this won't be available for a non-authenticated user with no data. So it's time to jump into the statistics, which is all the information that we're going to collect about the user and display it on the screen. And we're going to do that from within the stats component, which is currently empty. And the first thing we're going to do is start off with the JSX. So for this component at the top, we're going to start off with the common div, giving it a class name of section-header. And in here, we're going to have an icon that has a class name equal to fa-solid space and fa-chart-simple. And then that can be a self-closing element. Now underneath that, we need the h2, and that's just going to say stats, pretty straightforward. And now on our page, if we refresh the page, that's not showing up. And the reason it's not showing up is because if you recall, our authenticated content is hidden because our isAuthenticated state is currently false. And obviously this is a fake state until we implement the authentication in database, which is coming later. But if we now change that to true, this conditional rendering is going to check that isAuthenticated is true and consequently render out the authenticated content, which is just this section right here. And now we have that little header stats showing up on the screen. So with that open and available to us, we can carry on our mission to show people how bad their caffeine addictions are. Now underneath this div, we're going to have a div that's a grid. And so this div is going to have a class name of stats.grid, just like this. And in here, what we're going to do is we're going to create a new component, but in a different way that we haven't seen before. So sometimes when I'm creating code that's going to be duplicated, and I don't want to use a map for it, but I'm also only going to be using it in this component and nowhere else, what you can actually do is define a functional component that is scoped specifically to this file. And the way we do that is above where we defined our original functional component, we create a secondary one. And once again, it's just a function. And in this case, it's going to be called statCard. And it just returns some JSX. And that is now a secondary functional component. It's not the primary one of this file. It's a secondary functional component that is to be used only within this component, the stats component, and that allows us to take advantage of the reusability of components, which in this case allows me to style it once and use it multiple times. Now this stat card receives some props, and we'll see what they are shortly, but there's 3 in particular that we can destructure out from the attribute style props. The first one is a variable called large, or a state called large. Then we have a title, and then we have the children. And those are the 3 props that this little component is going to need to receive. Now in the demo, we had, I think it was 5 different cards showing up, and then at the bottom we had a grid of the most common coffee choices. And so in this case, what we're going to do is come down to our stats grid and just render out 5 of them. So we're going to have a stat card, and that's going to have an opening and closing tag. And then what I'm going to do is copy this and just duplicate it 5 times. And so now we'll have 5 stats cards. And if we come back to our screen, nothing shows up, and that's because they have no styles. So we can come up to this little component and we can give it a class name, and this is going to be dynamic, so we need the squiggly parentheses. And the default ones are going to be card and stat card. That's going to be applied to all of them. And we'll throw a space at the end right there. And then we're going to add on, outside of the string, some more logic to be appended to the class. And essentially what we're going to do here is we're going to say if it's a large stat card, so if it's a bigger stat card, if the large is available as a prop, then we want to render out one string, otherwise another string. And if it's not, we just leave it blank. If it is, we're going to give it a property called colspan2, which in a grid display, if we have 2 columns, it tells this card to span across both of them. So the default is that we'll have 2 cards in a singular row, but if it's a large card, then it's going to span across both of them. And so now when I save these styles, we get 5 cards. Currently, none of them are a large card because we haven't passed that prop in. But now if we pass that as a prop to the first stat card, and in this case, technically you could pass it as a state called true. But if you just pass in a Boolean state, you can actually just abbreviate it to literally just have the prop name. And the difference is that for this stat card, large is undefined because it doesn't exist as a prop. But in this case, it does exist, so it has a truthy value. And therefore, just adding that large prop to this first card now makes it span across 2 columns. And that's looking pretty nifty. Now, as for the content, each of these is going to have a title attribute. That's going to be super important. And the title for the first one, we're going to add this, copy this right here, and paste it after the large attribute. The title for the first one is going to be the active caffeine level. For the second one, it's going to be daily caffeine, which is going to be how much caffeine someone's having on average on a daily basis. For the third one, it'll be average number, got to do that inside there, average number of coffees per day. For the fourth one, it'll be daily, keep doing it outside, daily cost. And then we're going to have the $sign in the circular parentheses. And then for the last one, it's very simply going to be the total cost. So that'll just be the average cost times by the number of days. Now you could obviously get experimental with the stats that are showing up, add some if you want. These are just the main ones that I thought a general coffee consumer would like to see. Obviously you could just throw in some extra stat cards, calculate some extra values. You know, the sky's the limit in terms of what information you could add. Now as for where that shows up in our div, we're going to create an h4 tag, and that is going to have the squiggly parentheses because within we're going to render out the title, which is the prop that we just added to all of the cards. And so suddenly you can see the benefit of having a reusable card instead of writing out this div loads of times. And now we have all of our different cards with their respective titles in place. Now underneath the title is very simply going to be the children contents. If you recall, the children contents is the contents contained within the opening and closing component card or tag. And remember, if you do not specify where to render out the contents, it will not show up. So it's super important to receive the children contents in the component and consequently determine where it's going to be rendered within that component. And now what we can do is start adding all of the children contents. So for the first one, within the opening and closing stat card, we have a div that has a class name of status. And you might be wondering at this point why I'm choosing to use the children prop for all of these stat cards. And it's because I'm going to use this as a generic wrapper for a card where the contents of each card can be hugely varied. For example, I could have some random divs in this one could have a whole lot of other random stuff. So the stat card is basically just a template where the children contents within the card can be, you know, all over the place, whatever we want. So back to what we were doing. The first one is a div that has a class name of status. And within here we have a paragraph. And this very simply contains a span element that has some JavaScript and a value specifically that we need to define. And that's just going to be some more fake data for the minute. So we're going to create some fake data for all of the values that we will later calculate. So in here I'm going to define a variable called stats, and that's going to be an object. And the first one is going to be the daily caffeine. And that's going to have a value of 240 milligrams. Underneath that we're going to have the daily cost, and that's going to be an average of 6.8. Then we're going to have the average coffees, and that's going to have a value of 2.3 per day. And then underneath that, we're going to have a total cost of $220. So that's just our fake data that we will later calculate when we have some real data. And after that, the only other piece of information we're actually going to need is the active caffeine level. So we're going to also calculate that up here. And that's not an interactive value, that's a calculated value, so we can assign it to a traditional variable called caffeine level, pretty straightforward. And that is equal to the util function that we have, calculate current caffeine level, and that receives the coffee consumption history as an argument, which is all of our fake data from our coffee consumption history, ensuring that we import both the coffee history and the util function. So the caffeine level goes within the span. It's JavaScript, so it needs to go inside of the squiggly parentheses. We just plug that in there just like that. And then immediately after the span, we're going to throw in a milligram. And if I save that, that's showing up as 0.000. And that's because the fake data is old. Now at this point in the tutorial, all your values will probably have gone to 0. And that's specifically because the millisecond amounts that we used in the fake data are very out of date. So because of the half-life, it will have all expired in your blood, but that is absolutely fine. That's no worries at all. But we're so close to having our own custom data that it'll be fine just to get the values showing. So technically at this minute, we have 0 active caffeine in our bloodstream, which is actually correct because it's more than 48 hours old. And the span in here needs to have a class name equal to stat-text. And now if I go ahead and save that, that's just going to be some nice big text that has the milligram amount that will be in your bloodstream. Now underneath this, what we're going to do, we've obviously got the paragraph right here, is we're going to have an H5, and this is going to contain some text that says just low for the minute. And we'll come out and change this later. This is just a fixed amount just for the sake of styling. And we're going to be naughty right now and apply some dynamic styles using the style attribute tag. Now this is absolute blasphemy, and I'm only doing it in this case because the styles are dependent on the current caffeine level. So essentially in here what we're going to do is apply a color parameter and a background parameter, and that's going to create a little warning logo, and we'll see what it looks like in just a second, where the color, if you recall, is inside of the index. So if we come up to the top right here, we have the color and the background color. So we need to access those values. So in here what we're going to do is access status levels, make sure that we import the status levels object from utils. And now what I'm going to do is just access the low value and access the color for the color parameter. That's the text color. And then I'm going to do the exact same for the background. And that would now say low. There we can see it's a low value and it's green because it's good. And the last thing we're going to do underneath that is have a paragraph that just has, once again, the description of that status. So it's going to say status levels, access the low value dot description. Now this is currently hard coded, and once again we'll come back and make it very flexible and dynamic shortly. But now what we can do is just get a little description of the active caffeine level. Currently they're mild because it's 0, which is correct. Now that's the first stat card, it's the biggest and it's also the most complex. For the second one, the daily caffeine, we have a paragraph. Once again it has a span, and in here it's got the curly parentheses because it's a JavaScript value, and it's the stats value for the daily caffeine. Now once again the span needs the class of stat-text, and after the closing span we're once again going to throw in the milligram amount. And I'm going to copy this line because it's actually going to be virtually the same for all of them bar the cost. So if I go ahead and save that, and I'm also just going to enter these ones onto some new lines for clarity. Just like that, we have a whole lot of stat cards. I'll do this one as well. Enter. Just like that, we have all of our stat cards. They have all the text for the average number of coffees. We just need to swap out the key. So that's going to be average coffees. For this one, it's going to be daily cost. And this one is going to be the total cost value. And once again, for the cost parameters, I'm going to remove the milligrams. And at the front, I'm going to throw on, in front of the span, just some dollar signs. And I think a little space after them. So now we have some milligram amounts. We've got some costs. And if we save that, we have all of the stats displaying in big text. Users like, okay, 0 blood caffeine, the daily average is 240, average 2.3 coffees, 220 total cost, and daily cost of 680. So that is pretty cool. And that's actually the stats component complete. Now, the part that we need to make dynamic, obviously we have the fake information that will be calculated later. But first what we need to do is underneath the caffeine level, figure out what warning we're actually in. And the way that we can do that is say const warning level is equal to, and we just do some conditional logic. So we say, is the caffeine level less than the status levels for low? And I think it's the maximum amount property. If we come up to the top just here, we have the max level. Is it less than the low max level? And if that's true, then all we do is we assign the low parameter because it's low. Otherwise, we check if the caffeine level is less than stats level, and we access the moderate key, and we get the max level for that. Is that true? If it is, then we access the moderate value, or we assign the moderate key. Otherwise, we assign the high key. So just to summarize how this warning level works, we calculate the caffeine level that's current. We check if it's less than the maximum level for the low status. If it is, we assign the string low. If it's not, we check if it's moderate. If it is, we assign moderate. And if it's not, then it must be high by deduction. And so now that we have that warning level, everywhere we manually type in low, we can replace that with warning level. And warning level is not a string. So warning level like that. Same with the status description. That's pretty straightforward. And now that should still say low and everything is working, but it's not so hard-coded, and that will be dynamic to their levels. Now, one quick thing I noticed is that I made a little oopsie because I'm a Muppet. Obviously, average number of coffees doesn't have a unit, so we're just going to come down to average coffees and remove the milligram. And the last thing we need to do is just make sure that these values are calculated and not hard-coded, and they are all dependent on our caffeine history. And so for that, I've gone and pulled a fast one on you, and I've added an extra utility function. And if you copied the utility functions from the index.js from the GitHub repo, you will already have this. For me, it's just been added. But essentially what this utility function does is it just takes the caffeine consumption history, does some logic, and just calculates these 4 parameters and returns them as an object. So what we can now do is we can call this function, pass in the caffeine history, and just have the stats as an object. It's a pretty straightforward function. It does a couple of things. You're welcome to go and have a look through, see how it works. I've left some comments to, add some clarity and transparency to it. But now we can come back to stats, and instead of having it equal to this random object, we can just go ahead and invoke that function, which is called calculate coffee stats. We can invoke it inside of our functional component, ensuring that we import it, and we can pass in the coffee consumption history. And so now when we go ahead and save that, we can see that on average we take a lethal amount of caffeine, because I think that most of the entries happen across one day. You can see that here we had 21.5 coffees in a day on average, which is crazy. The total cost is $212, and on average we're spending $106 a day on coffee, so we should probably do something about that. Now underneath these stats we have a nice little table that's going to display exactly what our favorite coffees are. So we can come to the bottom of this stat card right here, still within this div called stats grid, and we're going to create a table that has a class name of stat table. And I always love using the native HTML elements. And this one is going to have a T head. So the T head is basically all of the labels for each of the columns in our table. So in here we have a TR, a table row, and the first one is the coffee name, the first TH. The second one, which is the second entry, is going to be number of purchases, and the last TH is going to be percentage of total. So if we go ahead and save that, now we have these 3 titles at the top of our soon-to-be table. Now underneath that, what we can do is have the T body, and that goes underneath the T head, underneath the head of the table. We have the T body. Now in here, this is going to be some dynamic stuff. We obviously don't want to go writing out all of the rows. So we're going to need some JavaScript to map out each of the rows. And in here, we need to fetch an array of the top 3 coffees that we have. And we have, once again, got a utility function for this called get top 3 coffees. So once again, you can go through, see how that works if you want to have a look. It's pretty straightforward. It just gets the top 3 coffees. So we can call that function, ensuring that we've imported it. It takes the history as an argument. So we can pass in the coffee consumption history, and that returns an array which we can then map over. The map takes the arrow function, and from within here we return a TD, well actually a TR element. Now the top level return needs the key, the unique key, And we obviously need the arguments for the function as well. So it's going to just be the coffee and the coffee index. That's the unique index. And so the index is going to be the key. And then inside of the tr, coffee is an object that has some information. And so we're going to create a TD. There's 3 things inside of the coffee object. The first is coffee.coffeeName. That's the name of the coffee. The second one is another TD, JavaScript, curly braces, coffee.count. That's the number of times we've had this coffee. And then the third one, TD, is coffee.percentage. So these 3 parameters show us our top favorite coffees. And now we have this pretty little table. Our favorite coffee is the flat white, equal to the drip coffee. It's nearly 7% of our total coffee consumption. And then number 3, we have Bang Energy, which is actually just an energy drink. I included energy drinks because I figured they're caffeine products. I should probably include dark chocolate, but I haven't done that. Obviously, you can go and fiddle with the coffees inside of the utils file. But now we have this nice little table. Once again, looks great on a mobile device as well. And likewise, as you would expect, it also looks good in dark mode. Got a great looking page with some wicked stats, so people can really get an idea of what it is that they're doing with their coffee habits. Now that's the stats section done. Time for the lucky last, which is the history. Once we've implemented the history, we can actually go and add authentication, start tracking some legit data, and deploy our project to the internet once it's all completed. Now for history, the first thing we're going to do is have a section header just like in stats. So I'm actually going to copy this element from stats and paste it into history. Now obviously it's not going to have FA solid that particular icon. Instead it's going to have a timeline icon. So the FA solid remains the same, and we just change the secondary class for the icon to FA-timeline. And obviously stats needs to be changed to history, and that's the header for this section. So here we can have the history icon with the different timelines, and we've got that nice big header at the top of the section. Now underneath that, what we're going to do is have a paragraph that's italicized. So we have a P tag, then we have the I tags, and it's just going to say hover for more information. And that's because in here, what we're going to do is just literally show them, like a stamp card, how many coffees the person has had. And then when they hover over an entry, it's going to give them that information. Now underneath that, we need a div that has a class name of coffee-history. And there's not really much logic in this component, so it's pretty easy. All we do in here is we have some JavaScript that we need to map over, and that's obviously the history of all of our coffees. Now our coffee history is an object. And so what we're going to do is turn it into an array by all of the keys using the object.keys method. We pass in the coffee consumption history, which we have to auto import. Make sure that's imported so that we have access to it. And now what we're going to do is sort it to ensure or guarantee that the entries are in chronological order. So we're going to call the sort method, which takes an arrow function. And the arrow function has 2 arguments, an A and a B, where the A is the first entry and the B is the following entry. And all it's going to do, we actually don't need the curly braces back here, is just return B minus A. And sort is super clever, so it's just going to say if the evaluation of B minus A results as positive, sort it one way, and if it's negative, sort it the other way. And that's going to turn our coffee consumption history into chronological order. It's going to return us an array that's chronologically ordered. Now with that done, we can map that out. The map also takes the arrow function, and this time from the arrow function we're actually going to return something, and the arrow function itself has some inputs. Now the key or the entry in the array is the UTC time. So that's going to be the first one, UTC time. And then the second one is just going to be an index tracker that I'm going to call coffee index. And that's obviously going to be for the key. Now, as for what we're going to return a div very simply. And that div is going to have a key that's equal to the coffee index. We always do that. And as for what we map out for every coffee in the array, it's just going to be an icon. It's going to have a class name of FA solid, FA-mug-hot. These are still the font awesome icons. And that is self-closing. Now for the minute, that's just going to give us all of the coffees that we've ever had. So right here in this grid, it looks like we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 43 entries. So that you can see we have 21 and a half every day. So, you know, we're having half of these coffees every single day. So you can see why that's some insane statistics. Obviously, it's all just fake information for the sake of getting something to show up. But now what I want to do is for each of them, make sure that when we hover, we get some information about each of them. And I'm going to take advantage of the title attribute to do that. And the information we're going to tell the user is going to be calculated where we can write some JavaScript just inside this arrow function before we return the div. So what I'm going to do in here is just say, first, let's actually access the coffee value. And the way that we do that, we're going to say const coffee is equal to, go to our coffee consumption history and access the value at whatever UTC time we're currently on in the array. And that's going to give us access to the values associated with this list of keys. Once we have that, we're going to define a variable called time since consume, and that's going to be equal to the time since consumption utility function, which we'll import. And the value that takes in, it takes a UTC time amount, and if you recall, it returns a formatted string that says 2 days, 2 hours, 6 minutes, and 4 seconds. So that's just going to look pretty nice, time since consumption. After that, we're going to calculate the original caffeine amount of the coffee. So we're going to have original amount, and that's going to be equal to another utility function, which is get the caffeine amount. Make sure we import that. And all we have to do in there is pass in the name of the coffee, and that's going to return the caffeine amount associated with that coffee. And then the last value we're going to have is the remaining amount. And that's going to be equal to calculate the current caffeine level, which historically took all of the entries, but we can actually use it with just one entry. So in here, we're going to invoke it, pass in an object because it receives an object, and we're going to construct the object. So that's just the UTC time, and all we have is the value, which is the coffee. And just like that, that's a singular historical entry for which we can leverage the calculate current caffeine level, you know, given that time and that coffee. So that's going to be the remaining amount of that coffee. So that's pretty cool. And what that's going to allow us to do is construct a string. So here we're going to have a, you know, summary string, and that's equal to the backticks. Now in here, what I'm going to do is have the coffee.name as a first entry. I'm going to give a bar key between all of them, and obviously, if you're not familiar with template literal strings, you just have the curly braces for JavaScript inside the string to, you know, basically plug in JavaScript to your strings, and you throw a $sign in front of them. So here we're going to have another value, and that's going to have the $sign curly braces, and this is going to have the time since consumption or consume. Then we're going to do the same thing, and this one is going to have the original amount as a value, followed by the milligrams, divided by another $sign curly braces, the remaining amount. And so this summary string is going to have the name of the coffee when we consumed it and how much is left out of how much we started with when we first consumed it. And so that's also a milligram amount. And I'm going to remove the spaces between the amounts and the milligram unit. And so that should very tidily basically tell us everything we need to know about each coffee entry. You could also include the cost here if you wanted. Maybe we do that. Maybe we actually just throw it in here. So that should be coffee dot, what's the name? Let's just go back and check. So it's coffee dot cost, just like that. And so now that we have the summary, we can assign it to the title key. So we give the div a title, and that's going to be equal to summary. And now when I go ahead and save that, obviously that doesn't change the page, but if I hover over a coffee, we get all of this information using the title attribute. So we can see we had a black coffee. It's 4 days, 10 hours, 4 minutes, and 41 seconds old, and it cost us $6.11. I might just throw the $sign in front of the coffee cost. So that's going to be a $sign circular braces. So if we try that again, you know, this one was 371 and it's 160 milligrams out of 0 milligrams. So that just means that I've got the original amount and the remaining wrong. So let's just swap these around. So it should be remaining amount divided by the original amount. So let's just confirm that once more. For this coffee right here, flat white, 4 days, 8 hours, 43 minutes, 35 minutes and 53 seconds ago, $5.41, and it's 0 milligrams out of 130 milligrams remaining. And we would expect this entry to be the oldest at 5 days and 8 hours, and this one to be the newest at 4 days and 5 hours. And just like that, we have our neat little history, all of the stats, basically everything anyone could want to know about their coffee consumption history. Now, obviously, at this point, the world is your oyster. If you want to go track some more stats, you're welcome to go calculate them, create your own utility functions, throw them in. This is what we're going to be working with. And with that complete, we can now add our authentication, start tracking some serious data, and publish this project to the internet. Now, one thing I just want to quickly add in is that since this is going to be a publicly available project, we're going to include a little GitHub link in the footer. So that's within the layout. And when we have this string just here, we're going to throw in an extra break after the design library and just say, check out the project on, and then have an anchor tag, and that'll just say GitHub. And then we can have an exclamation at the end. And simply throw in target equals underscore blank as an attribute so that the link opens up in a new page, and an href, which will just be, you know, https://www.github.com/ whatever the link ends up being for this project. I guess in this case it would just be React.JS full course for the minute. But when you deploy it to GitHub, you'll have a link, and that's the link that you would want to use. And it's just good to let people have access to that information. So as I was saying, the first thing we're going to do is start adding the authentication. And for that process, the first step we need to take is to add a login screen where people can actually authenticate their accounts. Now, all of this happens within the authentication component, which itself will be rendered inside of the modal. So what we're going to do in here is first fill out some content. We're going to start off with an h2 tag that says sign up, capitalized up, /login, depending on what state we're in, so we'll add that shortly. And that has a class name equal to sign-up-text. After that, we're going to have a paragraph, and this is just going to say sign into your account, exclamation mark. Then we'll have an input. And this input is going to have a placeholder that just says email. So that's pretty straightforward. We're going to have a second input that has a placeholder of a couple of asterisks, because that's going to have a type of password. And that's going to be an input field where they can enter a password. Then we're going to have a button that just has a paragraph that says submit. After the button, we're going to throw in a horizontal line to separate out the last div that's going to have a class name of register content. And in here, we're going to have a paragraph that says don't. We'll have our special apostrophe. So that's ampersand apos semicolon, don't have an account question mark, and then we're going to throw in a button that has a paragraph that just says sign up, and the second up will be lowercase. So that's an authentication window done, pretty straightforward. We'll obviously have to come and add some states very shortly, but the first thing I want to do is get this modal functioning. Now, the authentication window is going to be rendered from within the modal, and if you recall back to the Pokedex project, the modal is rendered out of context of the page, so it overlays it really nicely. Now, the first step to implementing this modal is to come down to the index.html, and where the root div, or the div with the ID of root, is where our React.JS application gets rendered, we need to create a secondary div that has an ID equal to portal. And this is just because our modal is like a portal overlay of the rest of our application. Once we have that new div, we can come into the modal component, and we need to import React DOM from the React-DOM package. Now, be careful how you spell React DOM, because that will have an effect on how successfully it works. And how this works, if you recall back to the Pokedex, is instead of just returning back the JSX, we need to be slightly smarter with how we do that. And instead of just returning it generically and it will be rendered inside the root div, we call React DOM and we create a portal. And inside here, we're going to actually turn these React fragments into a div. And then we need to provide a secondary argument. So after we've provided all of the HTML, we say document.getElementById, and we say render it whatever we've passed in here inside of the div with the ID of portal. Now this div has a class name of modal container because it contains our entire modal. And in here we have a button. And if you recall, that button is actually self-closing because it doesn't have any text content. It's just the modal underlay. So it has a class name of modal underlay. And then after that, we have a div that has a class name of the modal content. And in here, we just render out the children content, which is whatever is contained within the modal opening and closing tags when we actually go to render it out. Now the children contents is one of our props, so we have to tell the component to expect the props, and it's going to have children. So we have to say, you have children. Congratulations, modal. And we destruct the children out from the props, and then we specify where in the JSX we should render out the content. Now that's not all we get from the props. We also need a handle close modal function that we can assign as an on-click event to the underlay. So here we can just assign that as an on-click. Now this doesn't exist yet, but we will pass it down later. And so when we click the modal underlay, which is the dark screen behind the content that overlays the page, that will exit out of the modal. So that will look very cool in just a second. Now we need to render out this modal wherever we're going to essentially allow the user to click on something that opens up the login state. So obviously we have one in the header where we have the button, and we'll also need to be able to render it out within the form because that's also going to allow the person to open up the authentication state. Now this is all pretty simple. All we have to do is come into the layout. This is where the header is. So this button right here is going to open up the modal. So what we're going to do is render out just above the header. Remember, it doesn't matter where this gets rendered technically because it's actually not rendered in that same context. It's rendered within a different div. But we just now render out the modal, and within the modal component, we have the authentication component. Now, obviously, I had to import both of these. I used the auto imports. And so now the authentication component becomes the child to the modal. And if I go ahead and save that, we see that we now have the login screen come up. That's what we just coded. And once again, looks good in dark mode and light mode. And then if I just come back to the light scheme, soon when we click this background, it will exit out of this modal. And obviously this looks pretty nifty. Now obviously we don't want this showing up all the time. We only want it to show up when they click the necessary buttons. So what we're going to do for that is start off in the layout. And in the layout, we're going to maintain a state. So that's going to be pretty straightforward. We're just going to come up the top right here and say import use state from the React package. So now that we have access to use state, we can define a stateful variable to manage whether or not the modal shows. So we can say const show modal and set show modal. That's our state and our setter function. They're enclosed in the square parentheses, and that's equal to use state. And by default, that state is false, which means that we do not show the modal until it's clicked on. So that allows us to then select this modal, and because it's going to be, using JavaScript to decide whether or not it's rendered, we wrap it inside of the squiggly parentheses, and then the circular parentheses after that. And in front of the circular parentheses, I can use my conditional rendering, and I can say if show modal is true, only then render out the authentication modal. So if this state is false, we'll get no modal. For example, if I now save the page, that modal is gone. However, if to this button that says sign up free, I now assign an on-click event that's an arrow function that says set show modal equal to true. Now when I click this sign up button, which is right there, our modal pops up. And now we have to assign the handle close modal function. So in here we can provide a prop called handle close modal. And that's a prop that gets passed down to the modal component. And that's just going to be an arrow function when executed says set show modal equal to false. So now when we click the backdrop, that's going to close out of the modal. When we sign up free, that provides it. That opens it up. And then once again, when we click out of the back, that closes it. And that just works because this is a function that we defined. It gets passed down as a prop. The modal receives that prop, and then it's assigned to that backdrop button. As much as conceptually it doesn't feel like a button, technically we click on it and it creates an action. So that modal underlay is a button. So that's the first instance. The second instance, we need it. It's to pop up when we try to add an entry, but we're not authenticated. Now currently, if you recall, inside the app, we manage a state here that says is authenticated. And so all we have to do for that is pass it down, is authenticated equals to is authenticated. And now within the coffee form, what we can do is receive that as a prop. We created a prop, we now have to receive it, and we can destructure out is authenticated from the props. And with that done, when we handle the submit form, the user can obviously fill it out and everything, but if they click handle submit form and we say if not is authenticated, so if they're not authenticated, then we can A, return out of this function, but B, we can once again say set show modal equal to true. Now obviously that state doesn't exist in this component, so we need to define it. I'm going to define it up the top. Const show modal and set show modal. That is equal to use state with a false default value. And now we can have a secondary instance of this modal. It's only going to be one or the other. Either the portal exists or it doesn't. But we've just created two mechanisms for creating that modal overlay. So now, basically, we set show modal equal to true. And within here, we need to then, once again, have the squiggly parentheses, the circular parentheses, and then just once again, conditionally render out. We could literally copy across the code that we created in the layout, copy that straight across into the coffee form, and now we just have a second mechanism for creating that modal. ensuring that we import the modal component and the authentication component. Now obviously, in this case, we're using the modal for authentication. The modal component is actually super flexible. So you could use it in different instances. Once again, we've showed 2 different ways that we could render it. We could have it used in 100 different places in our application, each with their own different state, where the modal contains all sorts of different content dependent on what components are rendered within it. So it's a super great thing to know how to do inside of React. But the point is, now is authenticated as true. So when I click add entry, we console out everything as we would expect, because this does not evaluate to true, so we don't hit this code. Instead, we console out stuff. But if I come into my app now and change is authenticated to false, now what the user is going to see, we have an unauthenticated user, they're new to the web page, they could sign up free and enter the sign up form, or they get engrossed into it, they start filling out all of the stuff. They put 4.5, I had it 3 hours and 10 minutes ago. And then when they go to click add entry, because they don't have an account, we can't even save their data. It opens up the modal and prompts them to log in, register, and then we could go ahead and save that. And so this is a really good way to authenticate people, because they're kind of committed. They've filled out the form, they want the information, and so that's going to be absolutely wicked. Now obviously the last thing to this process before we throw Firebase into the mix is to just make sure that within our authentication form, we manage some state. So at the very top, what I'm going to do is import use state from the React package. And now I can define a bunch of states up here. So the first one I'm going to define is called is registration. Registration. Yeah, I think that's correct. And here we're going to say set is registration. And what this one's going to be used for is defining whether or not a user is signing in or signing up. And that's an important distinction, because the way that we handle those authentication functionalities is different. So that's just going to be equal to use state, and by default that's going to be false. So we're going to assume that the standard individual just wants to log in, not actually register. After that, we need a state called email and set email, and that's equal to use state, and that's an empty string. We have another one for the password, const password and set password, and that is equal to use state, also an empty string. And then the last one I like to have is a const authenticating and set authenticating state. And that by default is going to be false. And that's just a state that we're going to set to true when they go to click submit to manage a loading state until they have either authenticated or failed to authenticate. And now with those states defined, we can come to the inputs first. If you recall, the inputs take a value. We need to tie a state to the value of the input. So the first one is going to have a value of email, and that's going to have an onChange event, which is a function that receives the event as an argument, and we set email equal to the e.target.value. And that's all we need to tie this input to our state. I'm going to copy these 2 attributes of the input and just paste them in for the password input, and change the value to password for that one and set password. And that is just going to manage our states. I'm also going to create a function up here that is an asynchronous function called handle authenticate. And for the second, that's just going to do nothing. But now what we can do is assign that to our button. So our button can have an on-click event that's handle authenticate. And then finally, this div down here that says don't have an account, sign up. Essentially this text, and this text, needs to change dependent on what the state of isRegistration is. So what I'm going to do up here is for these text elements, I'm going to wrap them in curly parentheses because this is going to be JavaScript. And I'm going to say isRegistration. If it's true, it's going to say sign up. And if it's false, then it's going to say login. And so just like that, our sign up text defaults to login until I click sign up, which should swap it over. So now this button is going to have an on click that's going to set isRegistration, and it's going to invert whatever the current value of isRegistration is. So if it's true, it'll set it to not true, which is false, and back and forth. So now just by adding that on click event to that button, if I come to the sign up, when I click sign up, we can see we're swapping between a login and registration state. Now obviously this text inside of the paragraph is going to have to change as well. So we're going to swap sign up for the appropriate text. So if it's isRegistration, that means we're currently registering, which means that the opposite needs to say sign in. And that's going to be lowercase. And if it's not, it will say sign up. So now when we make that adjustment, don't have an account, sign up. And now it goes back to sign in if we're in the sign up state. So likewise, this text right here is going to change. So we're going to wrap that in curly parentheses, stringify the whole thing. Since it's within a string, we can actually escape a quotation, and that will be recognized successfully. And now we just add the isRegistration, the question mark. If it's isRegistration, then what we do is we have a string that says already have an account. Because we're on the registration page, we need to give them the option to log in if they already have an account. So if it's isRegistration, we suggest to them already have an account, sign up. Otherwise, if we're logging in, don't have an account, create an account. So if I save that, it says already have an account, sign in, don't have an account, sign up. So you can see how we're making this form slightly more dynamic. Now the last one, actually I think that text, no, we'll change that to say create an account. So we'll do the same thing with this state right here. We'll wrap it in the curly parentheses, then we'll turn it into a string. We'll throw an isRegistration conditional check. If it's isRegistration, then we want to say create an account. If it's not and we're logging in, then we want to say sign into your account. So now we have a super dynamic form. It defaults to the login state, sign into your account. Don't have an account, sign up. And then it goes to the sign up page where it says create an account, already have an account, sign in. And just like that, we have the code ready. Well, a super nice, neat and responsive login window, but we also have the code ready to handle our authentication and actually add Firebase authentication to our project. Now, one last thing I just wanted to add before we go and add Firebase is it's actually to change this variable right here. Whenever I'm managing a state that's like a Boolean value, for example, isRegistration, I like to use the is keyword because it, denotes something being in a state. We're in a registration state. The person is registering. And in this case, instead of just having authenticating, I think that making it is authenticating and set is authenticating just adds a bit of clarity, and it makes it a slightly nicer variable name for our Boolean state. So when we do the if check, if is authenticating is true, as opposed to if authenticating, is authenticating just makes it, is it? Yes, no. Minor change, but a good practice to get into if you're managing these kind of, you've got a state to manage a state of something. Now, to add Firebase to our project, there's a few things we need to do. First, within Caffeine, we're going to create a new file at the top level, and it's going to be called Firebase.js. So in my case, just above the index.html, we now have this Firebase.js file. And the other one we're going to add inside of the source directory is a new folder called auth context. And we're going to go ahead and save that. Well, actually, I'm going to change that. I might just rename it to context. Because within that file, we're now going to create a component called auth context.jsx. Now, essentially in React, context is another React hook. And what you probably noticed is that within all our components, we use a lot of props. We send a lot of data through props. And we also historically have talked about the state hierarchy. So a parent can pass information to a child easily. It's much harder to pass information from a child to a parent or across componentry that's on the same level of the hierarchy. And that's often when we instead decide to use a context. So context just gives context to our entire application. And a term I like to refer to it by is it's just a global state. So it removes the need to pass the state between props. We essentially create a top level overview, a wrapper for our entire application, create some stateful context in there, and then everything within that, whatever component, we don't have to pass it through all the componentry, it can just access it. So it's super convenient for managing an authentication state, which can be used in a lot of different components. We don't have to worry about passing it through props. And while that might sound a bit confusing when you're first introduced to the concept, we will see how it works and it will become very transparent and clear to you. So we just needed to configure those two files for our project. Now with them done, we're going to come over to Google and we're going to type in firebase.google.com. Link is in the description as well. And we're going to click this button up here that says go to the console. Now you might need to create an account. It's typically linked with your Google account. It is in my case. And when we come to this page, it's going to give us the option to select a project. We're going to go ahead and create a project. And we're going to name our project Caffeined. Now after we've done that, we're going to hit continue. When we're talking about Google Analytics, I don't think we need them for our project, so I'm going to disable them, and then I'm going to hit the Create Project button, and Firebase is going to provision us a project. Now, if you've never come across Firebase before, it's what's known as a PaaS, which means Platform as a Service. And there's a number of ways you can go about developing full stack applications. In this course so far, we've only really developed front-end dominant applications that maybe fetch data from an API. But the back-end that sits behind them, there's 101 million ways you can go about creating a back-end service. Firebase is just a back-end service that's already provisioned, that's ready to go. You just need to configure it, and you've got authentication and database that you can just plug into your application instead of having to, configure your own server, do all the code, handle all the code, all of the admin work, figure out how to deploy it. Firebase just does it all for us. So it's a really easy way to get up and running with a full stack application that needs to persist data. It needs to securely handle authentication, and it's totally free until your application is huge. So there's a huge free tier that we're going to take advantage of. And if by chance you ever ran out of that free tier, you'd probably be making bank on your application anyway, so it wouldn't even be an issue. So it's a brilliant service. We are now ready to go. We're going to hit continue, and it's going to take us to the dashboard for our project. Now, once inside the dashboard, what I'm going to do is actually just zoom out of the page a little bit. The first thing we're going to do, as it says right here, get started by adding Firebase to your app. And it gives you a couple of options. So you could do Flutter, Unity, Web, Android, Apple. We're going to go with a web application. And in here, it's going to ask you to register an app. We're just going to give the app name Caffeined to match the name of our project. And we're not going to select Firebase hosting. And with that done, we're going to click this register app button. Once that's done, we're going to have to add Firebase to our project. And the way we do that is by installing Firebase to our app. So we're going to come back over to our code base and we're going to kill our terminal instance with the Control and C keys. and we're going to type npm install Firebase. Hit enter on that, and that's going to install Firebase to our project so that we can go ahead and configure everything. Now, before we go back to the web page, because there's some more information and instructions that we have to follow there, the other thing we're going to do within our Caffeine app is add a .env file. Now, if you're not familiar with .env files, it's an environment variable, and typically these files are used for storing secret keys, essentially the passwords for the internet, which if you're using API keys are equivalent to passwords. Now, our Firebase application is going to give us some secret keys that we cannot show to anyone, otherwise they can basically hack, take advantage of our cloud Firebase database and authentication and all that kind of stuff. So these need to be kept secret. And that's especially relevant when you go to push this code to the internet. We need to keep it private and make sure that our .env file does not get committed to our GitHub code, which is important if you want to have a public repo that you could show to an employer. So the other thing we're going to have to do with this file created is come into the .gitignore, and inside of here, what we'll do is we'll add the .env file to the bottom of this .gitignore, and that just tells Git to ignore this file, don't commit it to our repos, keep it secret on our local device. And now that we have that file successfully being ignored, what we're going to do is start adding some keys to it. So if you come back over to your Firebase project, you're going to have this code down here. What we're going to do is copy everything in this block of code, including all of the secret keys. So I'm going to go ahead and do that and show you what it looks like once it's done. So I've now gone ahead and done that, and I've pasted it into the firebase.javascript file, and I've blanked out all my keys so that you can see what I'm doing without me exposing my keys on the internet on YouTube. And essentially it's 17 lines of code. We're going to add some more to this file shortly. And what we're going to do is, instead of having our keys available here in this file, we're instead going to read them from that .env file. Now, when it comes to reading API keys from a .env file, when we have a Vite project, what we do is we say import .meta.env, and then we have the name of the key. So the first key is dot, and then we have a Vite, this is all capitalized, underscore Firebase underscore API key. And now what I'm going to go ahead and do is copy this line and just repeat it for every single entry in this Firebase config. And that's going to read an environment variable. Currently it's reading the same environment variable. And now what I'm going to do is swap out the last key for whatever the key is that we're assigning it to here. So this one is going to be auth domain. The one under that is going to be project ID. Under that, we're going to have storage bucket. Under that, we're going to have messaging sender ID, and finally app ID. Now, it's really important these are spelled correctly. And now what I'm going to do is copy each of these key names, so just the last one here. And if you want to do a multi-select like this, you can once again check out the VS Code Shortcuts website. It tells you how to do that, but in my case, it's either the Alt or Option key. Hold that down while you multi-select. And I'm just going to copy all of these keys and paste them into our .env file. And it's important that the names right here match what we typed in on the other page. And then we very simply add an equals sign to the end of all of them. And then the very last thing we have to do is copy all of those keys across. So whatever the value was, remove the quotations from the end of it and just paste the value in its appropriate spot. So now I've gone ahead and done that. You can kind of see a little bit of each of them just in here. Should look something like that. They each entered onto a new line. There's no commas, there's nothing like that. Just the exact key and then onto a new line. And once we've added all of these keys, we can now save that file and close it. And these keys will, when we restart our project, be read in, and our Firebase app will be configured. Now that doesn't quite mean we're finished with Firebase just yet. The other thing we're going to do from within here is import some other stuff. So Firebase is the name of the PaaS, or Platform as a Service. We specifically want access to the database and authentication services. So Firebase authentication, and the database we're going to be using is a NoSQL database, which is kind of just a glorified JSON object called Firestore. And so in here what we're going to do is just add an import line, and we're going to import getAuth from Firebase/auth, and we're also going to import getFirestore from Firebase/Firestore. And once again, it's important that that spelling is correct. And now that we've imported both of them, basically this bottom line here, once we've created our config, it reads in the config, it initializes Firebase in our project, and we can now export a constant variable called auth, and that's equal to getAuth. We call getAuth, and we pass in our app, and we also have a second line that says export const database, or DB, and that's equal to get Firestore, and we just pass in our app again. Now what that's done is we're exporting our auth, and we're exporting our database so that they can be accessed anywhere inside of our project. Now if you come back to our little config screen right here and scroll down to the bottom, there'll be a button that you can click that says continue to console. That's where we want to go from this page, since we've copied all of this config information across. And now that I've clicked that button, we can see that we have one app up and running. That's all we need, and we can now choose to add some products to our app. So within our code, we've obviously added Firestore, the database, and the authentication. We're going to do that from within the dashboard as well. So we're going to start off clicking in authentication, and just here we're going to say get started, and that's going to bring us to a page where we can select all of our authentication providers. We're just going to go for plain old email and password. We're going to enable email and password. I'm not going to worry about the email link. And then once that's created, I'm just going to click save. That's going to add authentication. Now we have email and password working. And then we're going to come back to the project overview. And the second thing we're going to add is the database. So here's Cloud Firestore. We'll just go ahead and click on that. And then from within here, we can now click create database. We'll click on that. It's going to ask us to do some stuff. First, we have to set the name and location. It doesn't really make a difference. You can obviously pick one that's going to be closest to your user base, but I find that United States works well in New Zealand, for example. We're going to click next, which is just behind my head. And then we're going to click start in production mode. Now you can technically start in test mode, however you basically run out of days. It's limited for 30 days, then you have to reconfigure this anyway. So we're just going to go ahead and start in production mode, and then once again click create, which is behind my head. Now that's going to go ahead and provision our Cloud Firestore, set up our database for us so that we are all good to go. So now that we have our database provisioned for us, essentially how it works is you've got collections and you've got documents. So a collection is just the key name, and the document is the value that's associated, and that's just a big object. And you can have nested collections within documents and all this kind of stuff. But what we're going to do just to demonstrate is we're going to add a collection just here. It's going to be called users. We give it an ID. We click next, which is behind my head. And then it's going to ask to add some demo information. Here I'm just going to give this document ID the title demo, and I'm going to remove this entry, and I'm just going to save that, which is once again behind my head. Now what that's going to do is create the first entry in our database, where here we have the users field, and then we have a whole lot of documents just in here, and this is all of the JSON. Now how this is going to work, or basically how we configure authentication for users using Firebase, is we have a collection of users. when we use Firebase, every user gets a unique ID. And so what we do is we save all of the user's information, all their coffee entries, under a document titled by their unique ID. And so then when we go and fetch the data, we just look up their unique ID and we have access to all of their data. And the way that we make it extra secure is we come over to the rules tab just here, and we're going to add some rules to finalize the security of our authentication and database system. So just here, these are the rules that we currently have, and essentially the important lines are, basically, we have a line here that says match databases/database/documents, and then apply these rules to them. And so what's happening right here is it's saying allow read and write if, and then a condition, and currently the condition is false. So if you tried to do any kind of database reading or writing at the moment, it would be denied. But the condition we need for our rules that we're going to add in here in place of the false is we're just going to access the request. So when a user makes basically a read or write action to save to the database from our caffeined application, we're going to run that through their user ID. And so we can access request.authentication, and we can say if request.authentication is not equal to null, which means that we have a legitimately authenticated user through Firebase, and then we're going to use the double ampersand for the AND condition, and we're going to say request.auth.uid. So we're going to get the user ID from the authentication, basically, of the request to see who the user is, and we're going to match it to the user ID. Now the user ID is a dynamic parameter, and the way that we get access to it is via the string parameters. So in here what we're going to do is where it says basically any document at the moment, we're just going to match users slash and then have the curly parentheses, and in here we're going to say user ID. And so whatever the user ID is that they're trying to write to, which should be their user ID, we're going to ensure it matches the user ID signature on their request. Now underneath that, what I'm going to do is just add a line in for basically what we had before, and just say allow read write if false, and have that original line in. And the reason I'm going to do that is just because I don't want anyone reading and writing to any other document except for the one that we've allowed it for, which is when they're writing to their own user condition. And I'm also just going to throw that match condition underneath the first. So the moral of the story is that when we're trying to write to a user's document or their basically database that's specific to their user ID, they need to be authenticated, and the signature of their authentication has to match their user ID. So now we can go ahead and publish these changes. And with that done, we have configured our Cloud Firestore. So all of the stuff on the internet is done. Firebase is added to our application. How do we actually really finish the configuration? Well, all of that happens within this auth context file. Now, as I said earlier, the context basically wraps our entire application and works as a global state. So we define some states here, and they can be accessed super easily anywhere in our application, no matter the hierarchy. Now you might ask, if that's the case, why don't we just use the context for all state? And that's because it becomes less efficient. So you want to really pick and choose where you have your global states. And in this case, a user authentication state is globally necessary. So that's the one we're going to use it for. Now at the top of this file, the first thing we need to do is import some hooks. And specifically the hooks that we're going to need is use state, use effect, and use context. And they're going to come from the React package. Now underneath there, the next thing we can do is we can export a default function called, and actually it's not a default function in this case, it's just export a function, and the function is called auth provider, because it's our we're basically provisioning our authentication. And this receives some props, and then when we open that function up, we can destructure out the children from the props, because this is obviously a wrapper for our entire application. So you can think of it as a set of opening and closing tags like we've seen historically that has contents within them. Now at the very bottom, what we return from this function is still JSX, so still a React functional component, except it's actually a special, basically secondary component that we have to export, or better said, it's actually a context. So the way we initialize the context is we come up above where we've defined the functional component, and we just say auth context, const auth context is equal to create context. Now we need to make sure that also gets imported from the React.JS package just up the top. So we create a context, and then what we return from the auth provider component is the auth context dot provider opening tag and corresponding closing tags, and then from within here we render out the children contents. Now as for what gets passed down as a global state, here I'm just going to define a variable called value, and that's going to be an object. And what I can do is pass a prop down to this general global state, this context, that's just value is equal to value, and anything that is contained within this dictionary becomes part of our global state. For example, if I wanted to have a stateful variable called user, and set user is equal to use state, and that's by default null, then what I can do is I can in here just pass in the user, and now that is going to be added to our global state that we could access from anywhere. Now in addition to this code that we have so far, there's one extra thing I'm going to add that's going to make this context incredibly easy to read in any component from within our application. And we're basically going to turn it into a React hook, a custom React hook. And so I'm going to export a function, this is above our component, called useAuth, and that's a lowercase useAuth. And we know it's a hook because it's got the use in front of it. And all we're going to do in here is return the use context hook, and in here we're going to pass in our auth context. And so what that's going to do is that's just going to create a custom hook from which we can destructure out any of these values. Now that's a lot of information to take in. We'll understand how it works as we continue to build it out and add it to our application. So thus far we've only defined a state to manage the user. We're going to need a secondary state called const global data and set global data, and that's also going to be equal to use state and have a default value of null. Because if a user is unauthenticated, we don't have a global state. And then the last one we're going to define is one called loading and set loading, or actually even better, let's go with is loading and set is loading. And that's going to be equal to use state by default false. And essentially, we can add these three stateful variables to our global state by just throwing them into this data right here. So we can have global data. We're also going to need set global data. We're going to need the setter function, and we're also going to need is loading. And so now all of these stateful values are accessible from within anywhere in our application. Now the other thing we're going to do in here is add in some authentication handlers. Now the way that these work, when we installed the Firebase package, we also got access to a whole lot of handy dandy stuff to effortlessly manage authentication and database actions. For example, we could create a function in here called sign up, and that receives an email and a password as an argument. And to get Firebase to authenticate or sign up a user, all we have to do from this function, we're going to return out what's known as create user with email and password. And here we can see the auto import come up from the Firebase package. So I'm going to slam enter on that. And this right here is now imported from the Firebase /auth package. Create user with email and password. That's exactly what we're looking for. And all we do in here is we pass in auth, which we also have to import from our Firebase package. If you recall, we exported auth. So now we import auth from Firebase, we pass that in just there, and then we follow that up with an email and a password. Now that's an asynchronous function, and we'll see how we handle it shortly, but currently we've just created a function for signing up. Likewise, we're going to have a function for logging in that also takes an email and a password, and we return sign in with email and password. So we're going to also have to import sign in with email and password. And once again, we pass in the auth, which is now already imported, the email and the password, and we just return that from login. Now I'm going to move this value line down the very bottom because it needs to be the last thing above what we return from this function. And there's a whole lot of functions you could add. Another one is going to be called sign out, or actually let's call it log out. And that actually doesn't need any arguments, but all we return is sign out from Firebase auth, ensuring that we add sign out. Just make sure we import that. And that just takes the auth because it doesn't need any arguments. In this case, when a user signs out, we also want to set the user state to null and set user or set global data to null as well, because we shouldn't keep a person's data if we don't currently have them signed in. If they're wanting to log out, we need to clear all of their states. Now there's a load of these functions. And with logout done, there's one more I'm going to add. You could figure out how to incorporate this, but it's just a function called reset password. Sometimes that can be handy, and that just takes the email, and from within it we return send password reset email, which needs to once again be imported from Firebase auth. And all we do is we pass in auth and email. So you can see how easy it is to basically handle authentication using Firebase auth and add it to our project. And now that we've created these functions, all we do is we throw them into our value right here. So we're going to throw in sign up, we're going to throw in login, and also log out. I'm not going to worry about the reset password. If you want to figure out how you could add that in, you're more than welcome to. But now these functions have been added to our global state, and that allows us to use them in the authentication component. And we'll see how that works shortly. Now we're not quite done with this file just yet. There's a few other things we have to add. You might notice up here we have a use effect that needs to be used. So the question becomes, how do we use this use effect? Well, just above the value, because once again the value is the last thing we're going to pass down, we're going to throw in our use effect. Now I know I've said historically that the use effect is the last thing above all of this stuff just here, what you return, the JSX, and technically I think we should actually stick to that and just put the value above it. But the use effect in this case is very special and super important. Now the first thing, if you recall, the use effect takes two arguments. One is a callback function, the logic to be executed when the event that we're looking for is triggered. And the second is a dependency array that contains, or potentially doesn't contain anything that determines when this logic gets run. So in this case, we're going to leave the dependency array to be empty because we want this logic to basically execute when the page loads for the first time. Now, what happens in here is we define an event listener that we're going to attach to our application that listens for authentication events. And the way that we do that is we call a function called onAuthStateChanged. That's once again available from within our Firebase package, onAuthStateChanged. So we have to ensure that we import that. And this very special function takes some arguments. So the first argument is the auth. it needs to associate it with our auth. And the second is an arrow function that's actually asynchronous. And what we're going to do is assign this to a variable called unsubscribe is equal to this particular function. And from within the use effect, we're going to return unsubscribe. And this is what's known as a cleanup. Essentially, it just means that we don't have any data leakages or anything random in our use effects. This is typically fairly uncommon, but in this case, we're assigning a special event listener, so we need to make sure that if we close our application that we then consequently remove it, clean it up, so to speak. Now, this on-auth state change function listens for when a user signs in, for when they sign out, when they register, and essentially we're going to leverage it for a few things. Now, it receives an argument, which is the user. It takes a user as an argument. And we've actually already defined the user up here. So what I'm going to do is change the state to our global user to keep it consistent with our data. So this is going to be set global user. And I'm going to have to make sure that we consequently update that in here. So this is going to be global user inside of our value that gets passed down. And that's because when our on-auth state change happens, let's say a user logs in for the first time, it's going to give us that user. It's going to give us all of the information about that user, not all of the data necessarily, but all the information like the user ID that we need to then fetch all the data. And so what happens in here is we say, if there's no user, empty the user state and return from this listener, I guess, this authentication listener. If there is a user, then check if the user has data in the database, and if they do, then fetch said data and update the global state. So that's relatively straightforward. Essentially what's going to happen is, let's say user signs out. That means that this user right here will be blank because there's no user. Then all we do is we empty the states and return out of the function. And if they do sign in or they register, let's say they register, for example, then we'll get access to that new user. And then we can go to the database, say, does this person have a record in our database? If they've just registered, they won't. That's totally cool. They'll create one when they go into our application. We can update our global state to match that new user. And if they do have a record, we then fetch all of that information. And Firebase authentication is super clever. So let's say a user is logged in, they close the web page and then they revisit the web page. It automatically runs this authentication check because it's inside of this user effect when the page loads. And if we find that they've been previously logged in, we update that login state and we go and fetch the data automatically, and then everything just works perfectly. So to come in here and basically make all of this work, we're just going to say if not user, the first thing we're going to do is return out of here. We don't need anything. If we do in fact have a user, then we need to run some of these checks. And I like to run this stuff inside of a try catch. We catch the error. And finally block. Now if we catch an error, we always want to console.log the error.message. And for the try, the first thing we want to do is say set is loading equal to true, because we're loading a whole lot of information. And then at the end of this process, we want to set is loading equal to false. Now as for what we do underneath the loading state, this is where we can now go and fetch all of the data. This is going to be the first introduction to fetching data from the database. And essentially how it works, the first thing we do, if you recall coming over to our Firebase database, we have collections right here, where a collection contains a bunch of documents, where a document is just a key and a value that's an object. So we have a collection, a user's collection, and we need to create that as a reference to let Firebase know which data we're trying to access. So the first thing we do in here is we define a variable called doc ref, and that's equal to the doc method, which we have to import from the Firebase / Firestore package. So now that we've got doc, what we can do is pass in our database, give it access to our database, which needs to be imported from /Firebase. If you recall, that's the second thing we define down here is our database. So we say fetch from within our database, and then what we do is we provide the collection, which is the user's collection, and we check for the user and we access the unique ID. So that's going to basically say, here's the document. Let's see if we can get something from that. Underneath that, what we're going to do is say const doc snap. We're going to take a snapshot of the current document, and that's a method that we need to await. And then what we're going to do is say get the doc. Now this is also a Firebase method. We have to call get doc. And then once we've gotten the doc, we can now pass in the doc ref. So we say get this doc, and we pass in the reference to the doc, and then we take a snapshot of that document. So I'm just going to make some notes so that if you want to look back at the code, this is here. First, we create a reference for the, if I can spell that correctly, reference for the document, which is just a labeled JSON object. And then we get the doc, and then we snapshot it to see if there's anything there. So that's what this first process does. Now underneath here, what I'm going to do is define a variable called Firebase data, and I'm just going to initialize that as an empty object. Because if we don't get any information back, then we're just going to use an empty object as our basically data instead. And underneath that, I'm going to say, okay, we've initialized some Firebase data to an empty object, but if the snapshot that we fetched, the doc snap, and we call an exists method, if it exists, then in here we can say console.log found user data, which is pretty cool. So we found some user data, and we can overwrite the empty data state inside of Firebase data, and we can now say it's equal to doc snap.data and call the data method, and that's going to get all of the data and assign it to our variable, basically overwrite it from this empty state. So that's pretty nifty. And then at the end of this whole process, what we can do underneath Firebase data is we can say set global data equal to Firebase data, and Bob's your uncle. We've essentially created a function or an authentication listener that when an authentication action happens, for example, a page loads and we run some saved authentication token to see if there's an existing user or when they register, we basically check the database, see if they have any data associated with their unique ID, and then add it to our global state, which can be accessed from anywhere inside of our page. And so if we go ahead and save this, that is the end of our auth context for the minute. Now the last thing we need to do is actually render this somewhere within our application, and the place that we're going to do that is inside the main.jsx. Right here, I said that the context is a wrapper for our entire application, and so we are literally going to render out auth provider is the name of the component, and we have to make sure we import that from context/auth context, and we're going to wrap our application or our app component inside of the auth provider. And now if I go ahead and save that, we are finally ready to boot up our project and see if everything we've done works. So we can go ahead and open that up on this page right here. Let's reload that, and lo and behold, everything works. Praise be to whatever God you believe in, or potentially no God, your brilliant coding skills. That has now worked. If something in that process went wrong, we would get errors for millennia. Now that we have this global state working, our application is wrapped. What we could actually do to really just check that it's working is just here we could say found user data. If we run into this not user, we could throw in a little condition up here that just says console.log no active user. I like throwing these little console logs because they make it clear what's actually going on. And just in here we could say found user data, so that actually works. So if we save that and now refresh the page, we can see that we have no active user, but that's actually running. But now we have access to all of those useful functions inside of our entire application. So we can come across to our components and our authentication component. And now what we can do is when we have handle authenticate, we can come in here and we can say, first, let's add a guard clause and say if not email or not email dot includes the little @ symbol or not password or password dot length is less than 8. I can't remember if it's, I think it's 6 actually. So then we're just going to return in here. And this is a guard clause where we basically say if they're authenticating, we're going to need a password and an email. So if we don't have them currently entering an email or a password, or the email doesn't include the @ or a password is less than 6, then we don't want to bother with that. We don't want to run all of our Firebase stuff. So we're going to block that authentication. That's the guard clause. If we get past that, then we can say if is registration. Then in here we can register a user, and then we can have an else condition that says log in a user. So that's pretty handy. And now, because we have our amazing hook, what we can do is underneath all of our states just here, we can say const sign in. What were they called? Let's come back into auth context. If we come back into our context, we can see exactly what, so it's sign up, log in, and that's pretty much all we need. Sign up and log in. So here we have sign up and login, and we can destructure out these two things from our global state, which is just that value object, by calling the useAuth hook, ensuring that we import that hook, and now we have access to them. And that's why that hook that we returned is so useful, because it just immediately gives us access to whatever was contained within the value, which is the global state, which for the minute is the sign up and login actions. Now what we can do is inside here, if we got past these two states, we can say, well actually let's throw these inside of a try catch block, because I just love my try catch blocks. Good for the error handling. We make sure we receive the error, and inside here we console.log the error.message, and then after that we can have the finally, where we just set is authenticating equal to false. At the top we're going to set is authenticating equal to true. So while we're doing any authentication actions, we maintain a state that says that's currently happening. And then what we can do is throw this if else inside the try section, and for is registration, we can say that means the user needs to register an account, so that's sign up. We can pass in the email and password. We need to await the syntax, and then down here where we log in, we can just await the login function, pass in the email and password, and that will do the exact same thing. And just like that, we have handled the authentication for the user. It's so simple. Now, the one other time I want to return out of this function and not run either the Firebase signup or login is if we're currently authenticating. So we're just going to throw is authenticating into this guard clause. So if we're currently running an authentication action, we don't want to do it again, duplicate it, double it up. That's just going to be messy. So now with that all done, what we're going to do is come down here, and where we have this handle authenticate button and the submit text, I'm going to wrap that inside of squiggly parentheses, turn it into a string, wrap it inside of the quotation marks, the single quotation, and I'm going to say is authenticating. If it is, then we actually want a different string that just says authenticating. Otherwise, we're not currently doing anything. And I'm going to do the triple dot just there so that people know there's a loading state. There's some acknowledgement that they've clicked the submit button. And then if nothing's happening, we submit it. And so now I can save that, come back to our application. And the other thing I'm going to do is just come to our context right here. And I'm just going to add a console.log at the very top. Now this is one you'll need to remove before you deploy your application. But I just want a console.log current user and then throw the user on the end. And that's going to make it very apparent as to whether or not we actually have a user. So with that done, I should be able to now click sign up free. We have our little sign up sheet. I'm going to say testemail@gmail.com. We've got the little @ keyword, so that should be fine. And the password is just going to have to be 8 digits long, I think. So let me just do this again. I think it was greater than 6. And now I'm going to click submit. And I would expect this to fail because there is actually, we're logging in. There's no account with this information. So that says authenticating, and then we get an error that says invalid auth. That's absolutely right. You could very easily receive that error, set an error state, and show that as an error message. And that's something I challenge you to do. You could throw in a little error bubble right here and just let the user know that that was an invalid authentication. But now if I swap to a sign-up sheet, I would actually expect this to work. So now we submit, we're authenticating, that state works perfectly. And now we actually have access to a current user. And even cooler, if we come back to our Firebase application, come across to authentication, that little tab on the side, we should see that that user now exists. When it was created, a user ID, all that good information, and that is absolutely wicked. Now, even cooler than that, I can go ahead and refresh this page, and we can see that it automatically loads in the current user. Every time we get a current user, and we don't have to re-log in. Now that means a few things. The first thing that we need to account for is if we come back to our authentication sheet, at the end of is authenticating, if we successfully authenticate, we need to handle the closing of the modal, if that makes sense. Because it's no good just keeping that modal over once we've already authenticated a user. And the way that I want to handle this is wherever we render out authentication, which is right here, we have this handle close modal function. I also want to pass it down to authentication as a prop. So that's going to be super important. If I just throw it in there, that should be fine. For some reason, let's just write it out again. Handle close modal, that is equal to an arrow function that just says set show modal equal to false. Now that's just a prop. I'm going to copy this prop right here and paste it into our other instance, which is inside of the layout component. So just to be clear, in the two places we render out authentication, which is within the coffee form and within the layout component, I've added a handle close modal prop to the authentication component where we render it out. And now within the authentication component itself, right here, I can receive that prop. I can tell this component it receives that, and I can destructure it out from the props. And now when we successfully authenticate, if the action is successful, then we want to handle the closing of the modal. So that is just going to shut that modal when we completely log in. Now the other thing I want to do is inside of the layout, where we have the header, we don't want to have this button that says sign up if the user is already logged in. So what we're going to do is wrap it inside of these squiggly braces because we're going to run some JavaScript on it, and this is within the layout, within the header. Once it's inside the squiggly parentheses, we're going to then wrap it inside of the circular parentheses. That's just a syntax thing so that I can have the component on its own line. And up the top here, I'm going to check if the global user exists. Now that's obviously something that we need to access from the context. How do we do that? We very simply destructure out the global user from the useAuth hook, which needs to be imported, and then we invoke the hook. So here we import the useAuth hook, we destructure out the global user, and now we can see if the global user exists. And if it does, we actually want to render out a different button. So I'm going to copy this original button. I'm going to once again also wrap this version inside of the circular parentheses so that I can enter it onto a new line. And this button is going to be different. This is just going to say log out. So we're going to remove the icon, and in here we're just going to have a button that if they exist as a user, so if global user is true, we have a user, then we give them a button that says log out. If not, we allow them to sign in. Now obviously the on-click just here is going to be different. All we have to do is pass in that logout function, which is accessible from within our global state. So we can literally just destructure logout from our global state. And now, when I refresh the page, I would expect that to be different. And what's happening here, I realized there was one error that I made. Right here, when we get the user, the very first thing we need to do is actually say set global user equal to the user. So I forgot to update the global state to match whatever the Firebase authentication handler actually receives. So now we can see that because we are actually setting that state, I refreshed the page, that authentication handler ran. We checked if there was data, there was no data, so we returned out of the function, but we did actually update the global user, and now we have the logout button. And if I click the logout button, we would expect the auth handler to handle everything and allow us to sign in again. Now it looks like when I click that, we get an issue that says set user does not exist. And that is simply because inside of the auth context where I defined the logout, set user should now be set global user. So if I refresh the page, I can now click logout, and then we have no active user. So the current user is null, there's no active user. And then this time I should be able to sign up free and actually just log in instead of creating an account. So it's testemail@gmail.com. And I think that was the password. I can submit that, we authenticate, and then we are logged in, and then that user state is saved. And with that done, that's our authentication managed. We are now almost ready to persist all of the data and then deploy the application, which is going to be so absolutely cool. So that is all working well and good. There are actually two small adjustments that I've decided we are going to make. One is to the authentication form. I have in fact decided that having an error state is pretty essential, and I'm going to show you how it's done. So in my case, what I would do is underneath the const is authenticating, inside of our authentication form, we're going to add a state that's very simply called const error, and set error is equal to use state, and that's going to be null by default. Now all we do is when we receive an error, you know, we saw when we tried to log in with a non-existent account, we logged that message. We're just going to set error equal to error.message. And then the only thing we want to change is whenever we run this function and we set is authenticating as true, we want to reset the error to null. That way the error is not going to be there consistently. Every time we try again, we clear the error state in case we happen to be successful. And now that we have this error associated with a state, because it's interactive, and the screen needs to change when the error exists, all we're going to do is underneath this paragraph right here, we're going to have some conditional rendering. So we're going to use the curly parentheses, And we're just going to say if there is an error, then have the circular parentheses, render out a paragraph that has the X key, the X emoji, and inside of some more circular braces, we're just going to render out the error that we have. And so now if I come back to our app and let's say I log out and then I go to the sign up and I just do some random stuff at gmail.com and let's just have some silly password. Now we try to authenticate and we get this little error state. So here we see that we have an invalid credential and we've got the little big X indicating that we have an error. And then if I once again try to log in properly, just like that, and now submit it, the error state goes away, we authenticate and we successfully log in and the modal closes. And so that's how we can add an error state to our login form. And the one other thing I wanted to do is just where we created those handle close modal functions, which were wherever we were rendering out the modal right here. So here we have this handle close modal function twice. And for me, that's duplicate code. So we're just going to clean it up a little bit by literally defining a function called handle close modal. And it's just going to be the handler function, and all it's going to do is set the value to false. And now, instead of writing out this function twice, we can just pass it down as a reference twice. And that's just going to look much cleaner. And then we can copy this function and we can go to the second place we render out this handle close modal stuff. And in here, we can also define the function and update these so that we're not writing this code out twice. We're not duplicating any code, and that's just going to be way cleaner. And so that was within the coffee form, and it should work exactly the same. It's just a little bit tidier. So now we have all of this information. We've got authentication working, which means that we can now start writing to our database and also reading from our database. Now what I'm going to do is come into the app. And the reason I'm coming to the app is because this is where we render out our components that rely on the global user data. So the first thing I'm going to do is, instead of having, I'm going to keep this isAuthenticated variable, but I'm going to destructure out the global user and the global data from our context, which is the useAuth hook. And then I'm going to invoke that hook and ensure that we import the hook from auth context. And now what we can do is we can just have this isAuthenticated state associated with our global user. So if there is a global user, then we're authenticated, and if there isn't, then we're not authenticated. So now what's going to happen is we're going to render out the stats and the history because we do in fact have a global user. However, if we're authenticating content, we actually want to make sure that not only do we have a user, but that we actually have data. And what that means is that we need to have some basically some records of data entries. And so what we can do in here is we can define a variable const is data, and that can be equal to, and what we can do is we can say global data. So global data has to exist, because if you recall, inside of our auth context, the default state is null. And then what we also want to do is use the AND condition, and we want to make sure that there's actually some entries. And the way that we can do that is we can use the object.keys on the global data, and I'm going to pass in a backup just here of an empty object. So if global data is null, then we're going to default to an empty object, because this object.keys takes an object as an entry and returns a list of the keys. And what we can do is we can access the length. And then what this is going to do is it's going to say, if the length is 0, that's a falsy value. And so what that means is that now we have this conditional statement that says, okay, there's only data to display if we have global data. So global data actually has to exist. and the length of the entries is greater than 0. If we have 0 entries, or we just don't have any data in the first place, then we don't have any data. And so now what I'm going to do is I actually only want to show this authenticated content if not only are we authenticated, but we also have data. So what I'm going to do is throw this is authenticated inside of the circular parentheses and just add a second condition to it. So if we're authenticated and there's data, then show the authenticated content. So now when I go ahead and save that, we can see that our authenticated content goes away. For some reason we're getting a little 0 here. Let's see where that's coming from. But the moral of the story is that because we don't have any data, nothing is displaying. So just to summarize what just happened there, now we only show the authenticated content, which is the stats in the history, if we have a user and we have data. And what that means is that we need actually to have some global data, and there has to be more than 0 entries inside the global data. And currently this Boolean check right here, when it's evaluating to 0, is not working effectively as a Boolean check. So what we can do is we can force it to be a Boolean value by throwing a double exclamation in front of it. And what that does is it just type converts anything that could be truthy or falsy to a Boolean value. And so now we have no data, and so that works perfectly. But if we did have global data, and we can demonstrate what it would look like by defining a variable here called global data and setting that equal to coffee consumption history, now we do show all of the entries because we do actually have data and we are authenticated. If I were to then log out, even though we have the data, we don't show any entries. And once again, we can add an entry. It's going to force us to log in. I can go testemail@gmail.com, type in the password, submit that. I got the password wrong. No, I didn't. There's no L in Gmail. So now we log in. We have all the data, so that all displays. Now, the one other thing I want to do is define a third variable that's called const is loading data, and that's just going to be equal to is loading. So what we're going to do is just throw in is loading in here, and obviously once again access the global data and not use the fake data. And now I actually don't think we need is loading data there. We can just use is loading, and I'm going to throw in some more conditional logic in here that just says is loading, and we're going to have a little paragraph that just says loading data ... And I think what I might also just do is tie that to is authenticated as well. So we're going to have a double conditional. If we're authenticated and we're loading the data, then we'll show that. If we're not authenticated, but for some reason we're loading information, then we're not going to show that up. So now when I refresh the page, everything works. We load data and we don't find any data. So that's super cool. So with all those loading states, those authentication states, and obviously hiding our data displays if we don't have any data, we can actually look at how we can legitimately persist this information. And so all this magic happens within our coffee form. So now we're inside of our coffee form.jsx file. Let's take a second to understand exactly how this data persistence is going to work. Now, we're managing some global data, some global context inside of our application, and we also need to persist everything to Firebase. And so the way that I like to manage all of this is wherever I am saving to my database, I have to make sure that I also make the exact same adjustments to my global context so that everything is always synchronized. And then what we do is when we reload the page, we load our page on a different user device, we log in somewhere else, we re-authenticate. That on-auth state change event that we defined earlier where we fetch the data will once again synchronize everything, and we'll load in the persisted data. So in here, the way that this handle submit form is going to do, the first thing we're going to do is define a guard clause that only submits the form if it is completed. If that's true, then we're going to create a new state, or a new basically data object. And then finally what we're going to do is update the global state and persist the data in the Firebase Firestore. Now the reason I always create a new data object is obviously because state is immutable. We can't modify the original state, so I just like to completely overwrite it, take the current version, modify it in a new entity, and then overwrite the original version. So to start off in here, we're going to define a guard clause that just ensures that the form is completed successfully. And so for that, we're going to say if there's no selected coffee, then we're just going to return out of this function, because you know, the hour can be 0, the minutes can be 0, the coffee cost could be 0, as much as that's not ideal. But the main thing is that the selected coffee has to be chosen. So now that we have that information, what we're going to do is create a new data object. So we're going to say new const new global data is equal to an empty object. Now what we're going to do is spread out the existing global data inside of this object. And that is just going to create a duplicate of our existing global data. So what we're going to have to do is obviously say const destructure out the global data using the useAuth hook, which once again needs to be imported into our page. And now that we have access to the global data, we can then spread the global data and basically create a duplicate called new global data that we can modify, manipulate, and make changes to. Now what I'm going to do in here is wrap global data inside of some circular parentheses and just provide a backup of an empty object in case global data happens to be in a null state. So that's just some extra security. So now that we have this new object, this new database that we can write to temporarily within the context of this function, we need to define a key. So we're going to say const timestamp is equal to, and now what we need to do is go ahead and create a timestamp for this entry. So what we're going to do is define the now time, a variable called now time, and that is going to be equal to the date.now object, and that's going to give us a UTC amount. Now obviously we have the hours and minutes that they have entered, and so we're going to create a second variable called time to subtract, and that's going to be equal to the hours, set hour, times by 60 times 60 times 1,000 plus the min times by 60 times 1,000, and that's going to convert both of them to millisecond amounts, and then we can have a final variable that's the timestamp, and that's equal to the now time from which we subtract the time to subtract, and that's going to be the timestamp of when the person consumed this coffee. So now we have the timestamp. All we have to do is write the coffee and the cost. So that's pretty straightforward. So we say to new global data at the timestamp, and we set that equal to an object where if we look at what our data entries look like, it just has a name and a cost. So I'm going to copy that and actually just paste it in here. So we have a name parameter. No, I'm going to redo it. So we have a name. The name is the selected coffee, and the cost is the coffee cost, and that's our new global data. And what we can do now is we can update the global state. So we have to have access to the set global data function. So we just destructure that out of our global context, set global data, and now we can overwrite the existing global state using the setter function to new global data. So that's just going to update our context. Now the second thing we have to do is obviously persist this to the internet, And what I might actually just do here is change this console.log so that we can see the new entry. So that's just going to be the timestamp and the selected coffee and the cost, which is the coffee cost. So now to persist the data in the Firebase data store, we're going to have to use some Firebase functions. So the first thing we do is we create a reference to wherever we're going to write. So I like to call that the user ref. And that is once again equal to the doc function, which needs to be imported from our Firebase Firestore. And in here, we pass in the database as we've done before. When we were reading, we have to make sure we import the database. And then we pass in the collection that we're writing to, which is the users collection, and then the user collection, and then the user ID specifically, because that's how we label the document that they're writing to. And so that is equal to the global user. So we have to access the global user. So we come up and we just destructure out the global user from our useAuth hook. And from within the global user, we can access the user ID. So that gives us the reference of the document that we're writing to. And now what we do is we say const response is equal to, and we await the setDoc function. Now that also needs to be imported, so we import setDoc from Firebase Firestore. And in here, we pass in a couple of things. First, we pass in the user ref, which is the reference to which we're writing. And then we pass in an object. Now what I'm going to do is actually recreate this new data. So it's just going to be the timestamp, and then we're just going to write the exact same stuff to it, just like that. So now we have an object that contains the timestamp key and the associated value, which is the information. Now, if we wrote it just like this, currently this would overwrite whatever data we had persisted, but Firebase is clever, so we can pass in a secondary argument down here where it's an object with a key that says merge, and we set that equal to a value of true. And then what that's going to do is, instead of overwriting our existing database, it's just going to merge our existing database with this new entry. Now the one other thing I want to do is just up here underneath the timestamp, I want to define a variable called const new data. And that's just equal to an object, specifically this object. And the reason I'm doing that is because now I can just write the new data to our local data, and I can do the exact same here instead of having to write it out twice. So now the new data is assigned to a timestamp, which is merged with our existing Firebase data, and we've also updated the global state to match. Now obviously this await is not happy, and that's because this form needs to be asynchronous. So if we just throw an async in front of this handle submit form, we should actually be good to go to set all of this information. So we can go ahead and try make that happen. We could add our very first entry. We could say it's an espresso. We could say it cost me $16.50. We could say I consumed it 2 hours ago and 15 minutes. Let's just open up the console to see if everything works. We are in fact logged in, so I would expect this to persist. And now I can add the entry. We can see that our global state was updated. Obviously it's still reading in the wrong information, but now we have local data, so we had expected to display. And if we come across to our database, our Firebase entry, and open up the Firestore database, we would now expect that entry to have been written to our database. So now in here we can see that originally we just had a demo entry. We have now a secondary document that is the user ID associated with my account, and we have our first entry, which is the key, which is the UTC time that it was submitted. We have the cost and the name, and that is successfully persisted. So now the last thing we need to do is obviously reset the form upon completion. So that's pretty simple. All we do down here is underneath where we submit all of this information. And to be fair, I might actually just throw it inside of a try catch block. So just underneath this stuff right here, underneath where our guard clauses, we're just going to create a try catch block. catch the error, console.log the error.message, and then I can throw all of this code inside of the try block, just for that extra security and error handling, super important. And now after everything is done, after the response, we can set selected coffee. What's the default value? It's probably null. Set selected coffee is null, so we'll set that to a default value of null. We'll set hour to 0, we'll set min to 0, and we'll set cost, coffee cost. What's the default value for that? Also 0. So that's just going to reset our entire form. Now, if I reload the page, we can see that our on-auth state change listened. We actually found user data, and did we console.log the user data? That could be kind of handy for the second. So if we come over to the use effect inside of our auth context, we should actually just console.log Firebase data. So what I'm going to do is throw this underneath and just comma separate it and throw on Firebase data onto the end so that we can actually see all the entries in our database. So now we refresh the page, we found the user data, and here it is right here. So that is absolutely brilliant. Now the last thing we have to do is come over to our history and just make sure that instead of reading in our fake data, we're reading in our global data. And so we're going to actually start off with the stats first. So essentially, everywhere we have this variable coffee consumption history, we're going to replace it with global data. So obviously the first thing we need to do is get global data from our context. We can say const global data is equal to call the use auth hook, which needs to be imported. That allows us to access the global data from within our global context. And now that we have global data, we can just chop and change all of these values wherever we have the coffee consumption history for global data. So let's go ahead and save that. And so now that we have added that entry, we can see that our active caffeine level is low. That's the active value considering the half-life of when I entered it. The daily caffeine is currently 63 milligrams. We've had one coffee. It cost us $16.50. And now we are good to come across to the history and just do the exact same thing. So just above the JSX, we have to import the global data from the use auth hook, which needs to be imported. And now when we map out coffee consumption history, we can just chop and change global data in all of those places. And so now if we scroll down, we can see we have one caffeine entry, and that was an espresso 2 hours and 10 minutes ago, and we're currently 46.64 milligrams out of 63 milligrams. Now if I go ahead and refresh that page, we see that we still have absolutely everything. It still looks great on a mobile device. So I could add a second entry, a double espresso. That's going to be $21 in a few years' time. I'm going to say I just had that right now. I'm going to add the entry. And now we have a moderate amount of caffeine leads to a noticeable stimulation. The daily caffeine has gone up. We've had 2 coffees. We've got the average cost, and we have that second entry. And obviously our little chart right there is working. The one thing I noticed that's not working is that this text should have updated, and that is within stats. And that is the little plaque card. So we've got the description. And this is the text right here. So what we have to do is change that text low inside of the H5 for some curly braces that just has the warning level. So now we have a warning level of moderate. And I think that looks absolutely wicked. Super pleased with that. And just like that, we have successfully created our coffee tracker. If I reload the page, we get a loading data state, and that is all there. If we bring it up onto a full screen or even a dark mode, it looks super cool as well. Once again, refresh the page. If I log out, everything's gone. If I sign in again, testemail@gmail.com, and submit that form, we authenticate, we load in all the data, and everything is still there. So with that all done, it is now time for us to deploy this application so that it is live on the internet. And the way that we are going to do that is by first up deploying it to GitHub, which means opening up our GitHub desktop. Now what we're going to do is come over to the repos, add a new repo, and add an existing repo. And we're going to select choose and find our React full course project and select caffeined. Now I'm going to click open. There's no repo here. I'm going to create a repo, initialize it with a readme.md. I don't know, is there currently a readme.md in here? There is indeed. So I'm going to override it. And the project description for this one is a coffee tracking app with React.JS, FantaCSS, and Firebase. And now we can go ahead and click Create Repo. And with that created, let's just come into the history, and you just want to double check that your .env file is not in here. Remember, we added it to the get ignore. You really just want to confirm that your .env is not in here. Otherwise, it will be committed to the internet. And now, since that's not in there, we can publish that repo. I'm going to make it public. Publish the repo to the internet. And now that is available for anyone to see. And with that on the internet, we can come over to Netlify. Once again, log into our account. We can click add a new site. We're going to import an existing project. We're going to be importing it from GitHub. Make sure we run all the necessary authentication checks. And now what we're going to do is scroll down. I don't have the app currently available, so I'm going to have to manually add it. So I'm going to come into these settings, scroll down, select the repos, and just look up caffeined. And I'm going to add that to the list, hit save, and now I should be able to look up caffeined inside of Netlify, select that project. It should automatically recognize it to be React. And what we're going to have to do in here, we're not quite ready to get that up and running. We're going to need to add some environment variables to this project. Now the way that works is you just need these to match your .env files exactly. So here I have my local .env files. I'm just going to copy the name of that key, paste the key in, and then I'm just going to copy the associated value across. And then obviously once you've added one, you need to do all of them. And then once that is done, we can go ahead and deploy the app. So I'm just going to add all my environment variables really quickly. And so now I have effectively added all of my environment variables. There's 6 of them to configure Firebase. I can go ahead and deploy caffeined just like that. And while it's deploying, we can go ahead and update the URL for that site. So to do that, we're going to come across to domain management. And inside here, we're going to click on this options and just edit the site name. And I'm going to steal the first caffeined version. This is obviously a unique ID, so you'll have to create your own sub version of that. I'm going to click save. Someone's already taken that. That's hilarious. So I'm going to call this instead caffeined-coffee tracker. And then save that project. Surely that one's not taken. And so that is available. And now if we come up to deploy, we can see that that has been published to the internet. And so we can click on that URL, open up our project. It starts off in dark mode. We can try add an entry. It asks us to log in. We should be able to use the emails and accounts that we used for development. So testemail@gmail.com. Submit the password, it's authenticating us, and now we are logged in and we have everything. We've got all of the information. We could create a new account, add some new entries, and we are absolutely good to go. And just like that, congratulations, you have officially finished project number 3 in our React full course. And that brings us to the closure of this excellent experience. Massive props to you guys for getting through the course. It's a huge effort to consume 8 hours worth of content. I hope you have enjoyed the experience. I hope you feel like you've learned a lot. I hope you're feeling more confident and comfortable developing applications with React. If you have enjoyed the course at this point, I would absolutely super appreciate it if you smash the like and subscribe buttons, and you also star the React full course repo on GitHub. Super helps to support the channel. And if you're looking for the next step in your development journey, be sure to check out the Learn to Code roadmap linked in the description down below. Anyway, thank you my friends for watching the video. Love to share this stuff with you, and I'll catch you in the next one. Peace. Learning to code? If so, be sure to check out the Learn to Code roadmap or dive straight in with these videos. That's a good one.